A very warm good morning to our eminent guest, Honorable Chairman Sir, Shri Sunil Sharma, Honorable Chief Mentor Sir, Dr. Sudhanshu Sir, Honorable President Ma'am, Dr. Ritu Gelotra, Honorable Registrar Sir, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, Coordinator of Center for Sustainable Development, faculty members, and all those who are present here from different institutions and countries. I, Priyanka Roy, welcome you all on behalf of Suresh Vihar University for the inaugural ceremony of one-day virtual international conference on Earth observation technology for environmental management. We are very delighted and eagerly looking forward to have you all involved in this quest of embracing knowledge. Now, on this thought, I would like to invite Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, to take forward today's event with a welcome address. Madam Shruti Kanga.
Okay, thank you, Priyanka. Good morning, everyone. It's a great pleasure for me to talk on the formal introduction about the university and the welcome of participants from all over the world in one-day virtual international conference on Earth observation technologies for environmental management. The Conference on Earth Observation Technologies for Environmental Management dedicated to bringing together a significant number of diverse presenters within a conference program. The program aims to bring together leading academic scientists, researchers, and research scholars to exchange and share their experiences and research results on all aspects of Earth observation technologies for environmental monitoring. It's also provide a premier interdisciplinary platform for researchers, participants, and educators to present and discuss the most recent innovations, trends, concerns, as well as practical challenges encountered and solutions adopted in the fields of Earth observation technology. About Suresh Vihar University, it is a non-profit autonomous private university located in Jaipur, Rajasthan, India. The university became first private university in Rajasthan to be awarded with NAC A grade by National Assessment and Accreditation Council. The university has portrayed into numerous other disciplines including engineering, pharmacy, management, hospitality, interdisciplinary and liberal studies, applied sciences and agriculture, journalism and arts, etc. Research and development in the university established with a goal to promote research in the country. Gyan Vihar has established about 12 research centers focusing in a wide range of research and development areas like climate change and water research, renewable and sustainable development, learning center with Google, ecosystem for innovation and entrepreneurship, training and research in automation with Wash, housekeeping and traveling, agriculture research, and sustainable development, etc. Center for Climate Change and Water Research at Suresh Vihar University aims to pursue the academic excellence in research, development, and training activities. It enhances the research and training capabilities of students, research scholars, and the faculties as well. Academic credibilities of Center for Climate Change and Water Research has already been proved by organizing different national, international conferences, webinars, workshops, seminars, and field exposures, industrial exposures and trainings and visits to the students very frequently. Center has collectively published around 120 research papers in various reputed journals of Web of Science, Scopus, UGC, etc. in the field in few last years. Center has also published total 35 edited and reference books with international publishers and many book chapters with more than 2,400 citations against the published research works. About the faculties, we have faculties in the center from IITs, NITs, Central Universities, Wadia Institute of Himalayan Geology, and various state universities working in the different fields like natural resource management, disaster management, water resources, forestry, agriculture, sustainable management, urban planning, and wasteland mapping, etc. So this is a brief about the university and the center and about the conference. With this, I'm welcoming all of you here in this platform and hope we will have a very uh, good time and informative sessions here. Now I'm handing over the things to Priyanka. Thank you.
Thank you, ma'am. Thank you for the information on the conference and the university. Now, on this note, I would like to invite Dr. Suraj Kumar Singh, Coordinator of Centers of Sustainable Development, to give a brief information of the conference. Sir?
A very good morning to Honorable Chairman, sir, Chief Mentor, sir, President, ma'am, uh, Registrar, sir, all the esteemed speakers and participants. It's my pleasure to welcome all the participants today for one-day virtual international conference on Earth Observation Technologies for Environmental Management 2021. I welcome all the eminent speakers and guests from all over the country, from different walks of the life. You have come here to share their knowledge and vast experience with the student community. The Center for Climate Change and Water Research is regularly conducting online conferences, seminar, workshop on digital platform in line with the social distancing norms due to COVID-19 pandemic. We are proud to announce that this conference has received an overwhelming response from all across the globe, ranging from academics to industries. List of few university. I'll be listing out only few universities named like in Institute of Geography, Romanian Academy, National Open University of Nigeria, NIRD, Fakir Mohar University, Ranchi University, Odisha School of Engineering, Tokyo City University, Annamalai University, Ministry of Urban Development and Land Records, National Institute of Technology, Silchar. Then you have got Patna University, then BHU Banaras Hindu University, JNU Jodhpur, University of Allahabad, Nigerian Defense Academy, Asian Institute of Technology, Thailand, University of Tasmania, JNU, Utkal University from Bhubaneswar. Then you have got Regional Remote Sensing Center, ISER Bhopal, Bombay State University of Nigeria, MNIT Allahabad, University of Kalyani, Tribhuvan University Nepal, Geological Survey of India, Indian Institute of Remote Sensing, Indira Gandhi National Tribal University, SEPT University, Central University of Jharkhand, HPU Shimla, Jadavpur University, Central University of Rajasthan. We have got also participation from Ajimji Premji University, MIT University, then Hamaya University, Ethiopia, Aligarh Muslim University, Mizoram University, Jamia Millia University. Then we have got Faculty of Geological Engineering, University of Zagreb, Croatia. And I have listed only few, near about we have got 400 registration against this conference. And there will be in this conference, there will be a plenty of knowledge enhancement activities such as invited talks, then selected paper presentation. We received near about 80 paper we received. We have published 47 papers, and out of that we have selected 15 papers that will be presented today in the afternoon session. We have got eminent speakers from all across the world. I'll be listing few of the names like Professor J.K. Garg, who is the governing body member, Wetland International South Asia, New Delhi. He was the former director, Center for Disaster Management, Indraprastha University. He'll be talking about use of geospatial science for wetlands restoration and management. Then we have got Professor Nitin Kumar Tripathi, who's the director, special degree program, School of Engineering and Technology, Asian Institute of Technology, Thailand. He'll be talking about climate anomalies and crop yield modeling in various basins of Thailand. Then with us, we have got Dr. L.K. Sharma from Department of Environmental Science, Central University of Rajasthan. He'll be talking the use of Earth observation technology for various kinds of environmental modelings. Then we have got Dr. Kriti Abhishek from Birla Institute of Technology. He'll be talking about wetland ecosystem using geospatial technology. Then we have got Dr. Praveen Kumar Rai from KMC Language University, Lucknow. He'll be talking about use of space technology in disaster urban planning. Then we have got Dr. Saliha Jamal from Aligarh Muslim University, She'll be talking about way forward in environmental research, role of remote sensing and GIS, and last not the least, Mahila from Romania. She'll be talking about Romanian rural space changes in the dynamics, demographic structures over 1992 to 2020 period. The main outcome of this conference is to come up with the national and international framework for the education system in the future of Earth observation technologies for environmental management. The crux of this conference will be use of digital technologies such as artificial intelligence, drone technology for monitoring and mapping of various resources, whether we are talking about climate resource, disaster risk reduction, biodiversity modeling. Here in this conference, the government and the private sectors will be talking about the benefits and how this technology can be used for the sustainability and livelihood management. And we hope that this one day conference will be helpful for the students for expanding their mental horizons and will help the Indian education system to adopt the best of education system in the field of remote sensing. I request all the students from across the country to make this one day international conference a huge success. With this, I'll hand over my mic to Miss Priyanka. Miss Priyanka, please.
Yeah. Thank you, sir. Thank you for the brief information of the international conference today we are holding. Now, on this note, I would like to give a brief introduction about our Honorable Chief Mentor, Dr. Sudhanshu, sir. He has to his credit an extensive research paper regarding distinctive environmental concerns and issues. He has 14 years of rich experience as a great administrator with a diversified vision. He is a great thinker, a great motivator with an incorrigible capacity of work and multitasking abilities. Under his competent leadership, Gyan University has developed by leap with excellence of being identified and recognized as one of the foremost technical institute of the country. He devoted all his time, effort, and energy in constantly planning on how to boost and develop every facet of the university, be it academics, which is his prime grit and concern, or infrastructure, or campus facility, or placement, or any other aspect that affects the smooth running of the growth of the university. He always finds spare time juncture for his commitment towards his social obligation. He has been actively and effectively involved with various social political organizations for past 20 years. Now, on this note, I would like to invite our Honorable Chief Mentor, Sir Dr. Sudhanshu, to address this conference. Sir, you are most welcome, sir.
Thank you, Priyanka.
Thank you, sir.
Most esteemed Chairman of Gyan University, Shri Sunil Sharma Sahab, our President, Dr. Ritu Gilhotra ma'am, all the dignitaries of SGVU, all the participant universities, and my dear colleagues. This is really a matter of great pleasure for all of us during this time when the whole world was affected with the pandemic and the corona has spread like anything, and we all had suffered a lot. Some of our centers dedicated to climate change, sustainable development goals, and few other, they have increased their activities, whatever the method they got, what are the opportunities they got, especially when the online method came into the existence, or it was recognized by the people. Our activities were increased like anything, and I can say this is kind of vardhan to the researchers now they can interact each other without spending much money. And this is really something like great gift of this corona epidemic to the world, to the globe. And human being is one kind of the thing which always get benefit of every epidemic. We come out from everything. Previously, in the thousands of the years, whenever we have faced such situations, always we were the winners. And the now the interaction level which we have developed, the whole globe, uh, we have opened the online platforms. We are interacting people from one and other place. Like just now, Dr. Suraj Singh was describing the list of the participants. I believe there are participants available in this one-day conference from all 7 continents. Either it is the Taiwan, Japan, or the Romania, or the Latin American countries. People are there. So certainly, I can say this is kind of vardhan to the researchers. And I congratulate to all the researchers that we must try to organize such conferences, such workshops, one and again in a regular way, so that we can interact each other, we can share our ideas, we can share our achievements to each other, and then after getting this, we can certainly do some better tasks what we have done earlier. I just want to congratulate Center for Climate Change and Water Research for their this initiation. And I remember in the last few months, I believe this is a now a tradition, become a tradition, organizing such big conferences, big workshops with the people, inviting people, and then sharing the ideas. So certainly, this is a great deed Dr. Shruti and her team has done since last 2 years. I congratulate whole team, and I believe you will not stop here, because sky is the limit, and please move ahead continuously, regularly. And I'm also happy that some other centers of Gyanvihar University, like our Center of Research for Sustainable Development Goals, is again doing good efforts. Our Center for Renewable Energy and Energy Storage, and few more who are working in the similar kind of activities. I'm not putting all the names of the centers, because some are related with some other fields. But I have observed these days, I remember how the past decades are very much important when the technology has turned into a different era of the life. Uh, I I know this very well. Before 2 decades, we were not having this kind of technologies about which we are talking here. But now whole scene is changed in these 2 decades. And after this IT revolution, and then this recent induction of AI has changed the whole scenario. And I think the challenges we had faced in the last centuries related to sustainable development, and we were fighting without any tool, we were fighting without any proper direction. But after entering these technologies, IT and artificial intelligence kind of thing, machine learning, deep learning, certainly now this is the time when we can say कि we are in the position to contribute something. Maybe before this, we were able to just observe. Like you were talking about there are two things. One is the observation, other one is apply our knowledge to improve the situation. So I remember it before these technologies came, we people were try to collect the data with the help of the field work. I myself has devoted more than 100 days for the field work to get the data from the various areas. But certainly that was very tedious. That was very tiresome. And then after, you were not in position to get all those things with you in your laboratory because there were limitations. But as of now, when the technology has entered into this field, and very beautifully, uh, people mainly who are working in the earth science, they have started using these technologies. The induction of these new technologies has now changed the whole scenario in very different way. So I just wish my centers, my university, and the other people should also start using learning these new technologies so that we can put more effect on our learning and on our contribution for especially achieving the sustainable development goals. We have faced that, especially India, uh, still the poverty and lot many other things are there, which has not allow us to move ahead since a long. But now, after adding these technologies, Earth observation data, when it is with us, we can fight against poverty in a better way. Certainly, this will be something great if we will enter into this field with more pace, with more intelligence, with more resources, with more. We have to develop our capacity in a for like a new era. I know like center is working hard for this, but again I told that there is no limit of this. We have to work hard again. I welcome all participants, universities, and the institutions across the globe. They are now joining such events. Certainly, we are always beneficiary for the main beneficiary when you people are participating with us. Our students are getting lot of knowledge, lot of learning from all of you, and I believe you are also getting knowledge from other participants. So please, whenever I wish whenever we invite you, please join us, and whenever you organize such events, we love to join your events. And I always welcome each and every participant. We are from the land of Rajasthan. This is really a place where we say Atithi Devo Bhave. So all participants are our Atithi, and they are just like the God for us. So I just want कि जो ये देव हैं, जो देवता हैं, इनका आशीर्वाद, इनका प्यार, इनका सम्मान should be always with our center and our university. We know that this increasing the time, like initially, I believe 20 years before or 25 years before, this remote sensing term were into the utility when people are talking about data from remote sensing. But that time it was not that much very effective. This was 70s and 80s when few satellites people have able to launch, and very small data was there. But nowadays it is really very easy for each and everyone, and I believe we have discussed at our center few months back, and there was a commitment of my centers that soon we will also going to launch a earth data satellite. I just want to just rememorize Dr. Shruti Kanga, Dr. Suraj Singh, and other participants, as well as our president, that we have self-committed that we have to launch our own satellite in year 2024. That is for the climate change. So the relevance of such events when you are talking about like effects of these technologies on environment management. I also want to add agriculture and poverty and few other topics into your goal while you are planning for the satellite. And I also want to like inform all of the participants that we are also working with some companies who are into the drone technology. And the purpose of drone technologies are just to collect the Earth observation data, especially focusing climate change, environment management, all these things. So certainly, in future, after a year or two, if we will able to launch our own satellite, I think this will be really something great thing for us. Please take help of other departments of the university. And I also wish if we can open a Indian chapter of GEO. It's a intergovernmental organization of UN. So if Ganviar is able to involve into this, or Ganviar is try to get a membership of GEO, this will be something a better situation for us to represent these important issues on the platform. Similarly, we can also create a platform within India with all these participants and other stakeholders who are into Earth observation technology, so that we can increase these technologies, their effect, their utility in a better way. My best wishes to the organizers, to all the participants, to each and everyone, and my students as well, for this successful event of this one-day virtual conference on Earth observation technology. And my best wishes to all of you. Thank you. Thanks a lot.
Thank you, sir. Thank you for such insightful words and motivating us to move forward in the time of COVID and lockdown, and also showing us new path of how to take way forward. Now, on this note, I would like to take a brief moment of introducing our Honorable Chairman, Shri Sunil Sharma, sir. Apart from being a chairman of Gyan Vihar University, he is also vice president of Satya Swadharth Samiti and various non-government organizations. And despite the facet of cumbersome task of administrating busy university work, uh, most of the time he is also dedicated his effort in social commitment as a prominent and responsible citizen of the state of Rajasthan. He has emerged as an invaluable and responsible asset of being a rare resource person for value based and ethical leadership. He is predilections of reading, writing, appetite of various disciplines, and made him a virtual potpourri of information covering wide spectrum of topics ranging from history, economics, metaphysics, Indian philosophy, uh, Indian ideologies, and many more. Now, on this note, I would like to invite our Honorable Chairman, Sir Shri Sunil Sharma, to say a few words on today's event. You are most welcome, sir.
Thank you, Priyanka. Thank you very much. Uh, Most Honorable Dr. Sudhanshu ji, Chief Mentor, Ganviar University, Professor Dr. Ritu Gulhotra ji, the organizer of the today's conference, Dr. Shruti, Dr. Suraj Kumar, and all other associates. First of all, as the chairman of the university, let me welcome every participant who is participating in this beautiful conference. Dear colleagues, the basic object of any university is to create knowledge. And whatsoever knowledge you have created, that should be shared among the peer groups. And that this is the only way how the knowledge can be evolved. So I really congratulate the organizers that they have really organizing such a extraordinary conference where the most alarming thing, like the environment. Reason is being everybody is talking about the environment, and it's like if the things are not going to be under control, within 2 decades, the whole this beautiful planet will be confronting a great catastrophe. So that's the thing. But dear colleagues, the thing is this: that since the inception of Homo sapiens on this beautiful planet, we are like observing a lot of things. The reason is being mother, the nature has nature was very much miser, giving us. Neither we are having power nor we are having other things to save ourselves. But we were having simply one thing, and that was instinct to live. We simply want to live. Hence, a very different thing got evolved, and that is our mind. And the evolution of mind, if we talk about how the mind got evolved, so 2 things were there. One thing, the instinct to live, and another thing to observe. The inquisitiveness which we got, and that inquisitiveness has really make us master of this planet. But the moment we become master of the planet, lot of like no doubt, we have mastered this planet through different mean of technologies that like the way the living standards are increasing. But at the same time, all these things has done a very difficult situation for this planet, like unbatched or say unfettered exploitation of our resources that has really made a very vulnerable situation. So now the thing is this, how we can get rid of with all these problems. And for getting rid of this problem, the technology is the only answer. That okay, can we really go for the sustainable development or not? So for the sustainable development, like whatever the like, if we really have to define that what is the sustainable development, then it's really very tough thing to like define that okay, this is sustainable development. But the only one thing which is very much important, that is to hand over this beautiful planet to our progenies in a better situation that we got from our forefathers. So this is the only criteria which we can think that okay, this way we can really save this earth. So like saving the earth, and then say environment management, because these 2 things are synonym to each other. Like when we are talking about saving the earth, does mean the environment management. And now the environment management, like a lot of threats are there, like the deforestation is a very big threat. Then pollution is a very big threat. And the again unfettered urbanization, unplanned urbanization, and every year we are losing a lot of arable agricultural land. Like we are losing forest land, we are losing arable land, and at the same time the population is increasing like anything. So for every policy maker, so like either he's a policy maker at United Nations level, or a policymaker who is controlling any nation, there's a big challenge that how to feed a big population, how to give them a perfect habitation. So these all things are really very a big problem. So now how to get it done, how to plan these things, this is a big challenge. And the only answer for this is that is the earth observation. Like we have to observe the potential of earth, what it can give. Like Mahatma Gandhi once told a very beautiful phrase, that Mother Earth can give all things to fulfill our needs, but we really turned greedy. So like how to check that greed, that is a really very big problem. And the only answer to check this greed is the earth observation. All the time we have to keep observing the earth and its limitation. That again we have to understand the limitation, because the geographical area of earth is limited one. You don't have any sort of elasticity. Maybe possible the population increasing every year, but at the same time the geographical area of earth is limited. Now the arable land is limited, deforestation is limited. So like then you have, if you really want to exploit those things in such a unplanned manner, then believe on me, at the initial like at the initial stage of my speech, I spoke one thing, that we have turned master of the earth, then we will become destroyer of the earth. So like we do not want to become destroyer of the earth. Rather than we should confine, we should be simply the master of the earth, not simply master of the earth, but say that we should specify our another role, and that is servant of this earth, the server of this earth. And how we can do that thing, and that the first step goes from the observation of the earth. We are really lucky enough that since the Sputnik's uh, reach on the earth, orbit, more than 1800 satellites has been gone so far. Out of these 1800 satellites, hundreds of satellites are still active. And every year, most of the nation, like even India, is sending a lot of satellites. So we have extraordinary data, we have all things to analyze, and that thing should be analyzed. This is not the thing that our generation, the first generation, which is observing all the thing. Since 5,000 years time, our forefathers were also observing with their limited resources. Even in the temple of Babylonia or in the temple of Egypt, a lot of priests were there who were observing all the things, the changes in the climate, the seasons and all the things. Though their purpose was very limited, that they want to have good crops. So like how to evolve a good crop cycle, that was their field of studies. And another thing, the most of the civilization was established on the bank of rivers. So every year's flood was a big problem for them. So they also want to observe that, okay, what's the way out of, or what's the cycle of the flooding. So for that, they were doing observation through their very meager means. But then after evolution of technology, evolution of industrial development, other things like now artificial intelligence is there, and a lot of extraordinary technologies are there. So the tool of observation which we are having, that is really enormous. So that should be utilized for the welfare of for the humanity. That should be utilized for the welfare of this earth. And the most important thing, that is a protector of this planet, is a server of this planet, is a servant of this planet. We have to work very hard. Otherwise, believe on me, within 2 decades, we are going to invite extraordinary catastrophe, and our progenies will never forgive us for such misdeed. So, this is the time when we should sit together all across the globe, like those people who think that they are responsible, the responsible person, responsible organization, responsible government, responsible university, they should come forward, they should sit together, and then they should resolve for one thing, that, okay, uh, the resources which we are having, that we will utilize for the welfare of this Mother Earth, for the welfare of this beautiful planet. And if that thing is being done, then believe on me, the relevance of such conferences really become extraordinary. So the basic relevance of this conference is to share knowledge, the shared data, and for what? For the welfare of humanity at large, for the welfare of this Mother Earth at large. So I'm very much confident that under the leadership of Dr. Sudhanshu, Shruti, and Suraj Kumar Singh, this event is going to be extraordinary, successful event, and the outcome of this conference will be really it's a in a way uh, a transforming one in the sphere of the knowledge. So let me give you all the best, and let me I'm privileged to announce this conference open. I'm very much confident this one day, like the next 8 or 7 hours will be a transforming hours of the life of the participants. I'm very much confident, and thank you very much for inviting me, and all the best wishes. Thank you very much.
Thank you, sir. Thank you for such insightful words and motivating and giving your blessing for today's event. Now, I would like to call for the conference souvenir to be presented. So this is our conference souvenir cover page, abstract cover page. This is the message from our uh, president sir. Sorry, this is message from our chairman sir and chief mentor sir, president ma'am, and these are the committee members, organizing committee members. And next will be the chapters that we have compiled over for so many papers that we have received.
Congratulations for presenting such a beautiful souvenir.
Thank you,
Congratulations.
sir. Thank you, sir. So now taking forward today's course. So this is all the papers, an abstract of the papers. And this is the end page of the souvenir. Now, taking forward the course of our conference, it is time to introduce our first keynote speaker of the day. Professor J.K. Garg has more than 44 years of wide range of professional experience in the field of geospatial technology for ecosystem analysis and monitoring, especially wetland in India. He started his professional career in 1976 in Space Application Center, Indian Space Research Organization, Ahmedabad. He joined Indraprastha University in the year 2008. He was Dean University School of Environmental Management and Director of Center for Disaster Management Studies in Guru Gobind Singh Indraprastha University, New Delhi. He was also associated with the Rai School of Advanced Study as a senior fellow during March 2019 to October 2020. Professor Garg has pioneered the use of remote sensing and GIS technique for environmental application in India. He is a well known for his work in conceptualizing and implementing first scientific inventories of wetland in India using remote sensing and satellite data. His work on wetland led to spurt in use of geospatial science for wetland management. He is nationally and internationally regarded for initiating use of geospatial science for wetland management. Professor Garg has worked on many projects related to bioresources and environment, disaster management, ecosystem rehabilitation, and restoration. He is currently associated with Wetland International South Asia. He has more than 180 research paper publications in national and international reputed journals. On this note, I would like to invite Professor J.K. Garg to take forward today's event. Sir, you are most welcome. Sir, unmute, sir.
Thank you, Priyanka, for nicely introducing.
Thank you, sir.
Let me first congratulate Gyan Vihar University for organizing such a wonderful topic, this webinar, because this decade, beginning March 2020, I hope I am able to share my
Yes, sir, your screen is shared, sir.
Open your slides, sir.
now I can be seen because I don't see myself.
So the slide, we cannot see it yet, sir. Your screen has been shared, but the slide is not open, sir.
Sir, minimize it and open it Sir, minimize your screen and open the slide.
I will do again sharing and then again share. This. Now there are three things: your entire screen, window, a tab. So I
Priyanka,
do
So,
help.
window. No?
so the tab that will only open the specific tab that you want to open.
Share a Chrome tab. No, screen is not coming. My PowerPoint is not coming somehow. So I think it will be window if I'm not mistaken.
Yes, sir, a window.
Window again, the same thing. I'm not able to.
So you have to open your presentation. It has to be keep running. Your presentation has to keep running. Then you can select the a window, and it will be automatically presented on the screen.
Actually, my presentation is open. Now I go to window, Priyanka.
Yes, sir.
Window. Then it is again showing the screen. Share an application window, Chrome.
Sir, please share entire screen.
Sir,
Please
kindly
share.
share entire screen and proceed normally as you are working normally on your computer, sir.
Then this thing.
Kindly
Please share.
please click on entire screen and share. In the bottom side, there will be option of share. After
That's
clicking,
what I have done. Actually.
yeah,
Your entire screen.
yeah, and then share.
Share. This is not clicking.
Entire screen, click on entire screen and then share option will be enabled, sir.
Oh, that was done. I'm sorry to present your entire screen, a window, a tab. So I am doing entire screen, but it is not taking my presentation.
Sir, please mail us. Please mail us.
It is a big file.
Okay, that's why, sir, I asked you in the morning itself if it will be easier
Okay,
for us. If
let
you
me
could
try
have
again.
shared us, we could have shared it.
Okay, let me try again.
Sir, anyway, without presentation also we can hear you. No issues.
No. I want to show the screen also.
Okay. Yeah, now we can see.
Yes, sir. Now, sir, please open your presentation slide, sir. Now it will be visible for us.
Visible now? Okay. Meet Google is sharing a window. I don't know how to. What should I do now?
Now just open your PPT, sir. Where you have your PPT, just open your PPT. It will be visible to us.
Is it visible now? PPT is open.
Okay, no,
No, sir.
no, sir, it's not.
Your
Oh my.
Chrome is visible, sir. Your Google Chrome is visible, not your PPT.
Minimize the browser.
Chrome I will close. Chrome is closed now. There is only.
Sir, why this thing is happening? Because you haven't your entire screen shared, sir. You have shared only one tab, which is Google Chrome. The moment you closed your Google Chrome, the screen is gone, sir. The shared screen is gone. So you need to, sir, share your entire screen instead of a particular tab.
Actually, that's what I'm doing, but it is your entire screen I am sharing. Now this screen is there, but presentation is. entire screen is presented.
Sir, now could you please open your
No.
PPT just without doing anything? Just click on your PowerPoint and it will open, sir.
Yes, sir.
Yes.
Now it is visible, sir.
Okay, so nice. Okay, I'm so sorry to make you
No
waiting.
issue. No issue, sir.
But I can't see you people anyway. Uh, as has been told by Ms. Priyanka that the topic of my talk is geospatial sciences for wetland conservation and management, restoration and management. Actually, you may be knowing also that this decade is for restoration of wetlands. And wetlands are very important. Basically, if we go by the definition of Ramsar Convention, all water masses excluding part of the ocean which is more than 6 meter deep come under wetlands. And they provide us so many services, but many of the wetlands have been lost, many are degraded, and it has become a serious problem to survive on this planet. So my talk is centered around what are wetlands, because some of you may not be fully familiar with what are wetlands. And there is International Convention on Wetlands, which was the first international convention on any ecosystem. Then what are wetland components and characteristics? Then what are the ecosystem services, threats, and how to rehabilitate wetlands and restore them using remote sensing and GIS. That will be my main topic. Now, if you see this picture of the Earth globe taken from a satellite, mostly it is water. It is seawater basically. More than 70% of the water of the land mass is sea, and in fact, one report says that about 97% of the Earth is covered by water. Then we have very less water which is available for our use. Most of it is locked in glaciers, snow, and permafrost. And we have very little water which we can make use of for our day-to-day requirements, which is available in lakes and rivers, and to an extent, groundwater. Now, what are wetlands? If you go by the definition or scientific definition, they are basically low-lying areas, and they are the transitional areas between terrestrial ecosystems and deep water aquatic ecosystems. They can be natural, as Sambar Lake in Rajasthan, as you have seen, which is a Ramsar site, or they can be man-made like Kevla Dev National Park, which is also International Heritage Site and Ramsar Site. They can be coastal or inland, and many floodplains, swamps, marshes, mangroves, deltas, and lakes are some types of wetlands. And technically, a paddy farm is also a wetland, and they can be freshwater, saltwater, or brackish water in nature. Now, these are this is the definition of wetland which India is following, and India is following Ramsar definition, which states that submerged or water saturated lands, both natural and man-made, permanent or temporary, with water that is static, means lentic ecosystems, or flowing like rivers or lotic ecosystems, brackish or salt, including areas of marine water, the depth of which does not exceed 6 meters, as I was mentioning earlier. But it does include, suppose there is a coastal area, coastal wetland is there, and within the wetland, if more than 6 meter deep water is available, then also it will form part of a wetland. Now, many of you may be knowing that there are 5 types of wetland systems. There can be marine, which include like your rocky shores and coral reefs. It can be estuaries like deltas or tidal marshes and mangrove swamps like Sundarbans. Lacustrines like lakes, which pertains to lakes, and riverine means those wetlands which occur along the rivers and streams like oxbow lakes and cut-off meanders, and floodplains. And palestrine means marshy areas, marshes, swamps, and bogs. Actually, there is a very slight difference between marsh and swamps. Marsh is that type of wetland which is dominated by herbaceous vegetation, and swamps, just like mangrove swamps, they are dominated by trees. And bogs, we have some sphagnum, etc. Now, just to give a brief introduction, recently we have added 4 more sites to the Ramsar list. We have 46 Ramsar sites in India, and 2 of them are in Rajasthan, which are very old. Sambar Lake and Bhartpur, they are there from the first 6 wetlands which were under Ramsar Convention before 1990. And recently, as I mentioned, we have added 4 more, 2 in Gujarat and 2 in Haryana. And this year is the 50th anniversary of Ramsar Convention, and there are 171 contracting parties, or you can say countries, and number of Ramsar sites as of today are 2430, which have a surface area of 254,611,076 hectare. In fact, Chilka was the first Ramsar site in India to be designated, which also happens to be the largest lagoon in Asia. Now, these are some of the pictures you may be familiar with. We have marshes, and in the center you see a ring-like structure. It is part of Loktak Lake, which occurs in the state of Manipur, and it is the only Ramsar site, or it is the only abode of dancing deer or sangi deer or service LD in the world. And then we have various types of lakes are there. This is in the center. We have a swamp is there. And some man-made wetlands are also there. Like this, you have some barrages or reservoirs or some types of constructed things for salt making or such things. And then you have paddy. These are some of the coastal wetlands. On your right side, you have mangroves, then you have coral reefs are also there, and then rocky shores also. All these things constitute wetlands. Again, you can see coastal wetlands, mangroves are there. This is coastal marsh, which is herbaceous in nature. It is a beach, and then again, we have rocky coastline. Now you know very well that wetlands are very, very useful to us. They are not only source of livelihood, but they provide us water security, food security, very good for recreation, DRR, ecotourism, climate change mitigation, and disease control. In fact, whatever we are facing, if wetlands are not there, and this year there has been a drought in many parts of the country. If wetlands are there, at least we'll keep on getting drinking water. Now, you also know that, from 2005 Millennium Ecosystem Assessment, there are 4 types of ecosystem services. Provisioning services, we get direct water, food, fodder, etc. Then regulating services like flood, water purification, climate moderation, disease control, etc. from wetlands. And we have cultural or aesthetic services like religious, spiritual, tourism, recreation, educational, cultural, heritage, etc. Actually, wetlands are the laboratory to study ecology. But we have to keep one thing in mind, that all these services are possible if we have supporting services like nutrient cycling, soil formation, biodiversity, structural components of the wetlands, primary productivity and habitat, etc. And if they are not there, then we'll not get any ecosystem service. Then when we are doing restoration or conservation and management of wetlands, the problem is that we don't have water quality data for many of the wetlands. And even if it is available, it is very sparse. Then data on biodiversity, which forms the base of the ecosystem, is not available or seldom available. And even if it is available, then time series data is not available. And whatever data we have, there will be data latency of 5 years. And many of us, especially in our universities and government organizations, we don't want to share our data. And that is a very big problem. Now, when these things are there, when we don't have high quality data, then how to make informed decision for scientific management and restoration of wetlands. And there comes our knowledge of geospatial sciences. Now, this is the diagram which I have made to show that what all a wetland will constitute. Normally, people think that wetland is water mass, but it does include marshy areas or other, you can say some if islands are there or islands are there. Any wetland is conditioned by the climate and geomorphology, but it is characterized by the hydrology, which is the driving force. And if there is no water, there will not be any wetland per se and no services. So what is important for us to study is that wetland hydrology and what are the things which are existing within the catchment, within the wetland, including plants, phytoplanktons, animals, and microbes, etc. But one thing also we have to keep in mind that if we have to do wetland restoration and management, then we have to treat its catchment and its integrity intact. Otherwise, short-term gains, suppose we do some activity for any wetland per se, then it will not survive and will not be able to get sustainable benefits from the wetlands, or there will not be any sustainable development as such. Now, these are the threats which most of you know that, especially in India, that urbanization and land use changes, conversion to agriculture. In fact, after independence, there was a mad rush to convert many of our low-lying areas into agriculture. Maybe that was required at that time. Then hydrological alterations like making of dams, etc., though they may be useful for flood control and irrigation, but they have ruined many of the wetlands, especially in the Indo-Gangetic plains. Water quality, we are responsible for it. We throw our sewage, we throw our industrial effluents into the lakes and rivers without any kind of treatment. And eutrophication or enrichment of nutrients for inland wetlands, it is basically phosphate and other nutrients, but coastal areas, nitrates are the limiting factors. Then invasive species like water hyacinth and many other species. And nowadays, recently, global climate change because there are issues with rainfall, precipitation, etc. Now, we have lost 50% of the wetlands globally. I will not go into the detail because of limitations of time. In the past 2 decades, 30% of mangroves have disappeared, and some countries have lost up to 80%. It is Millennium Ecosystem Assessment Report which says. Now, 20% of our coral reefs are destroyed, and 24% of the remaining reefs are under imminent risk of collapse through bleaching, etc. And as far as India is concerned, there are reports that we have lost about 50%, but a study done by Wetland International South Asia in 22 cities shows that Mumbai has lost the maximum number of wetlands, 71%. Ahmedabad 57, Bangalore is 56%, and so on and so forth, using satellite data. Now, this is a diagram which is very popular, and most of you, those who are dealing with ecosystem studies and restoration, they know it, that any original ecosystem will have high species complexity and species diversity, and most of its ecosystem processes like photosynthesis, nutrient cycling, etc., they will be in place. And when any ecosystem gets degraded, it loses its structural complexity. And you can see at the bottom it comes, if you know, this blank small circle, and then we have to rehabilitate, means we start getting many of the ecosystem services from the wetlands, but restoration is to bring the wetland to its pristine condition, which is not possible because we don't know even what was the pristine condition. So our aim should be to rehabilitate and restore our ecosystem as far as it is possible, and then get various benefits. Now, what are the things which are required? In fact, this is the diagram which I've tried to create. And one thing we have to keep in mind, that we have to follow landscape approach, which includes not only the wetland per se, but its catchment as well, as we have seen. And you can see there are 3 boxes on the top: hydrology, water quality, biodiversity, structural component dynamics, means what are the habitat types. Basically, you can see within the wetland, they are very important, including invasive species, and nature of land use, and anthropogenic stressors like industry, urbanization, etc. Besides geophysical setting, as I mentioned earlier, climate and geomorphology. And we have to keep one thing in mind, that people are very important. If any activity we do, and most of the people feel that it is government activity, but no, until unless we are able to make it people's activity, and that's what we are trying to do now through Wetland International South Asia and WWF, that we have started making wetland mitra, in every village or every pond, wherever they are there, and they are the people who will teach other people not to degrade the wetlands or lose the wetlands. And all these three things are very important for wetland integrity and catchment integrity. And based on these things, we have to set our objectives and then go for making rehabilitation and restoration plan, and subsequently implementation plan. And actually, as many of you may be knowing, that this plan has to be adaptive in nature, because we have to monitor it continuously. Suppose some changes are required, we have to do it. We have to keep one thing in mind, that any restoration plan is not sacrosanct. We may have to make mid-term correction or mid-term changes. Now, since this symposium or webinar is for use of geospatial techniques, I am presuming that all these things are known to you, just like our satellite data is there. We have too many satellites. Unfortunately, we lost our Earth observation satellite. Otherwise, from geospatial height, we would have got 50-meter spatial resolution satellite data, which continuously monitors our natural resources. Presently, we have ResourceSat, which has 56 meter, 23 meter, and 5.8 meter spatial resolution sensors on board, and we are getting data from them. And we have our Indian regional national this thing, or you can say our GPS on GPS, Navik, and we have GIS. Besides these 3 things, we have to keep one thing in mind, that domain knowledge or the subject knowledge is very important. if we don't have the subject knowledge on ecology or concern, then we'll not be able to do any conservation or management. And you have to keep one thing in mind that satellites provide us synoptic data. They are multispectral in character, means we not only see in visible light, but we see in various parts of it like blue, green, red, near infrared, shortwave infrared, thermal infrared, etc., and microwave region, which is more than 30 millimeter satellite data. And repetitivity, if we have to do using conventional methods, it is very difficult to get the data time and again. And using satellites, it is possible to get information about our natural resources, including wetlands, day, night, and all weather. And there is a famous jargon that remote sensing is the data providing technology, and GIS is data integrating technology. Now, when we talk of rehabilitation and restoration of wetlands, actually there are many issues. Inventory may be required at the national level, the type of inventory which Ms. Priyanka was mentioning, that it has been done at the national level. First inventory was done in 1998 based on satellite data of 92-93. Then we have had in-house inventory in Space Application Center in 2005. Now 2010-11, it was now whatever documents you get on the internet, they are for 2010 and 11, because in 1998 GIS has not matured, so those things are not available in GIS format. And now this monitoring is going on. What are the changes which have taken place from 2010-11? This thing is going on. And besides this inventory, we have to keep one thing in mind. I can tell you about Delhi, that using satellite data inventory, what SAC has done, that only about 300 odd wetlands were there. But now Delhi Wetland Authority, of which I am also a technical member, based on field data, about 1,000 wetlands or water bodies have been identified. And why it is so? Because whatever national inventories are there, they are just indicative. But if we have to do rehabilitation, we have to go further, down, and we have to use very high spatial resolution satellite data like Cartosat, etc., through which we can get even 25 square meter or 50 square meter wetlands. And then we have to study its catchment also, besides the integrity of the wetland based on physical, chemical, and biological parameters, and catchment also its buffer zone, area of influence. All these things are going on, and now Ministry of Environment has taken steps, and every you can say state in the country, or rather most of the states have now wetland authority in place, including Rajasthan. And then we have to go for wetland restoration, and you can see that what are the scales which are required. Now, as I mentioned earlier, that the catchment is very important for restoration and rehabilitation of any wetland, and this wetland integrity, which includes its water quality, biodiversity, structural component, etc., is conditioned by catchment integrity, basically which pertains to its land use and what our activities are taking place in the catchment, like industry, urbanization, etc., in addition to geophysical setting like lithology, landform, slopes, etc. So these are the information needs which are amenable to remote sensing. I will not go into the detail because time does not permit, but there are various information which we can get through remote sensing, like spatial information, as I mentioned, inventory and monitoring structural components, aquatic weed infestation, water quality, especially chlorophyll and turbidity, etc., thermal pollution, which we can get through from satellite data, habitat diversity and fragmentation of the wetland habitat, as well as catchment habitat, uh, catchment characteristics, and then nowadays it is possible to make action plans for rehabilitation, restoration, and conservation in GIS. And now you know all these things are available or possible at all the scales. So this you may be knowing, as far as India is concerned, we are the leaders as far as use of satellite data is concerned for national development. And India is very fortunate that we have satellite data on, which can be used at all the scales, from 1 million to even 1,500 or larger scales. And as I was mentioning earlier, that on 1:50,000 scale, we have the smallest wetland which can be mapped is 2.25 hectare, and that is very large. But if we have to do conserve our all resources, then our various wetland authorities have to go for delineation and mapping of smaller wetlands. And fortunately, we have satellite data, cartosat, two type of data, which through the spatial resolution of which is 42 centimeter. Any government department anywhere in the world, we have highest resolution. And on the same platform, we have the same, different resolution of 56 meter, 23 meter, and 5.8 meter, which is nowhere available. Now let us talk of remote sensing of wetlands. And as you can see, there are various graphs. You can see these are based on the field data, which some of my students have done this work for Vindavas wetland, which is now a Ramsar site declared in Rajasthan. And you can see that it is possible to delineate various spaces using field-based hyperspectral remote sensing. And unfortunately, if this satellite was there, which was launched, so it also had hyperspectral sensors, so it would have been possible to do it, especially for the larger wetlands. And water quality, especially turbidity, chlorophyll, it is possible, and trophic state index using satellite data. Time limitations, I cannot go into details. Now, the first thing in any restoration activity is to delineate the wetlands, and remote sensing plays a very big role. Normally, if we go to the field, then we have to make use of presence or absence of facultative or obligate type of aquatic vegetation that is required. But to do a good delineation, we have to make use of satellite data. There are various indices which are used, like normalized difference, vegetation index, normalized difference, water index, and various ratios, etc. Screen digitization, we can delineate and do accuracy assessment. This is very important when we are doing any restoration activity, that we have to make use of satellite data. Otherwise, it is not possible to have a very good delineation of the wetland, and we have to make use of both the things. This is our national wetland classification system, which we developed before, based on 92, 93 data. Unfortunately, at that time, there was no even scientific wetland classification system. So that's what we had developed. We have classified wetland into two: inland and coastal wetland, inland and human-made, and for inland wetlands as well as for coastal wetlands similarly. And these are various classes. I will consequently, show you in various images these things. Now these are some of the images which can be seen using satellite data. Lakes you can see, and within the lake, the first on the left side is Nurse Rover in Gujarat, which is again a Ramsar site. Then you can see Oxbow Lake, and on high altitude wetland, what you see on your the third image on the left top is there are two Ramsar sites. A deep blue color or blackish color is Somrari, and upper one is Sokhar, which was the 42nd Ramsar site in the country. Then we have riverine or waterlogged areas or reservoirs, including their aquatic vegetation, and barrage, which is Okhla Bird Sanctuary. This is these are some of the major types of inland wetlands. And in the coastal wetlands, you have lagoon, chilka is there, and in which you can see various shades of blue, which indicate turbidity levels. And it is the largest lagoon in Asia. We have 5 lagoons. It is one of them. Then we have creeks and mangroves are there. Intertidal flats, one can see, and coral reefs from Andaman and salt pans. About 80% of the salt pans are in Gujarat, and 80% salt is also produced in Gujarat. And inland, you can say salt is produced in Sambar Lake. Now, if nobody is having any further resources, then even crudely, we can find out turbidity using satellite data. Low turbidity will be very dark, and then high turbidity will be just like vision color, and then intermediate color will indicate moderate turbidity. And in the center, you have Wooler Lake, and whatever red color is there, it is a natural wetland on Jhelum River. And now, there are various issues because of the trapa or singhada which is being grown or cultivated there. There are serious problems, and it's the width of the river is very narrow now. So basically, using satellite data, we can delineate the wetland, we can map and monitor its aquatic vegetation and turbidity as well. Now this slide shows various major activities which have been, especially at the national level, which have been done for India. First, scientific inventory of wetlands, and then we have recent, and then we have for a wetland information system for West Bengal and for Loktak. These were the first thing which caused use of or usage of remote sensing data for wetland studies. And as of today, we have about 15 million hectare area under wetlands, including rivers. And these things don't include areas less than 2.25 hectare. So basically, you can see that, in my opinion, our wetland area should be more than 20 million hectare, which is about 4% of our total land mass. And globally, it is about 6% of the land mass is under wetlands. And you can see from this figure that how many wetlands are there in terms of percentage. Rivers occupy about 50%. Those rivers which have water in some part, and man-made wetlands occupy 24%. Among the natural wetlands, we have lakes, 7% are there. And in coastal wetlands, because of this runoff cuts, we have intertidal mudflats more than 80%, and mangroves are the second types of coastal wetlands. Now, when we do restoration, the basic thing is that we have to assess the health of the wetland, and this can be done using remote sensing and GIS. Now it is possible. Earlier it was not possible. Basically, for coastal areas, people have been doing, but work done globally and by our students or my students. Now it is possible to do aquatic health assessment, especially for turbidity quantitatively, chlorophyll A and trophic state index using satellite data in conjunction with very little field data on water quality and all that. Now, using satellite data and some you can say ratios or some equations using satellite data, and this has been done using Landsat data, reason being that it is freely available. And unfortunately, our Indian satellite data does not have thermal band, as well as uh, it is not freely available always. We have very little data. First, we went for a trial basis for in Chhattisgarh for some of the reservoirs, and you can see it was possible to make use of satellite data to quantify, to quantitatively estimate the turbidity levels, and then trophic state index also it is possible, chlorophyll A also it is possible using satellite data, various indices, various equations I have shown, and then aquatic vegetation also. And this is very important because field data cannot be collected time and again, but this data is very crucial and it can be estimated using satellite data. So I request my students, those students who are attending and working on wetlands, that they should now use satellite data also in conjunction with field data for assessing some of these parameters. And these are some of the structural components. So this term was coined by us to show whatever are the different types of habitats occurring within the wetland. So using satellite data, it is possible to monitor, and which is very critical and crucial if we have to do any conservation measure. And this is trophic state index for the same, this wetland. And basically I've shown for chlorophyll only, but if you are using field data, if you have data on phosphate or nitrate, then you can have trophic state index, which was first given by Carlson in 1977, using other parameters as well in various seasons and various. Similarly, for rivers also, this is very recent work. This is part of the Ramsar site, which between Breast Ghat and Narora. This is the reference site for Ganga River rejuvenation, or Namami Gange, which is going on. And in this also, besides monitoring of erosion and deposition for different reaches during 1993-2007 using satellite data, it was also possible to model chlorophyll A concentration in this stretch, and using the same type of equations. And this graph shows that how it can be done using satellite data. And beside, and what we need is that even data on water flow will be required for doing this conservation. And using satellite data and field data, now it is possible to delineate various parts of the river. And this type of data, unfortunately, is not being used for our Namami Gange. Otherwise, it can be very useful. We can find out water quality in various sectors of the river where water quality is good or poor or very poor. You can see from the image that it is about 85-kilometer long stretch. That considerable part of the river water quality is very poor. Now, especially this is for wetland per se, but for catchment also you can study. This is Bhindavas wetland. Its catchment is agriculture only. There are not many other, you can say, type of ecosystems like forest, etc. These are various images, false color composite, conventional, and as you can see, the yellow color depicts agricultural area. And if your catchment happens to be forested, just like catchment of Renuka Lake, which is in Himachal Pradesh, Sirmaur district, which is a forested catchment, and many of our wetlands occur in the Himalayan region and in the forested region of Western Ghats and Vindhyas. There it will be very useful that we study landscape fragmentation of the catchment, patch density, patch number, etc. As whether the catchment is perforated or all those things can be studied using satellite data. Basically, what I mean to say is that catchment integrity, using remote sensing and GIS, we can have a great information on this. Now, what is the process? If we are using satellite data and GIS only, so far we have been able to do only using wetland per se, and because catchment rehabilitation will require a lot of information and involvement of so many agencies, maybe revenue, maybe forest, urban areas, and so on and so forth. But using satellite data and information on the wetland side, catchment, whatever is available using satellite data, then what type of activity can be planned using criteria-based information and various landscape indices, it has been possible to suggest that what are the activities which should be done for various wetlands. We have studied for 5 wetlands. But what I'm showing you is for 2 wetlands. This are 3 wetlands rather, Somurari and Sokar.
Sorry to interrupt you, sir. So we are a little in tight schedule, time constraint, sir. So could you, sir, please?
Can we take only 2 minutes? Only 2
Yes, sir.
minutes.
Yes, sir. Sure, sir. Okay.
Okay. Now these are 2 wetlands, and using satellite-derived information on the catchment and wetland per se, and the structural components, it was possible to tell that what type of activities will be required. As I said earlier, that this is untouched wetland, so no action is required. But if we see deeper bill, which is a wetland in Guwahati city, remnant of Brahmaputra river, what we can see is that different sections of the wetland have different trophic states, and using various parameters, it is possible to tell that what type of actions will be required in different parts of the wetland, whether biophysical parameters should be regulated or water holding capacity is required to be improved, or no action is required in different parts and removal of vegetation. So I think this is the last slide if we have to go for wetland restoration, and it does show that what are the things which can be done using remote sensing. And as many things I have spoken, and it will require use of field data and involvement of many agencies, and besides policies and etc. And once the restoration plan is made and implemented, then satellite data can be used even for monitoring. Now, what is the way forward? That using we have to make use of landscape ecological approach for conservation and restoration of wetlands, and we need to develop. This is a challenge for our geospatial scientists and remote sensing scientists to develop further better indices to study its catchment integrity, and we have to involve people if we have to do any restoration, etc., and involve all people. And I think this was the last slide. Thank you very much for your patience. Thank you, Priyanka. I am through. And
Yes, thank you, sir. It was a very wonderful and very in detailed study that we have learned a lot about wetland. Now, moving forward, today we are not going to take questions right now at this platform, but we are going to mail the questions to the keynote speakers, and those answers can be again mailed back to the those who have asked. Now, taking forward the event, I would like to take our second keynote speaker and introduce him, Professor Nitin Kumar Tripathi. He is a professor in remote sensing and geoinformatics system in Asia Institute of Technology, Thailand, with over 32 years of experience in teaching, research, and projects. Apart from his regular responsibility of teaching and research at AIT, um, he has also served as a leader of information and communication technology and coordinator of remote sensing and GIS field of study. He has earlier served as various administrative positions in AIT, such as Dean School of Engineering and Technology, Director Academic Quality Assurance and Accreditation, Chairman Academic Development Review Committee, and Director Unified Programs. Dr. Tripathi obtained his BTech Civil Engineering degree in the year 1984 from NIT Warangal, India, and MTech Remote Sensing and PhD in Remote Sensing from IIT Kanpur. Dr. Tripathi has over 2 books published and many book chapters and over 200 publications in his credit under reputed peer-reviewed journals and national and international, and also have presented papers in several conferences. He has served over 40 doctorate and many master's theses with majority research topics focused on application of GIS and remote sensing in climate impact, water resource, agriculture and health, health and environment, internet GIS and system security, crop suitability modeling, and many more. So at present, he is also involved in research related to impact of extreme weather events and solar flares on accuracy of global positioning system signal supported by USAFRL. Dr. Tripathi has successfully conducted several projects and collaborations with international and national partners. He has conducted projects and training in India, Thailand, Burma, Cambodia, Laos, Vietnam, Indonesia, Philippines, and many more countries. Professor Tripathi was actively involved in Indian Society of Remote Sensing and Social Society of Geomatics. He has also served as a life member of Institution of Engineers in India and also Indian Society of Technological Education India. He is active a member of Asia Conference Remote Sensing. Now, with this thought in our mind, let's invite Dr. Nitin Kumar Tripathi for taking this event forward. So, you're most welcome.
Thank you very much, Priyanka ji, for introducing me. I would like to thank Suresh Gyan Bihar University for organizing this very useful conference. The whole world is going through the pandemic, Corona, and people do not know how to interact with each other. So I thank Suresh Gyan Bihar University to provide a platform so that we can see each other at least virtually and talk about our research and keep the things going. So thanks Shruti ji for inviting me for rendering the keynote, and also Sharma ji for this wonderful institution hosting this conference. So I will share my screen now. So Priyanka ji, can you see my screen?
Yes, sir. It's visible, sir.
Okay. So I'm here in Asian Institute of Technology since year 1999. Before that, I was working in IIT Kanpur as a faculty. And that time I was pretty active with Indian Society of Remote Sensing, NRSA. Garg Saab is one of my seniors that I have a lot of respect. And so I'm little far from India, but always keeping focus on India, Indian students. And so I'm here in AIT since 1959. I was sent by MHRD, Ministry of Human Resource Development, as a visiting faculty. Later on, they recruited me as a direct hire faculty. And in year 2000, I joined here. And I joined here because AIT is very innovative in its research, and it is a research university. It doesn't offer bachelor degree. It offers only master's and doctoral degree. So we have a lot of opportunity of doing research with people from all over the world, and various topics which are being addressed in Southeast Asia, South Asia, and other part of the world. You have already introduced me. So I will just say that I'm also, this journal is there, International Journal of Geoinformatics. So from Asian soil, there are very few journals in the field of geoinformatics. So I started it in the year 2001 as an Asian Journal of Geoinformatics. And now we have changed it to International Journal within 3 years. And now we are having since 2005 this journal. So International Journal of Geoinformatics, which is in Scopus, and I invite all of you to read it and also join in the research publications into this journal. Now today, seeing the theme of the conference, I have taken the topic up Earth climate anomalies and crop yield modeling in Songkram Basin in Thailand. So a lot of studies have been done for climate change studies, and people are convinced that climate change has occurred, or almost it has changed the climate, and it is going on. The climate change is going on. So the worst impact is going to be on the availability of the water, like predictability of availability of the water, and then also temperature rise, sea level rise. There are so many impact on the earth, and which is going to directly impact the human beings. One of the things that we are all concerned is about the food security or food availability. So we thought that, okay, climate is changing, but what is affecting the farmer is anomalies. Like when he's expecting certain kind of temperature, certain kind of rainfall and humidity, instead of that, there is a variability at that point of the time. So how it is impacting the crop yield? It is a very risky research because crop yield depends on many factors. One factor is climate, of course. Another is like soil quality, soil fertility, and you can improve that. Man can improve the soil quality. Plus water availability. If it is a rain-fed, yes, it affects the agriculture directly if the climate is changing. But if the managed, like a good irrigation system, etc., then it may not impact much. But at least I thought we should create a framework that not only climate change, let us study the climate anomalies and how it is impacting the crop yield in Songkram Basin. So climate anomalies, this is the variation in atmospheric composition resulting in abnormalities from the long-term averages. So we take like say 15 to 20 years average and then see how it is varying in different months and different years. So then we will understand that during the cropping season, what kind of anomalies and abnormalities are coming. Climate anomaly is the deviation from the average climate parameters over decades or longer, and the weather in each season for the year or decade. So here we can see we have to study sometime weather in say months or climate in month, year and decades. And climate change is decade and centuries. So here we are worried about say climate variability or anomalies at a particular cropping period. Now here this slide is very useful. This is from I have taken it from published literature from global climate cooling.org, and then this is the global land temperature anomalies. So we can see here it has taken from minus 30 degrees onwards up to more, and then from the year 1880 onwards till 2015. So we can see here how the things are changing. So the one straight line is the normal, that is the thing, and then how the anomalies are there. So we can see here climate temperature, global temperature is rising, and it is not like sometimes it is going down, but on the average it is on the rise. But how, when it became, it is around 1980-85 it has started becoming more. Earlier it was below normal, and sometimes there is a less temperature what we are expecting, but now we can see here it is always rising. In the higher temperature zone it is rising. Similarly, we have January to December precipitation anomalies in millimeter, and we can see here anomalies earlier were less, but now it is random. Sometimes there will be too much of rain, sometime negative. So this is the thing that sometimes farmers are affected by drought, sometimes by the flooding. Now the third graph you can see, the red color is the biomass production, green color is the vegetation indices like NDVI, etc., and blue color is the vegetation indices. Green color is the vegetation indices. Blue color is the leaf area index. Leaf area index gives the total vegetation cover by soil cover, and vegetation indices, which is in the green color, it is giving us like how vigorously your crop is, how strong your crop is in terms of moisture content and other things. Then biomass is the total production. So now you can see here from the spring to summer and autumn how the this biomass and everything is looking like, and then we have to study these things in the light of the climate parameters. Now I have taken the Songkram Basin, which is in the northeast of the Thailand, and you know Thailand is an agriculture economy also, and in the northeast of Thailand, in the farmers are mainly going for rice, cassava, and sugarcane. So these are the three crops they are doing, and there have been a lot of studies. They have reported that climate change has resulted in erratic rainfall and temperature patterns. Then agriculture production in the Songkram River Basin is sensitive to the changing climate. That has been done by my colleague Sangam Shrestha and Dr. Professor Mukund Babel, and they have found that changing temperature and rainfall patterns in the basin directly impact the agriculture sector. So this is very important to understand how the farmers are being affected. Then major crops are rice, cassava, and sugarcane. So they have been studying the climate change effect. But what in this study we are doing anomalies at every month. What is the anomaly during the cropping patterns? So objective of this study is to explore modeling NDVI and LAI with climate anomalies and its relationship with crop yield in Songkram River Basin. And specific objectives were to explore the trend and spatial patterns of NDVI and LAI, to identify the relationship between NDVI, LAI, and climate anomalies, finally to explore impact of climate anomalies on crop yield. So we are going to first find out what is the anomalies between, say, patterns of NDVI and LAI, then what is its relationship with climate anomalies, and then we find out impact on climate anomalies on crop yield. So we have used the climate data like temperature, rainfall, relative humidity. We collected from Thai Meteorological Department for the year 1988 to 2017. Then satellite data we have taken from Moody's. Two products we have taken from 2003 to 2017. And then we have taken European Space Agency Climate Change Initiative land cover at 300-meter spatial resolution. Then land use data we have taken from the Land Development Department, and crop yield data, land use data was taken for like our checking ground truth, and crop yield we have taken rice, sugarcane, and cassava from Department of Agriculture Economics. So this is the Songkram Basin. Now you can see here, red color is the high elevation zones, and then this green line, it is the Songkram River which is flowing, and then it is going and making into the Kong River, that is the Mekong River, and which is the border of Laos and Thailand. So this is a border province and mainly agriculture economy, and so we have taken this in our study, and we have used different softwares. I think all of you are aware of it, ArcMap, IDAS. Then we have used Python for scripting, and SPSS and ExcelSat, etc. Now, overall methodology is first to find out climate anomalies for rainfall, relative humidity, temperature, and we have related temperature with digital elevation model, and find out the lapse rate of estimation also for that. And finally, from the random point we have done is spatial interpolation, and we got the rainfall interpolation, relative humidity interpolation, and temperature interpolation. And then we have calculated from relative humidity and temperature heat index. And from the heat index, anomaly also was calculated. So all the 4 parameter anomaly like rainfall, relative humidity, temperature, and heat index anomaly were computed. And from the satellite data from MODIS and land cover data from ISA and field survey validation, we have developed rainfall, relative humidity, temperature, NDVI, and LAI for different crops. So we have developed these things, these indicators for different crops also. And later on, we have done the statistical analysis to find out impact of anomalies on our NDVI, LAI, and finally in third objective on crop yield. So I will not go into the details of how we have done it, complete study, because of time constraint. Any researcher wants, then I can discuss with him and share. And then I will come to the results of the objective 1. So NDVI and year from 2003 to 2017, we have analyzed the NDVI, and you can see here the normal line, that is the dash line, and then how it is changing over the years. And so we have done using Python language, though the study was done for monthly, 16 days average. We have done 16-day data we have analyzed, but just to show here, in the thesis we have all the records, and we are showing here the annual variation. Now you can see here from 2003 till 2005, NDVI was going down in the whole basin. I'm telling about the whole basin here. And then it picked up in 2006, and then it was quite stable, but NDVI was rising till 2010. Then again 11, it went down because too much of rainfall and flooding was there, and finally crop was not there. And then again from 2012 it is stabilized. Then 2014 there was a drought year and it went down. Then again it is rising. So we see that NDVI is constantly rising, though there is a climate change is happening. So if we see that one, we look like climate change may not be affecting NDVI. Now come to the LAI, leaf area index, which is a signature of coverage of the green leaves over the soil. And then we see similar trends, but it is showing much fluctuation than NDVI. And it shows that in certain areas there might be impact of the climate change. So instead of rising, sometimes it is going down drastically, and then in some areas it is up like NDVI. But altogether it is also showing very good trend that NDVI, LAI is rising altogether as per the normal. But there are fluctuations we can see in LAI also. Now, this is the map that I told that from 2003 to 17, we have computed annually. We have also done monthly, because now with Python, you can do anything once you have the data. So we have done, and we find NDVI changes in the whole basin from 2003 to 2017. And then we can see here that NDVI is rising. That graph we have seen, and now you can see here in certain area on the upper part, NDVI impacts are very good, and altogether it is rising. We can see here in 2005 it is quite less, so it was going down, and then it picked up in 2006, and then it rise. In between there are some rise and fall, but altogether NDVI is rising in this basin. Now this is the LAI. LAI is you can see here from 2003 to 2017, and there are some outlier like 25.5s. Otherwise, in many areas, it is showing the trend as depicted in the curve. And spatio-temporal variability of mean annual LAI from 2003 to 17. LAI was on highest in 2016. 2.01, and it was the lowest in 2005, 1.55. Now here is spatial pattern of the mean 16-day NDVI from 2003 to 2017. Now seasonal dynamics of mean 16-day NDVI from January to December from 2003 to 17. So for month-wise, like January 1, then after 16 days, 17 January, till complete year, like 2003 to 17, we have taken the data, and we have taken 16-day variation. That tells that if I take like 15 years data and then take the monthly twice variation, now this is the result, and it is going to give very good result. Like it is telling that NDVI variation on the whole basin was governed by rainfall, where the NDVI values started to rise in March and peaked in the September. We know that in Thailand, the rainfall comes in April. Instead of like June in India, it starts in April middle or something. So from March, we are seeing NDVI is rising. And then it goes on rising till September, then it's declined. So this is a very good trend. And I think we can do more experiment of this kind. Like we have done 16 days experiment, but within the year we can do daily because the data is available, and we can find out when exactly in some year drought conditions are prevailing in certain parts. It is not the whole basin. Right now we have studied the whole basin. Later on we can go at the sub-basin analysis, and I think we can do a better crop management. Now this is the LAI. Similar thing, the LAI started increasing again in the end of July, when the crops cover the whole area, and then reaching the peak at the end of September and beginning to decrease until February. So we can see in July it starts rising, LAI, and then it peaks in September, and then from October onwards till February it will go on decreasing. Again, slight rise will be there after March. You can say when the rainfall is there and crop starts showing up. Now, these are all statistical analysis. We have done NDVI correlation with climate anomalies for different sub-basin. So we have divided the Songkram sub-basin, like say, into 8 parts, 8 sub-basin, 7 sub-basin and whole basin. And now we have analyzed it at sub-basin level, and we can see here like Hue Kong and Huai He, they are showing some significant results here, and for NDVI anomalies with temperature, and then heat index also in some cases is showing very good results. And so we found that heat index and temperature may be very important to monitor, and we can see how the temperature anomalies are affecting the crop yield, because once the rainfall is there, then temperature and humidity are controlling the growth. And then here it is the LAI correlation with climate anomalies for different sub-basin. Again, we see that Huai Kong and Huai He, they are playing very important. They are giving some significant numbers, and these correlation may look smaller, but they are positive trends. And then they are showing that these anomalies are having the impact and on our crop production. So we have to do much more detailed study on anomalies, not only climate data directly, but how it is changing from the normal data. So one thing we found that climate is like temperature is rising, NDVI is rising, LAI is rising, but there is a lot of fluctuation in LAI. And now when we are studying a different sub-basin, then we know that in which sub-basin it is having pronounced effect compared to other sub-basin. So one study is on the whole basin, another is to do at a sub-basin level. And then we can know that whether we need more irrigation facilities and more education to the farmers to cope with the climate anomaly. And crops, and this is for paddy, cassava, and sugarcane for NDVI and LAI. So I will conclude it because time is less. And then this is for 16-day, 0 to 16-day. And for all the sub-basins, we have found out. And we find that for certain crops, we find out that after, in the beginning, like 32-day itself, we can see the impact. And most of the sub-basins we see at 96 days. And in some areas at 128 days or 144 days. So temperature anomalies can so impact even in the advanced days, like say after 3 months or something like that. So we have to be very careful. And I think this calls for a how to cope with the anomalies and how to have more irrigation facilities. Now this is the thing for crop, like 3 crops we have done, and we can see here 16-day LAI for sugarcane, and NDVI sugarcane is much impacted. So in the beginning, sugarcane need more water, and so this is the thing for 16-day and for rainfall anomalies. And then after 80 days, paddy and cassava around 96 days, they are impacted. So I think these are the things we have to be worried, and these are giving very good indication how this climate anomalies can be one of the research areas. And instead of climate itself, climate anomalies will give much more dedicated, means much more precise evaluation. And then we have done different crop yield trends. We got the data for objective 3 from like agriculture economic department, and we got the data not for sub basin, so we cannot say much about that. We got the data for whole province, and so they shared only for whole province. Maybe at some stage I can find out at the district level or something, and then we can see on the sub basin level how to manage. But we can see here like second rise is impacted a lot, and in some years, like say 2002 to 2005, too much impact is on the second rise, and after that there is very less impact. I think after that they have improved the seed quality and also irrigation facilities. Similarly, cassava was impacted till 2005, I can say, but later on they have also less impact. But there are minor impact, we can say, like in the later stages, like say 2014 onwards, there have been decline in the second rise, and there has been decline from 2012, and again it has picked up in 2016 about cassava. Sugarcane, earlier it was having decline, now it is quite stable, but in 2016 onward, again there is a decline from the normal. So I will skip here. There are a lot of curves to discuss. I will come to the conclusion slide. NDVI increased by 9.8% and LAI values increased by 12.3% from 2003 to 2017 for the whole basin. So this is a good sign that we are having a better crop yield, though there is a climate change and there is a climate anomalies. But overall, this is giving a better scenario that there is not such a problem in the Songkram sub-basin. This is blessed with one river like Mekong River on the northern side, and then Songkram River is just circulating. It is not flowing like a straight line. It is just going around the Songkram sub-basin, Songkram basin. LAI in the Huai Kong and Huai He sub-basin were significantly positively correlated to temperature anomalies. So temperature is the one which is affecting the LAI. And we know that after how many days it will affect. So this study is really useful to tell that we must study the anomalies, and we should know after how many days we have to be very careful about the crop. And then analysis of the delayed effect of the mean 16-day rainfall anomalies to NDVI in the Hawaii Kong sub-basin show good correlation between NDVI and rainfall anomalies for 128-day lag. So this is a good thing. Like we have found that after 128 days, there is a good correlation between NDVI and rainfall. So this is giving like rainfall anomaly will affect after 128 days or in the beginning for the sugarcane. Most of the correlation coefficient of the mean 16-day NDVI and rainfall is higher than that of the mean 16-day LAI and rainfall anomaly. So NDVI is very much important for the crop structure, and I think LAI is normally the leaf structure and leaf coverage. NDVI is more important for the crop growth. I think that should be taken, and it is showing very high, quite high correlation. Minimum temperature anomaly was significant. So more than the higher maximum temperature, minimum temperature analysis is more significant for the crop yield, and that I think we have to monitor that one. Climate anomalies, no strong relationship observed in the crop yield due to improved irrigation, agriculture area extension, and better seed. One thing is data is at the province level, so we cannot go in a detail. Otherwise, in certain sub-basin, there will be significant effect where the like irrigation canals are not there. But on the whole, the agriculture department here manages seeds very well. They are having high yield seeds and which can be resistant to drought and other things. The result revealed that the climate anomalies have a significant effect on the second rice yield. So they have first rice yield in the first part of the year, and second is in the from July till November. So that is much more affected by the climate anomalies. Rainfall, minimum temperature, and maximum temperature anomalies account for 79% of the variation exhibited by the second rice yield. So all of these are impacting the second rice yield, and I think these anomalies must be observed more carefully. So with this, I will stop, and I would like to thank Ms. Dao Savalak and my team members, Professor Sangam Shrestha and Dr. Salvatore Verdis for this study. Thank you very much. So I will stop here. Thank you.
Thank you, sir. Thank you for such detailed knowledge that you have shared with us. Now, moving forward with today's event, I would like to take a brief moment to introduce our third key speaker, Dr. Lakshmikant Sharma. He was associated with faculty of Birla Institute of Technology, Misra, Ranchi, and Central University, Jharkhand from 2007 to 2015. And now he is currently an associate professor in environment science at Central University of Rajasthan, Ajmer, since 2015. He was formerly headed of Department of Environmental Science and Dean of School of Earth Sciences. He received his MSc and PhD degree in botany with specialization in ecology and environment from University of Rajasthan, Jaipur. He received his PG diploma as well as MTech in remote sensing and GIS from Indian Institute of Remote Sensing, Dehradun, India. And Dr. Sharma is also been author of 50 peer-reviewed international journal, books, and many more book chapters, as well as he is served as an editorial board member of various international journals. He is currently member of Commission on Ecosystem Management and World Commission on Protected Area of IUCN for the period of 2017 and 2020. Dr. Sharma has also been associated with many MSc and MTech project and PhD research works. And his research main focus is in the area of advanced remote sensing GIS tools for analyzing environmental system, land use and land cover challenge, forest fire modeling, saline wetland in climate change impact, human environment interaction, and many more. Dr. Sharma has worked extensively with multi-sensor advanced remote sensing data with research support from Space Application Center, NRSC, Ministry of Environment, Forest and Climate Change from Government of India. Recently, Dr. Sharma is member of Marcus Wellenberg Prize Award for 2020. This is can also be cited on website of British Columbia University of Canada. On this note, I would like to invite Dr. Lakshmikant Sharma to take forward today's event. Sir, you're most welcome.
Yeah, thank you, madam. Thank you so much for this giving me this opportunity to present my knowledge to share with some of my colleagues. And thank you so much that Professor Tripathi is there and Professor Garg is there. So very good morning, sir, all of you and my dear friends. And this approach is very, very unique because every year Dr. Shruti and Dr. Suraj is taking this type of opportunities for providing some useful knowledge to their students and their other fraternity also. So I appreciate this type of efforts of Dr. Sudhanshu also, who is the mentor of this university. And now I'm just presenting my presentation, which is particularly based on the theme. I'm not going to the detail of any of the specific case study of my research, but I just want to just share the things which is very common to each and everybody, and what is the new things we can arise that is also maybe discussed in that way. So, once a minute. Is it visible?
Yes, sir, it is visible, sir.
Okay. So now my audio is also listening. Audio is good. Should I start?
Yes, sir. Yes, sir.
Okay.
Yes, sir. Audio is clear, sir.
Okay. Yeah. Now today's talk is based on Earth observation technologies for environmental management. As I am from Central University of Rajasthan, and we are centrally funded organizations, and we are in the middle of this, or you can say the semi-arid and arid region of the India, is the Thar Desert, and one of the Aravalli region is also surrounding this one. So my habitat is totally different from other Indian parts. So we are basically doing our work in terms of environmental remote sensing, basically in terms of biomass productions, forest fire estimations, and land use and land cover studies, wildlife management studies, and all these others. So with this one, we are just starting with this Earth observation technologies for environmental management particularly. You see, why we are doing the Earth to observe actually. So Earth observation is the gathering of information about planet's Earth, physical, chemical, and biological systems. It involves monitoring and assessing the status of the changes in the natural and man-made environment. So the common application of Earth observing is that like forest fire estimations, which is very much concerned about the global warming concern. And each and everybody is just aware about the global wildfire, because Californian forest and Indonesian forest, Australian forest, and all these European unions, some of the forest regions are very, very catastrophic effect showing on the nature and natural resources. Every year they are showing their great loss of the wildlife habitat also. So this is a common application of Earth observing satellites, Earth observing remote sensing, is that to monitor, to better management of this forest fires and other things is also there. Other one is the ocean monitoring. That is also very important things. Precision agriculture, urban and regional planning, water resources management, weather forecasting, environmental monitoring and management, land management, forestry applications, energy resources, natural disasters management, emergency responses. All these things can be done due to this Earth observing satellites. So this Earth observing satellite in terms of environmental management is so important, and so eagerly using in that way. So in terms of this benefits, economic benefits, environmental benefits, public health benefits, security benefits, and knowledge benefits, we can also segregate all these benefits with the Earth observations. So in that way, we can also say that environmental management, a holistic approach, if you choose, then different type of the ecosystems like and different type of the practices can be also interrelated to the environmental management, particularly in ecology, earth sciences, atmospheric science, water science, climate change study, society and culture studies, environmental laws, environmental assessment, mitigation and monitoring, management practices, waste management, sustainability. All these things are interrelated to each other and governed by the environmental management particularly. And if you combinedly use this Earth observation satellites or satellite remote sensing in a single window or single platform, the application part, then you can say the environmental remote sensing is a better tool to understand our better strategy making and better planning, and you can say the better development and other things can be managed in that way. Now the question is that now these days the sustainability is a major concern, and the sustainable goals different as per the United Nations provide the 17 goals for the sustainable development, and all the 17 sustainable goals which requires global monitoring and global aspect to determine the situations, and you can say the different aspect regarding the monitoring, evaluations, management, and rehabilitations, and some rejuvenation of the natural resources. All these things can be done due to this type of the goal of this sustainable development goal, because every natural resources demand the sustainability itself. So in that way, natural resources monitoring and Earth observation is a closely related things, and we have to understand these type of things at first to obtain the different sources are available. Everybody is aware about this one, that from that ancient time, from pigeon photography to the Earth observatory or the space level photography, now you can see easily that how much difference is the current day situations and the previous situations. So Earth observation is a primary concern about this one, not only from recent time, but from ancient time also, or the previous times, earlier times, we are also depending on this one. And some of the mechanical methods was used at the time, but now the technology is so advanced that we have the geostationary and the sun synchronous satellites also, which is covering the Earth observations, daily monitoring, 1 day monitoring, and you can say the each and every moment we can also monitor through this technology. So it's a tremendous change to add to this Earth observing remote sensing satellite systems. Now, you can see we are not using for the classification only different type of classifications we are classified. Before that, the classification was based on some type of the phenomena like the supervised classification, unsupervised classification. Now, the soft classification is so important in terms of the classification because each and every species specific information is required now. So hyperspectral remote sensing imageries is providing a excellent tool in terms of this one, but the classification algorithms like fuzzy C-mean theory, fuzzy classifications, or C-mean clustering, artificial neural network, deep learning, and all this, Google Earth Engine, we are just taking the help of this one. The classification part is now these days are very, very common in Earth observations. Again, the drone is advanced technology also that is also providing a different type of the flight pathways and unaccessible areas explored without much experience and without much, you can say, the other necessities is required. So drone is also capable to take the Earth observing imageries and Earth observing capacity also. LiDAR, radar imageries, and the other different type of softwares is also available by which we can very, very efficiently use for different type of digital elevation models or the digital terrain models we can generate. And all these things not only from the satellite system but also different airborne systems and the drone based systems we are also using for the Earth observations right now. Again, same thing, the GIS is also providing a very, very unique decision-making capacity. But right now, from beginning to this era, you see that the measurement part, visualization and mapping, analysis and modeling, planning and design, policy making, decision making, and action taken, all these things can be easily carried out by the GIS. And you see in recent pandemic times, GIS play a significant role in terms of this COVID-19 period. Each and every person has, I think maybe familiar about the John Hopkins University's data, and they are daily updated through this GIS domain also. So this is the frequent, excellent example of the GIS-based analysis in terms of the health GIS particularly. So different ways we can use and Earth observing capabilities of the GIS that can be also explored in different domains also. Now you see these are the whisk broom and push broom scanners. So different type of scanning system is also very advanced right now in terms of this charge coupled devices, CCD arrays in the push broom sensors and the whisk broom sensors. You see different type of different techniques are available for Earth observing data analysis. So this is also another area by which we can easily understand the Earth observations through satellite remote sensing. And this is the diagram you're showing that different countries has different parameters they are taking, and all these are interlinked with the particularly remote sensing and GIS and GPS and GNSS systems, whatever the possibilities are there. And you see that different topics are interrelated to each other, and Earth observing are not only constrained with some of the topics, but each and every type of ecosystems that can be governed, that can be monitored, that can be planned, and that can be, systematized with these type of techniques, so that the proper planning and the implementation can be taken place in that moment, in current scenario actually. all of you know that how the passive and active remote sensing is developed in the Earth observation, particularly. The active system is the active source of energy is there, like radar and lidar, whereas the passive systems like this, or like this normal optic remote sensing system. So these are the also the Earth observing phenomena by which you can easily establish the system. And now the recent technologies now advancing in terms of the lidar and radar also. So I'm not going into the particular detail of this one, but this is the things by which I would like to show you that how the Earth observing phenomena is going on, and how the environmental remote sensing can be placed in terms of this monitoring and observations of the resources and other factors of the environmental related aspects. So active and passive remote sensing is also a very, very unique system by which we can also use in the Earth observing data types also. And you see the spaceborne EO platforms, different type of platform, like from drone-based ecosystem monitoring to the sports series of satellite system, Landsat series of satellite system, IRS series of satellite system, Aster data, Terra monitoring SAR-X data, Sentinel-1 data, Eros-1 data. All these are the Earth observing satellite platforms, and some of the platforms are polar-based Earth orbital systems, and some may be the geostationary, or these are the stationary phase systems are there. So different type of the spaceborne satellite platform, Earth observing satellites are also working right now. And the platform may be different from aerial to the drone, that the journey is so interesting in terms of this airborne Earth observing satellite platform, satellite data, you can say. And these are some of the things which is very, very unique in terms of lidar, radar, and INSAR, interferometric SAR, and the differential interferometric SAR, DINSAR. All these things are very, very spatiotemporal database analysis studies, and for in-depth analysis, and the jet directions or jet perception analysis. These SAR data and the lidar data is very, very unique in terms of the Earth observations. So these are the advantageous features of the remote sensing by which you can easily use for this type of the Earth observation and management. And everybody is aware about the MODIS data, moderate resolution imaging spectroradiometer, and which is 36 bands, and spectral bands is there. So you can say a semi hyperspectral database analysis of through this MODIS system. MODIS Aqua and MODIS Terra is also working in since 2002 to 2000 onwards. It is available, and you see how much resolution the global world coverage for the different MODIS based system can be also provide for the Earth observing satellites in terms of this one. AVHRR data, global fire mapping, global precipitation, global temperature analysis, all these anomalies related to the climate change situations that can be also easily visualized with the global this MODIS data set. So 500-meter true color FCC image you can see with this image, as well as the other Aster data is also available with different resolutions you can use for this one. Now, as well as the optical remote sensing, thermal infrared remote sensing system is also equally available for the Earth observing phenomena or Earth observing satellite systems. And you see the NOVA AVHRR data is also a very unique data by which you can use for this thermal bands, you can say the observations of the Earth resources. And these are the Landsat mission satellites and sensors. That is also a very useful in terms of the land surface or land cover analysis. in different ways, and which is available from 1970 to 2000 till now. And in 2023, it will be launched by the Landsat 9 will be also launched, and it is very, very unique and free of cost availability data set, which is provided by the NASA. And this is a very unique by which you can generate the Earth observing data in different ways. Now you see some of the structural complexity and the restoration trajectory in terms of, if you want to talk about this one, then the three-dimension LiDAR data is very, very usable. Above ground biomass, different spaceborne, UAV-based, aeroplane-based, ground-based, and spaceborne satellite is also usable. And some of the canopy layering and canopy monitoring also, that can be also very, very very uniquely applied with the you can say the radar data set, SAR data set, which is very, very common in terms of this, you can say the effect of soil particles as well as the soil moisture analysis. All these layers, different layers, bidirectional reflectance analysis, BRDF effect, which you can very easily generate through this radar data set also. So these are the species composition, and thoroughly, if you see the spatiotemporal or temporal changes, different multispectral, hyperspectral, and LiDAR data set is also very, very usable for the Earth observing. And spatially temporal data set for the biodiversity monitoring, for the species level demarcation throughout the you can say the different time series analysis, and habitat suitability modeling, and different type of approaches we can do in the environmental related aspect, not only ecology but also the some type of the pollution related situations, pollution monitoring and analysis, and climate change adaptation monitoring. All these things, rangeland management systems, that can be also, we can also use with this multispectral, hyperspectral, and LiDAR remote sensing. And some of the phenological level of the changes that can be also usable with the MODIS data and other data set also. And you see that the primary productivity means the ecosystem functioning, means the production of biomass per unit area per unit time. That is primary productivity. And the primary function of the any ecosystem is that the production of biomass, flow of nutrient, flow of energy, and nutrient cycling. So in that way, the phenology, plant phenology is very, very important in terms of climate change situation analysis and adaptation. So in that way, the Earth observing satellite is particularly the temporal satellite images, not only from the MODIS also, but some of the like Landsat and Sentinel-2 images that can be also, as per suitability, we can also use for this one. So some type of the buffering and distance mapping, settlement analysis, fire risk analysis, different type of the Cartosat map, Google Earth Engine map, and some of the other low resolution and the high resolution, both the satellite system can also be usable in terms of the Earth observing fields. Now you see the LiDAR is also a prominent feature, which providing the LiDAR, the cloud points is also providing by the LiDAR. Within a second, thousands of the cloud points will be also available, and each and every specific point will provide the X, Y, and Z situation. And you see the different type of the stories, mid stories and the over stories. You can easily estimate the height of the particular forest structure and the biodiversity, and in the ocean surface modeling, the bathymetric analysis you can done with this one, this type of the LiDAR applications, and the different models, animal impact models that can be also predicted in terms of the LiDAR analysis. So these are the this is a very, very innovative and advanced LiDAR system which is usable for the Earth resources, the satellite systems. Some of the image segmentations, different segmentation approaches, different classification algorithms by the use of this predicted, you can see the LiDAR and the worldview 2 data that can be canopy height model digital surface model, digital terrain model that can be also integrated in different type of approaches, and different studies also worldwide, different research journals are published, and these are the very very advanced technique by which we can use. You see, the hyperspectral images provide that very unique and species specific resolutions and of the particular species identification. For ground modeling, lidar data is very very usable and attributable in terms of the GIS domain you can generate, and ultimately you can analyze the forest trend. So these particular species level forest trend that can be also usable in terms of this hyperspectral imageries and a combination of the lidar images also. So the lidar images data is also freely available right now, and the ISAT2 data is also freely available with the cloud points, and we can do different type of approaches with this one. In future also, different type of algorithm will be also developed. One of our case study which we have used this hyperspectral data in Shulpaneshwar Wildlife Sanctuary in Gujarat, and we have also some type of the predicted modeling that can be also you can use with this one. We have also shifting of the different classes we have also used for this study, and this study is published in Ecological Informatics journals, and future projections of this type of study you can also generate with this. So these are the emerging developmental activities in terms of remote sensing and earth observations, like cube satellites are enabling small satellite to be accessible many. So right now ISRO is also focusing on this type of the satellites. Artificial intelligence, deep learning technologies are widely used right now, and with the use of this data processing, different type of techniques is also available. Cloud computing is also available, by which we can easily use the earth observing satellites and earth observing data set also. Now the aerial photography with the UAV and the other ground level measurement techniques, that is also much more reliable in terms of the earth observations. So some of the very recently in 27th August, one of our study is also, as Dr. Garg is already telling, that we need the restoration of this our wetlands. So we are also working on this Sambar wetlands ecosystem conservations, and our study is also published in the Hindu newspaper in 27th August 2021 in the Times of India, and this study is already published in the PLOS ONE journal. And one of the diegetic area study in the environmental sensitive areas in terms of this earth observing satellites, we are also very recently it is published in Journal of Arid Environment. So these are from my side, and if you have any question then you can ask me.
Thank you, sir. Thank you for such detailed analysis of the study that you have presented here, sir. So we will not take the questions right now because of the time constraint. The participants who are having any questions, we can mail you the questions, and sir, accordingly the answers we will again respond back to the participants.
Sure.
So moving forward with the event, I would like to take a brief moment to introduce our fourth keynote speaker, Dr. Kirti Abhishek, Associate Professor, Department of Civil and Environmental Engineering, BIT Mishra, Ranchi. Dr. Kirti Abhishek has received a Young International Scientist Award from Chinese Academy of Science in 2011 and has worked with UNEP China during his postdoc period. He has a good number of research publications in reputed journals, national and international, and he has worked with several international and national funded projects. Sir, I invite you for the taking this event forward. You're most welcome, sir.
Thank you, Priyanka. A very warm welcome, and thank you everyone for inviting me for this talk. And it has always been a pleasure for me to interact with and Dr. Lakshmikant Sharma. Your talk was very informative, and very background information was provided to us. So thank you so much. And in fact, I also thank Dr. Shruti and Dr. Suraj, who have always taken that initiatives to connect with us. So thank you so much. My lecture will be more focused upon a small case study that I had done for the Nawabganj wetlands in Lucknow. It has been renamed as Shaheed wetlands in Unnao. It's basically falling in now. So I'll be starting my presentation. Is the screen visible to all of you?
Yes, yes, sir, it is visible.
Okay. So I think
slideshow mode, sir. Please do it in the slideshow.
1 second. Yeah, I think it's fine now.
Yes, sir.
Okay. So I think in continuation with what Dr. Sharma was just now discussing about the various techniques and tools which have been adopted. So one of my case study was on wetland ecosystem monitoring using geospatial technology, and we had done this work for Lucknow, and basically we tried to address the National Lake Conservation Program of India. And this specific technology is a mixture of geospatial technology along with field survey work and some kind of secondary data collection. So it was a combination of 2-3 different aspects into one single platform. And we tried to pursue this work during the lockdown period. So 1 year data was provided, and the benefit was obviously seen, because in the second year when the COVID was in its extreme high notes, so we were not able to go for the field work. But at that time, satellite technology was so very helpful for all of us. So I will be starting now. When we talk about wetlands, the Ramsar Convention has already defined it as an area of marsh, fen, peatland, or water, whether natural or artificial, temporary or static, brackish, fresh, flowing. So with the limit not exceeding the 6 meters. So we have 2 different types of wetland, the inland wetland and the coastal wetland. What my presentation will focus upon is the inland wetland. Now, when we talk about wetlands, we have always seen n numbers of water bodies across us, and we have witnessed from our childhood, and I'm sure the younger generations who are currently in the presentation, they might also have witnessed the changes that are going around in the wetland areas. If you talk about in a very layman language, all the pond, lakes, whatever we see around us, they have been decreasing with time. So either it is because of pollution or over extraction of water. At times they have also been filled up by soil for urban constructions. So when such huge demolitions or degradations of the wetlands were going on, then at the apt time, the government of India took this initiatives for the National Lake Plan Conservation and under the National Water Mission. So we are trying to, under that scheme, we are trying to address this problem. When we talk about wetlands, it has multi-functions all the way from hydrology, which we are quite aware of, for aquifer recharge, discharge, the flow maintenance, all the way from biochemical recycling, where you have biomass and soil production, the nutrient transformations. Then habitat, because wetlands are an area where you have the land area and water area intermixing with each other. So we have n number of species which are there, both aquatic flora and aquatic and fauna. So how they're interacting with each other, it's a huge, it's a very intense combination of flora and fauna where it is working, and it also has a major role in the climate change, because it plays a role in carbon fixation. It also has a balance for carbon dioxide balancing. So many functions are there, and hence we need to take care of our wetland. One common mistake done for urban development can result in a severe water scarcity for that specific area. I basically belong to a city called Ranchi, and we had a huge water reservoir known as the Hatia or Dhurva Reservoir. And one common mistake that was conducted was the development of the ring road. And this ring road basically was done on the catchment of the wetland, and hence the inflow towards the water body was affected. And hence, after the construction of the ring road was completed, the water scarcity issues emerged in and around that area. So these are some very small examples that we see. So I'm just coming up with the problems, some of the problems that has been observed for wetlands, which is a common aspects. Agricultural activities and runoffs will reduce the water holding capacities of the wetland. And then we have deforestation going on, then hydrological alterations coming up, urbanization, various climate change influences on the wetlands, and at times even excessive fish cultivation can also affect the natural systems of the wetlands. So keeping all the aspects in mind, we try to go for identifying the significance of the wetland ecosystems and its services. So we try to understand how a specific wetland works and what are the services it provides. And then we also try to understand if there is a kind of a microclimatic influence of the wetland on the surrounding areas, and whether that influence can actually affect the human beings. And the third one was the spatiotemporal assessment of the wetlands. The study, as I already told you, it was the Nawabganj Bird Sanctuary. It's a Ramsar site. It was included in the Ramsar site in January 2020. And it's basically a marshland of 45 kilometers located in 45 kilometers from Lucknow. And the overall area of the wetland is around 224.6 hectares. Since it is falling under the Indo-Gangetic plain, so the temperature profiles are also varying, quite hot during the summer and quite chilly during the winters, from 4 degrees to 48 degrees centigrade. And it's a wetland which is located within the bird sanctuary, which is the Nawabganj Bird Sanctuary. So it's basically a protected area. But even then, we could see the variation in the wetland with time. So those studies were conducted using our satellite data sets. What you see is a picture of my research scholar who is working on Nawabganj wetland. And he has been doing this research since last 2 years, except for the last 1 year where due to COVID, he was not able to visit the site. So we used some handheld instruments for taking the air temperature, moisture, the carbon dioxide. So all the instruments handheld instruments were used. And this, we had fixed up a date for keeping a uniformity. So survey was conducted for 3 continuous days from the 5th to 17th of May 2019, followed by 12th to 14th August 2019, 5th to 7th October 2019. And we went for studying the relative humidity, wind speed, wind traction, atmospheric temperature, and all of them were recorded. So around 58 sampling locations were studied in an area of 224 hectares. When we talked about the comfort and the influence of that specific wetland on surrounding areas, we basically use an equation by Zahn 2016, which is the combination of temperature, humidity, and wind velocity. And they had given a grading of the index. Now, this specific equation, it was adopted since it was applied in a semi-arid region of China. And since Lucknow is also a semi-arid region, so we adopted the same equation to see if it is feasible enough to apply the equation in under the same environmental setups. So we found quite relative good results even for us across the wetland. Then, apart from understanding the human influence and effects on human comfort, we went for vegetation sampling, in which we went for around 14 locations of 2 meter square area. And from these square studies, we went for vegetation sampling and frequency assessment, abundance assessment. So we try to understand the vegetation components of the site by using density, frequency, and abundance. So these were the equations that were used for identifying or studying the site. What you see in the image is the Ramsar site, where if you look at the center point where it's written Ravanhar, that is the main wetland area. And the adjoining close by forest area is all covered, is all the sanctuary, the bird sanctuary area. Now it falls under the national highway, so you have an influence of moving vehicle, and at times, since the location is quite open at one end, so the wind directions also have quite an influence on the site. For satellite studies, we basically adopted the Landsat 8 satellite, and we used QGIS, ADAS, and ArcGIS softwares for studying. Now, except for 2013, where the data sets were not available for Landsat, so we went for the month of May as a pre-monsoon and post-monsoon for September. Rest all uniformity was kept for the month of March and month of October. So the pre-monsoon and the post-monsoon conditions were also evaluated from 2013 till 2020. Coming to the satellite data sets, we basically try to assess the vegetation indices and the water indices of the region to understand how the vegetation is changing across the region and what kind of a water stress can be observed in that specific site. So that we are able to do from these equations, and the following bands were adopted for Landsat 8. So one by one, I will be going for the results and analysis. Although this work, I will not be saying that it's complete, because it's just a preliminary work, and it was quite a hectic work to move from Ranchi to Lucknow and then collect data sets from there. But based on observations, we went for understanding the services that the wetland was providing. So we had some secondary data which was already published in some of the websites. So based on those, we try to compile the specific table where the food for the migratory bird, because we saw some migratory birds over there. So the local IFS officer was helping my research fellow in getting the data sets. So in that case, it was found that the presence of migratory birds were observed. It also provides fresh water, because it was seen that some of the people were also collecting it as a drinking water source. Then villages across or close by were also collecting some kind of fibers, wood twigs from the site. But since nothing as such was published with regard to the collection of wood, so we have kept it as a cross. And since biochemical studies were not conducted, so we have avoided that. Even the genetic material role was avoided. Although I'm sure, as compared to all the wetlands, this wetland will have all these functions with them. They also help in soil formation and nutrient recycling. Only then the wetland can be managed. So taking an assumption that the wetland is still active, so we have taken this as a correct service. And for economic services, we went for the revenue generated by the wetland throughout the year, as seasonal data of money that is being collected by tourism. So that was observed. And January 2020, since lockdown was initiated in the first phase, so from the January onward, data were not available to us. So prior to the lockdown, the data were available, so that has been given. Coming to climate regulations, we went for studying the climate regulations for the comfort index, so that is observed. Water regulation is already there. Water purification, because wetlands are natural water purifiers, so that function is taken into account. Erosion regulations, because any kind of erosion and siltation will be going to the downside area, and wetland being a point of collection of those eroded material, so they also help in collection of eroded material in a specific location. Then natural hazard regulation, because the site was not related to any kind of natural hazards, so we have not given a yes to it. Among the cultural services, there were several evidences for spiritual and inspirational services that the site provides. And because when we went for the field survey, we could see how people are performing their yogas and meditating in the site. So those are one side. Then the recreational sites also. For example, there were a zone of animals or kind of monkeys, and then a site was given for the tourists to view them. Aesthetically, the entire area has an influence on your mindset. So you feel a sense of calmness when you visit a specific site. So those were given as yes, and students were also observed in the site. So we have also given a yes for educational services. So these are some of the evidences that we had collected from the site. School students coming down to the wetland, and some kind of a survey they were conducted by their geography teacher. And what you see is my scholar who is making them or informing them about the instrument that we are using for collecting the studies. So they are quite watching at the instruments very keenly. And aesthetically, the site had passages from within the site, so it was making you feel very engrossed into the greenery of the area. And yoga was going on, so such spiritual and inspirational services were provided. Now, what you see now is the economic services, where around 10 lakh was the revenue collected in the year 2018, which got increased to around 13 lakhs in 2019. The 2020 data was not obtained, but a 3 lakh increase in per year data was observed between 18 and 19. That also shows an evidence of the increase in the tourism of the site, and also how the financial revenues are being collected. Now, when we went for the vegetation services and through the quadrant method, we found some prominent species like Dhatura, Cyprus compress, Cyprus nutans, and other grass species. So those species and frequency was collected over here. So frequency, density, and abundance data is provided over here, what we are seeing. Likewise, we went for several species that were observed. So all the way from n number of species that is listed over here. So you're seeing the frequency, density, abundance of all the species terrestrial, submerged over here. And when we talk about the whether bird species are dependent on this or the migratory birds are dependent on the species found in the wetland, yes. There are several species were found, and when we went for literature review, we try to understand why these birds are basically coming to the website of this specific wetland. And it was found that, for example, Wolfia arzea, the entire plant is basically eaten by the species of mallard, red-crested pochard, and shovelers. So we also try to correlate the food supply that the specific wetland is doing and why the species of birds are coming on that specific locations. When we tried to compare the all the quadrants, so this was the observation that was made. We had species of terrestrial species, semi-aquatic species, herbs, sedges, and shrubs, and weeds. So how seasonally they vary. So in the pre-monsoon season, the terrestrial species were high, whereas as we move from pre to post-monsoon season, the semi-aquatic species also increased. So this was the database that shows the correctness of the study that was conducted. So even the herbs, sedges, and shrubs basically declined completely in the post-monsoon season. Even the amount of weed species also declined in the post-monsoon season. So this was the data sets that we observed. And Dhatura was one of the most prominent species amongst all that was found in the region. So next, as I said, to see whether the wetland has an influence on the climatic zone, and where we had used the equation given by Zhang using the correlation between the temperature and velocity. So this was a specific outlet of the 58 locations that we studied. So amongst the 58 locations, what was the overall comfort index that was obtained? So if you look at the color codes, I've shown that red is basically the warm color code, yellow is the hot, and blue is the comfort levels. Now this is based on the table that was shown earlier and based on the equations that was shown earlier. And if you look at this specific map of using Google, we had plotted it on Google Earth. So what you see is the influence that the locations close to the wetlands are more comforting at times. So the blue lines, blue spots are basically the comfort levels, and yellow are the hot spots. Now you may see that there are two different points close by. When we went on the site to verify why this variation is coming, we found that the open area near the wetland were more comforting, whereas the moment we moved just around 10 meters from the wetland and we entered the forest zone, because the wind velocity was getting stuck, so the influence of the wind velocity reduced, and hence it was more discomforting, and hence the yellow patches were observed over there. Similarly, we went for the monsoon season data sets, and if you look at the data set, this was the influence. Most of the wind directions is coming from the south to, it moves towards the west-southwest direction, and during the season. And again, if you look at the specific point locations, you will be able to understand that the dark blue and the blue shades are more cooler and comforting. So the sites near the wetland are more cooler compared to site beyond it. And as the influence zone increases, so the hotness and discomfort level also increases. I'm just about to quote one. There was one study that was conducted based on the transect method, line transect method, where it was proved that the influence of a wetland on the surrounding climate is up to 10 kilometers. So they had gone through in an urban area. So the influence zone was extending up to 10 kilometers. But we are yet to do such kind of a study in this specific patch. So maybe in the next round of research, we'll be pursuing the transect method for assessing the influence zone. Now, under the post-monsoon conditions, again, if you see, the amount of hotness has reduced with yellow. But since it's a natural winter season, so in the winter season, the amount of blue shades and the cooler and comfortable points have increased. So, but overall, the picture can be obtained that the influence of the wetland is there in the surrounding area as we move from one direction, depending on the wind directions. Based on the handheld instruments that we had, we also went for assessing the relative humidity and temperatures. So this is the overall profile. So what we did was from 58 locations that we had collected the samples, we tried to demarcate them as near wetland, moderately near to the wetland based on the proximity from the buffer zone of the wetland. And then if you see, there's a decline in the relative humidity. And that's quite natural because water bodies will result in humidity. So humidity will also result in your discomfort. If there is a wind velocity along with it, then the humidity will go down and you feel more comfort. So this is an evidence of how the humidity reduces from the area close to the wetland to the area beyond the wetland. And just the reverse of humidity was observed on the temperature profile. So the temperatures were ranging from around 9 degrees to 20 degrees centigrade from the pre, post, and pre-monsoon, monsoon, and the post-monsoon season. So this graph is also quite correctly representing from the areas near the wetlands to the town area. So as we enter the town, the influence of the wetland declines and also the temperature increases due to multiple factors. Solar intensity is also very low near the wetlands where they increase beyond the wetlands. So wind speed is high near the wetlands. Since the wind speed is high near the wetland being an open area, so the comfort level also is good enough near the wetlands. As we move beyond the wetlands, so the wind speed declines, and it will also see the temperature also increases. So these are some factors which are influencing the complete microclimatic zone of a specific region. So we also had a handheld carbon dioxide concentration meter, which was an outdoor assessment method. So this was the zone of carbon dioxide. Although not much variation was observed, but still, if you look at the graph of the near-term area, so approximately 400 was the level of carbon dioxide in the towns, whereas near the wetland is around 350 to 360. So this variation was observed. So and a lower trend was observed near the wetland and higher trend towards the townships. When we went for the satellite-based analysis, we went for NDVI. This was the output of NDVI, and based on these NDVI images for respective years, we went for the final statistical or the calculation of the area. This was the NDVI image for the post-monsoon season. So when we classify the entire NDVI images based on vegetation patterns, except for 2015, where a barren land was observed in the pre-monsoon condition, because 2014 was considered to be highly lack of rainfall was observed. So in 2015, the barren area land was increased, which declined with the rainfall that was observed in the subsequent years. And if you look at this trend, the low vegetation areas, sparse vegetation area, and moderate vegetation areas were more observed, where the zone of high vegetation was not present, which is the dense vegetation. Although being a sanctuary, it was not highly vegetated, and lot of open area with shrubs and small trees were also were seen in the site. So these were some gaps that were observed, and based on the gaps, the information has been passed on to the authorities in Lucknow, and they are planning to develop the vegetation studies. So the same, we went for the post-monsoon studies. So the post-monsoon data sets is provided over here. And then based on the NDWI, we went for the water stress across the site. So these are the figures that was obtained for the post-monsoon conditions. We also use Google Earth for understanding the elevation, because sitting at Ranchi in my research lab, I was not able to clearly understand how the water is flowing in that specific area. So we went for elevation profiling using Google Earth, and when we started using this line method and to understand which are the deepest zones, so those zones were also identified using this option. So we went for multiple direction studies for elevation set analysis using Google Earth. So what we basically understood was the core Ravanhar area in the center of the wetland was the main point of water collection. And apart from this, the source of water was Monsoon River, which was getting collected over in the Ravanhar area. And there was a Sharda Canal, which is also influencing the wetland. Now, during the dry season, non-monsoon season, Sharda Canal was also used for water supply. And that was also an influencing factor, that during the non-monsoon season, the Sharda Canal was not supplying water to the wetland, and hence the zones of drying or the drying zone of the wetland were increased. And there was an overflow from the center Ravanhar to the left side of the screen, where you see the dry patches. So this was the influence zone and a small barricade. So water overflows to those sites. So that is why NDVI images were fluctuating in the sites. So this was the overall classification that was done over there, with the patches showing which was the center point and other locations. So basically the slope is from the northwest to northeast direction, and the core zone is the Ravanhar. And from the Ravanhar, the water overflows and goes towards the eastern and the southern direction. And you have the canal system, which is coming from the northern side. So now this specific data set is quite interesting to see, because what we see is that deep water body has increased by 2020. Now, when we compare this data, when we went for year-wise comparison, we went from 13, 14 till 19. There was a decline in the deep water body, but in 2020 there was an increase in water body. Now, this could be an influence of the site being classified as a Ramsar site. So once the site was classified as a Ramsar site, after that the study showed an increase in the deep water body area. And there was a reduction in shallow water body, because due to lockdown, the water consumption and the withdrawal rates by the people from within the premises was also restricted. Also, after it being they are denoted as a Ramsar site, so the influence of the people coming in, collecting fibers, collecting water was also reduced of the local villages. So those were the influencing factors that we observed for the year 2020. So if we try to conclude based on all the aspects that we study, was that the wetland is actually providing a lot of provisioning services, regulatory services, cultural and economical services. So based on the services, it's a very influencing wetland, and we need to conserve many such wetlands across India. And since the wetlands do provide us with a lot of services, so it is essential that we safeguard them. Now, these wetlands are also home to several species of birds. So, and the vegetation that grows over there, they're also dependent on the food habitat. It's also their food habitat. So, I think it's quite essential that the water bodies, species be maintained. To some extent, the microclimatic influences can be seen near the zone, but as such, we were not able to conclude. Primarily because it was a bird sanctuary, it was already a protected area, and the influence was not seen beyond the protected area. But if we talk about such wetlands across main urban areas, maybe a pond or a tank, so we can at least conclude that if we protect our ponds, the lakes, the open tanks in the city areas, we will be able to mitigate some kind of a temperature variations coming in the city. So those influences can be done. Then wetlands can also be created by artificial methods, like we can go for construction of artificial wetlands. Now these artificial wetlands can also be used for wastewater treatment. So with the help of proper planning and discharges from domestic or industrial locations, these wetlands can be constructed, which can become a home to several species, both the flora and fauna. And then it can also help in restoring the groundwater issues. So I think one step of conserving one wetland or one ecosystem can help in solving several other functions and services. So some of these are the references. So that's all from my end.
Thank you, sir. It was a very informative study, sir, that we have learned today. Now, taking forward to the next keynote speaker, our fifth keynote speaker, Dr. Praveen Kumar Rai, Associate Professor from Department of Geography, KMC Language University, Lucknow. He previously worked as an assistant professor of remote sensing and geographical information system in the Department of Geography, Institute of Science, Banaras Hindu University. He has over 13 years of teaching and research experience in the field of geoinformatics and its applications. He received his MSc degree in geography from Banaras Hindu University in the year 2006 and MTech degree in remote sensing from Birla Institute of Technology, Misra, Ranchi in the year 2008. He was awarded his PhD degree in remote sensing and GIS from Birla Institute of Technology in the year 2012. His area of specialization is glacier mapping using remote sensing, land use land cover mapping, health GIS, natural resource mapping, and management, and regional and urban mapping in GIS using GIS. So he has published many research papers in various reputed national and international peer-reviewed journals. He has edited many books, reference books, and book chapters. He also has reviewed many international journals of a repute. So, on this note, I would like to invite Dr. Praveen Kumar Rai to take forward today's event. Sir, you are most welcome.
Thank you for your nice description for me.
Thank you,
and
sir.
thanks to organizers, Dr. Suraj and Dr. Shruti, as well as my student who is also a faculty in your institute, Dr. Varun, to invite me to deliver my lecture on this one-day international webinar. So I am very thankful to be part of this. How can I share?
Yes, yes, you are absolutely clear.
Share screen.
Yeah, your screen is visible. Please open your slide.
Is visible?
Yeah,
Yes, sir.
please do in slideshow mode if it's possible.
There's some network problem in my monitor, so I am
Okay,
just printing.
okay. Please
file.
continue. Please continue.
And I slightly changed the topic. Is not Earth observation, it is geospatial technology in the climate change and environmental monitoring. So I hope many experts have already explained many things related to geospatial technology, remote sensing technology. Previously, Dr. Kirti sir has already given very excellent lecture on wetland application of this observation technology in the wetland monitoring. So, because many of the listeners are from MSc MTech background, so they should know better about the geospatial technology, which combined by three important technologies, that is GIS, remote sensing, and the global positioning system. So the main concern is how the researchers are using the geospatial technology, Earth observation technology, Earth observation data sets in environmental monitoring, environmental mapping. So you can see when we are talking about the environmental change, so you can see the environmental change can be identified in two parts. That is the inherent type and induced type. So inherent type, that is seasonal and other natural changes, including the changes caused by natural disaster, and that may be positive or the negative changes. So either because of the natural phenomena, because of natural process, we can see some kind of inherent changes in the atmosphere, in our surface. That is the basic example is flood is coming. Because of the flood, you can see many fertile fertile land, agricultural land will be submerged, especially in the North India. So that fertile land will be submerged, waterlogged can be seen. So that kind of negative changes can be seen on the surface, especially on the river valley area. So, in the positive change, we can see when the flood, this problem, at the end of this problem, you can see the very fertile depositions can be identified in the river valley area. So that kind of positive change can also be seen. And then induced type, it is the changes can be seen due to human use and abuse also. So excessive development, industrial development, the bad practices of the human, you can see some negative changes on the environment can be identified. So pollution, the recent example is the continuous, because of the continuous discharge of the industrial wastage or hot water, you can see our the fresh water is continuously polluting. So that kind of negative changes can be seen. This is one slide which shows about the quest of human, in this, the search or research of the human to live better and better. So you can see these are the points which I included here. There is a movement from a forest into the river valley plain to live better and better, happier and happier, and then try to improve economic well-being and quality of life, let them to reach land and resources, turn more and more intelligent, innovative and enterprising, and then when the human just develops their area for better living, so then after the industrial revolution, the era of the industrial revolution has came. So after that, disparities and inequalities in development can easily be seen in either in the Western country or in the developing country, and concomitant degradation of the environment has been started. So these are the points which we can see when the human start their life and then develop some ideal places for betterment of their life or betterment of their livelihoods. So climate change and environment. So climate is not unusual, and human action are partially responsible, especially in the matter of greenhouse gas emissions effect. So mankind polluting the planet in various ways and on the scale sometimes unimaginable. And then next part is that is the population, production, automobile, continuous development of the population, production of industrial goods, development of the automobiles, air travel, exploration, waste, continuous waste generations from the industry. Sometimes you can see sanitation. We are not able to develop proper sanitation facility in the urban area. So these things is continuously degrading the environment quality. And then the main concern is just to stop the continuous discharge of the waste water in the river, in the lake, or in the some freshwater body. And then this figure shows about the earth conditions, how the human interferences are continuously degrading our the earth surface or the earth atmosphere because of the continuous emission of the greenhouse, continuous emission of the harmful gases, because of the continuous cutting of the forest. You can see the quality of the earth atmosphere is continuously deteriorating. So this is the statistic which I just mentioned here. That is the greenhouse gases released into the atmosphere in the last 250 and 300 years, and ozone status during the last 30 years. And you can see carbon dioxide increased by 25%, methane increased by 140%, nitrous oxide increased by 0.2 to 0.3% every year. So you can imagine how these gases, emission of these gases are continuously increasing day by day, and because of these additions, ozone has also decreased by 3% since 1978. And if you continue to add these at the same rate, so you can imagine the global temperature are expected by the rise of 5 degrees centigrade. So you can imagine the coastal city will be flooded, or some small island will be submerged into the ocean. And what is going to happen? So you can see, these are the statistics I mentioned here. 30% of the drop in per capita water availability by 2050. This is the statistic given by some organization. And 15 million people, especially who are living in the coastal zone, coastal area, will be displaced by the flood due to sea level rise by half to 1 meter. And you can imagine, it is not only the condition, especially to the people who are living in the coastal area, because of the continuous melting of the glacier, because of the continuous melting of the snow, the glacier area or the valley area will be flooded. And then after that, you can see when these water will enter into the oceans or the coastal belt will be flooded, and then it will be submerged. And 30% drop in general flood grain production, especially wheat in North India by 2035. Some more statistics which I mentioned here, there is a 70% fall in wheat yields if temperature rises even by half a degree. And I already told you Himalayan glaciers may totally disappear or will continuously start melting, and it shows an alarming rate and unprecedented flood in river Ganga, and later it might go dry. So these are the statistics which I analyzed, which many researchers have analyzed and give their results. These things will be, if these things will be continued, so results will be not good related to the, especially the people who are living in the coastal belt. So Wetland disease and diarrhea death would go up. 50% of total biodiversity will at risk. 25% of the coastal flora and fauna would become extinct by 2030. So this is the conditions which we imagine if these things will be continued, then this kind of conditions will be faced in the coming future. And who is responsible for this state of affairs? So approximation of resource by colonial power, rise of European power and health, trading routes and environmental spoliations, that is the history of the colonizations, destruction of native culture by expanding agriculture population, destruction of land, river, that is not destruction, that is we can say degradations of land and river water quality because of excessive development of industrial development, because of continuous urban growth, continuous increase of the population, especially in the urban area, continuous increase of the waterlogging problem, legal disposition. So that is the integral part of colonization, and that is what had happened in the past. And if that condition will continue, so our environmental conditions will, nobody can just stop the deteriorating of the environmental quality. So when we are talking about the environmental changes, so that change basically can be seen either at the local level or at the regional level or at the global level. So local, there is include the condition of the environment at either village level or district level. So small problems can be seen at this level. State and national level problem, if the flood is coming, the whole state will be affected, whole nation will be affected. If any problems which can be seen at the global level, so the 2, 3, 4 countries or the whole continent will be affected with this. So the main concern is about the severity of the problem. So on the basis of that, we can decide how much area has been affected, either it is affected at the local or regional or global level. So what is happening in the present, that is the important part. So recent models of the development in the name of globalization are perpetuating the same pattern of the resource appropriation. North is appropriating the south environmental space through resource extraction and overloading atmospheric and oceanic environmental sink. So sometimes we blame the northern hemisphere, the country who are part of the northern hemisphere, they blame to the country which is part of the southern hemisphere. They are blamed because of the continuous extraction of the resources, continuous development of the third world country, or the environment, earth environment is continuously deteriorating. So sometimes this kind of geopolitics play important roles to blame to each others, and then due to this we are not giving the concrete solutions for proper monitoring of the environment. So being a geospatial, being a man of the geospatial technology, our the main concern is to map, measure, and monitor. These are the three words which I mentioned here. Mapping of the features, mapping of the information, measurement of the information, and monitoring of the information. That is the three important part. And natural man-made bird means our main concern is proper mapping of the natural feature or man-made feature world, proper measurement of the natural feature, then man-made world, and proper monitoring. So that includes about the natural phenomena as well as the things or the feature which is constructed by the man or by any populations. So and then main concern is either we focus at local level or we focus at the regional level or we focus at the global level. That depends on the severity of the problems which I already discussed. So on a periodical and real-time basis, that is a very important part. So when we just go to prepare any map, when we go to measurement of any features at local, regional level, so the things will be on temporal, spatial temporal basis or real-time basis. That is the important part. So that we can compare the result. So when we compare the results, so we can just estimate either things is the output is coming in the negative direction or it goes in the positive direction. So that's why the RSGIS, remote sensing GIS, helps us in this regard. So which is a part of geospatial technology. If we are just using this technology, so we can easily compare the result in the spatial temporal domain. I'm not going to explain about the remote sensing GIS. You people very well know about the basic meaning of the remote sensing GIS and about the energy matter interactions. These are the basic things, and I assume that you people know all these things. The main concern is just to give about the idea how this technology is helpful. What are the applications are available in which we people are using this geospatial technologies for proper monitoring of environment, for proper management of the environment. So you can see when you're talking about the global monitoring, so environmental features that monitor includes, that is the global vegetation covers, ocean productivity, global biosphere, means monitoring of the global biospheres, proper monitoring of the ocean temperature, ozone levels, snow and ice, atmospheric pollutants, wave height and direction. So these are things which I included here. And then this slide shows about the increasing awareness and consciousness that shows about the condition of ozone, which that the whole identified in 1978, and how the things have been deteriorated because of especially in the 19th century. You can see this is the century which is remembered by the development by the for the development of industry, for the development of the urban area. Many third world countries are developed, especially in this time period. So you can see, but these countries are not properly maintained their environment. So this kind of deteriorations has been identified. So depletion developed especially in the October season. Changes seasonally means this kind of changes is identified, especially in some specific regions, gradually getting larger over time. So that shows how the things have been deteriorated from one time period to the other time period because of the excessive development, because of the continuous development of industry as well as the urban area. When you're talking about the ocean temperature, so you can see remote sensing play a very important role for identification of water body because water is strongly absorbed, especially in visible part. So when people are using visible band data or microwave data, so it's water bodies or water features can easily be identified on infrared band. Or if I just want to identify the quality as well as characteristic of water body, so these bands, these regions in electromagnetic radiations play a very important role. So water is good for approximation of a black body. So monitoring climatic events. So sometimes when we are talking about the oceanic temperature, so that data, which is very helpful for to estimate the oceanic temperature, that is the coastal zone color scale, that kind of data will be very helpful. So that will be very helpful for the movement of the El Nino, which has been started from South America and it hit to the Indian Ocean. And due to this, you can imagine how about the condition of the Indian monsoon, how the monsoon will be affected because of the continuous movement of the El Nino and La Nino effects. So that you can easily calculate it because of when the temperature, oceanic temperature suddenly will be increased in a specific season when the rainy season will be started, and then when the ideal conditions will be developed, the El Nino effects can be seen. These are the few, the list of the satellites very well, which is very helpful for oceanic to analyze the oceanic environment. That is a geostationary or operational environmental satellite, that is the GOES. I mentioned about the characteristic. I'm not going to explain, but these satellite, these sensors have some significant merits, some positive merits, which will be very helpful for proper identification of very specific environmental parameters, for monitoring of specific environmental parameters. Bright tone relative cool radiant temperature, dark tone relative warm ones, and these causes clouds which are colder than water and land to have bright signatures. That are the, you can say, the basic characteristics which we analyze during the monitoring of any specific atmospheric parameters for proper monitoring of related Earth parameters. So the second one is that is a polar orbital environmental satellite or advanced very high resolution radiometer. So these are the some important name of the environmental satellites, AVHR, and then in the same way coastal dune color scanner. So this type of oceanic sensor, environmental sensor will be very helpful, which is launched by the NASA meteorological satellite, which is part of the NASA meteorological satellite, and it is very helpful to record the chlorophyll content in this oceanic water. So turbidity in shallow coastal water. So these are the things which I already discussed about the oceanic parameter, mapping of the oceanic parameters. That is currently systems are mapped by recognizing some property of water that surrounding water, that is the remote system record following property of water, that is the colors, radiant temperatures, surface roughness, thermal plumes. So now you can see the industrial continuous in hot water discharge, industrial water is discharged and it enter into the rivers, lakes, and continuously polluting the fresh water. So sometimes it is our main concern is for proper monitoring of the continuous discharge of the industrial wastage. So this kind of thermal data, thermal bands are very helpful. When suppose I just want to identify how much discharge of thermal hot water is identified in any specific area. So if we are using Landsat data, in the Landsat data we have a thermal band. So that thermal band will be very helpful for proper monitoring of the for proper identification of withdrawal of waters from lake, rivers, and ocean to cool their presence and then return into the same water body at a higher temperature. So that kind of sensor play a very important role. So I just mentioned here about some piece of the satellite data, and that data will be very helpful for proper identification and monitoring of degraded area, means deforested area, because when you can just see the satellite data of Himalayan area or northwestern area, so that type of patches can easily be identified, and it is only because of continuous deforestation activity for development of agricultural practices, for development construction of the urban area. So the main concern is just to know how much area is continuously converted into forest to some urban area, forest to some agriculture area. So that type of data will play a very important role. If we have spatio-temporal data, so then we can estimate the changes occurred from one time period to the other time period in the specific area. So this is one satellite data which is part of Sonbhadra district, and one river which is coming from your north western part to southeastern part. You can see this is the Son river, and the one river which is seen in the southern part, which is in the sky blue color, which is the Rihan river, and you can easily identify the color differences from Son river to the Rihan river, and that differences is only because of continuous discharge of wastewater which is coming from there is a thermal plants in the nearby area. You can see a thermal plant. So continuously wastewater is discharging into the Rihan Dam, and due to this the quality of water is deteriorated and it appears as a sky blue color. That shallow, the whole Rihan Dam is appear as a shallow characteristic. So you can just imagine how the quality of water is deteriorated because of the continuous development, human intervention. And then in the other part, you can see some white patches can be identified. The whole area is the forest covered area, and because of the continuous industrial development, the forest, major forested area has been disappeared, and then some other industrial activity has been started. So you can see how the human activity is continuously deteriorating our environment, especially in the forest area or in the plateau area. This is one satellite data which shows about the development of alkalinity, salt-affected area because of continuous irrigation. So because when you can see this kind of satellite data, especially in the Eastern UP, because of the continuous irrigation practices, continuous use of the fertilizer, that type of fertile land has been converted day by day into the salt-affected area. So the farmer doesn't know about the proper management of the fertile land. So they just know when they use plenty of water into the agricultural lands, they just assume they will the agricultural production will be increased. But in results, after some time, after passing 1 year into the other year, you can see this kind of results can be seen. So in the same way, this is one satellite data which shows about the burnt area, how the forested area has been converted because of into some degraded area, and because of the forest fire activities, the blackish portions is the burnt area, and because of the human interferences, the majority of the forest area has been degraded. The loss of biodiversity can be seen. So this kind of practices is easily seen, especially in the Himalayan area as well as in the dry area of Vindhyan region. This is again some more satellite data which shows about the paleo channel. So the loss of the paleo channel is a very important problem, major problem, especially in the Eastern UP. So this kind of paleo channel is very helpful for especially to the people who are living there, and they just suppose they are dependent on the groundwater. Their agricultural practices are dependent on the groundwater. So this paleo channel geomorphic features are very helpful for groundwater mapping, groundwater monitoring. But what is happening because of flood problems? That paleo channel, that oxbow lake is the quality of oxbow lake paleo channel is deteriorating, and due to this, our groundwater condition is also polluted, contaminated. So some more satellite data which I mentioned here, that is the deforestation activity, how the spatio-temporal data is helpful to identify the continuous cutting of the forest, as well as how the forest area is deteriorated because of the flood and because of the human interferences. So these are some more satellite data. Blackish part shows about the burnt area, how we are just doing this kind of activity, and then how the important biodiversity is disappear because of development of new agriculture area or development of urban area. This is more satellite data. So these are the things which I mentioned here about the just application of satellite data for different environmental problems. So the main concern is our Earth is a system with elements where we can see water, where we can see air, where we can see land, where we can see life, and these things have some relationships. These elements have some relationships to all others. Means water is interrelated with air is interrelated with land, and then whole things are interrelated with our human life. So when the things will be deteriorated, our life will also be affected. The question are how we relate ourselves to various elements of the earth and the consequences of these relationships. That is the important questions arises during the understanding of the environment of the earth surface or earth environment. So how should we relate ourselves to the water? That is a very important part. So if we relate ourselves to the water, especially in people who are living in the river side, so then the things will be related in the religious way, and then we will try to proper monitoring of the water, proper monitoring of the river by using the technology. So how did ancient people relate themselves to the water? That is the important part. How we relate ourselves to the water and how the ancient people relate themselves to the water. So I mentioned the few lines of the Sanskrit which I translated in the English form. Water is life, water is ambrosia, water is peace, water is panacea, water is health, and water is food. Water is strength and water is sacrifice. Water is energy and water is all gods. And water is loved by gods. But what we are doing, that is the question mark. So these are the lines which I found in our Vedas. And but can we just maintain these statements which is mentioned in our Vedas? So if we are not properly maintaining the natural resources, not monitoring our natural resources, so our quality of environment, our quality of resources will continuously degrade. So this slide which I mentioned here, and many people already seen this information on the internet, as COVID-19 forces world to quarantine, so air quality pollution level has improved. So these things already given on the internet, how the things have been changed because of some restrictions, how environmental quality, environmental problem is improved in some extent. So sometime forcefully, sometime in some planned way, we can try to improve our quality of the environment. So this is a graph which is also available on the internet, which shows about how the aerosol optical depth or aerosol level is, the quality of aerosol level is improved from before the condition before 2020 and condition in 2000 after 25 March 2020. So sometime that kind of problems, with the help of one problems, the whole problems will be improved. This is again the condition of NO2 level, how the NO2 level has been, condition of NO2 level has been improved because of the restrictions, because of the lockdown problem, because of the COVID problem. So the COVID problem is the problems which is seen at the global level. Well, because of this, you can see some problem at regional level, at local level has been improved. These are things which I mentioned here, how the condition has been improved, how the things have been changed before lockdown and after lockdown. All the things have already given on the internet, but my concern is how what we are doing for our natural resources, what we are doing for our environment. That is the important part. There is one statement given by former Secretary General of United Nations, Mr. Bibi Ali. He said sustainability must be strengthened as a guiding principle of the development. That is the important part. But what we are doing for our natural resources, what we are doing for our renewable resources, what we are doing for the environment, that is questionable. So the main concern is just to use the technology for the betterment of betterment of humankind, for the betterment of proper management of the environment, to maintain the quality of the environment. And then when we are talking about India, so our country characterized by huge opportunities and ever increasing regional and global interdependence and collective actions to mitigate these risks. So our people who are living in our countries, they are just very much focused on the proper maintaining the available natural resources in the sustainable way, and government, private sector, and civil society, they are continuously working on this, and they are trying to just maintain our environment, quality of the environment. So, but the thing is, what we can't. So we can't stop economic development. We can't stop the natural climatic change, but we can't stop melting of the Himalayan glacier. These things can't be stopped by the human beings or the people who are living in the India. But what we can, we reduce or stop population growth, reduce automobile, continuous development of automobile sectors, reduce and stop polluting waters and rivers, and then reduce to reap our garbages, reduce or remove sanitation problems, use of geospatial technology in environmental impact assessment, use of geospatial technology in sustainable natural resource management and sustainable development. And finally, being a geographer, I say you not only tell people about what is happening to the environment, show them what happened past, and tell them what would be the future of their children. That is the important part. So try to just educate the people, educate the children, and then educate the children about the awareness of the environment, about how to sustain, how to maintain the quality of the environment, environmental quality, and we must have data information with us to prepare our action plans, and almost all aspects coming within ambit of economic development, climate change, and environmental environment have a spatial distributions and dimensions. So that is all about some basic description about the uses of technology, uses of geospatial technology, earth observation technology to analyze the climate change, to analyze the environmental monitoring. So being a geographer, it is our responsibility, it is our task to educate the peoples, to educate the locals, to educate the children, to educate the coming generations, or maintain the environmental quality, stop the land degradation activity, stop the pollution, or minimize the pollution. We can't stop the pollution, but we can minimize the pollution. So that is all about our lecture. So thank you. Thanks all the participants who joined me, who listened to my lecture, especially on environmental monitoring and climate change. Thank you.
Thank you, sir. Thank you for such wonderful presentation on environmental change and climate change, and how we can use geospatial technology to analyze it. Moving forward with today's event, I would like to invite our sixth keynote speaker with her brief introduction. Dr. Shaila Jamal, Associate Professor, Department of Geography, Aligarh Muslim University. She completed her education and PhD in the year 2012 from Aligarh Muslim University with gold medal in her first position in BSc and MSc. She has been awarded various prestigious scholarship and postgraduate merit scholarship, inspired fellow by DST Government of India, and best paper presentation award like Young Geographer Award at Banaras Hindu University, Professor N.P. Iyer Young Geographer Award at Punjab University, and many more under her credit. She specializes in the field of environmental issues, urban, gender, health, and many more under the topic. So, she is a prolific researcher and has published many books and research papers under a reputed national and international journal. Presently, she is also working on a project awarded by Impress ICSSR. I would now like to invite her to take forward today's event. Ma'am, you are most welcome.
Thanks, Priyanka, a lot for your kind words of appreciation. I'm really feeling overwhelmed with so much words of appreciation from your side. And I would also like to thank all the organizers for organizing such events, and especially Dr. Shruti and Dr. Suraj for organizing, taking such initiatives for such events, and for connecting with so many eminent speakers to whom we have already listened. Thank you for that. Now, coming directly, because we are having less time and I have lot to present before you. So directly coming on my topic, is the screen is visible to you? To all of you?
Yes, yes, ma'am, it is
Okay.
visible. Ma'am, please put it into slide share mode.
Yes, now it's fine?
No, it has not come, ma'am.
It will take time.
Minute.
Wait.
1 minute, 1 minute. Now is it fine?
Ma'am, it is still in the present, not in the presentation mode, ma'am.
Already I have done here in the full
Ma'am,
screen.
please convert into PDF and then share. Please convert into PDF and then share.
1 second, just give me a second. May I continue? Should I continue now?
Yes, ma'am.
Yes, ma'am. Yes.
Okay. Okay. Coming directly to my topic, that is the way forward to environmental research, the role of remote sensing and GIS. Already know still the field expeditions, the conventional methods are very much important, and it is one of the best method we can say for the data collection. But now the advancement in the geospatial technologies, we cannot ignore it. How it has made certain is investigation so rapid and more comprehensive, that so much integrated interpretations we can do.
Ma'am, your voice is not audible.
Hello, ma'am.
Actually, rain is going on in Aligarh. Maybe this is the problem.
I think ma'am is facing a little technical issue.
Priyanka?
Ma'am, can we go for the next keynote speaker,
Yes,
ma'am?
yes, we will wait for 1 minute. If
Yeah.
I think because she's having some technical problem.
Yes.
So if she'll not come for 1 minute, then we'll proceed for the next one, and then ma'am will speak after that.
Okay, ma'am. Sure, ma'am.
Priyanka, you may start.
Okay. Coming to our next speaker, Mrs. Miela Persiu, scientific researcher, HGRDD, Development Department, Institute of Geography, Romania Academy. She has over 26 publications in reputed international journal and has research project under her credit. Uh, Her area of research is natural hazards, geomorphology, climatology, and demographic changes. She has been speaking on the topic of Romania rural space, change in dynamic and demographic structure over 1992 to 2020 period. Ma'am, you're most welcome.
Thank you very much. Can you hear me?
Yes, yes, ma'am, it's clear.
Okay, thank you. Just a moment. I don't know, it's seeing my presentation. So. I don't know, you can see.
Open your PPT, please. Open your PPT.
Just a moment.
Yeah, we
You
can
can see.
Yes,
You
yes.
can see. Okay. Thank you. So the presentation, it's about the Romanian rural space and the changes that occur in the period 1992-2020. This it's a part of the research project of the institute, and we work many of the colleagues. The presentation it's structured by five parts: introduction, data and methods, study area, result and discussion, and conclusion. The current research is in line with the Romania's territorial development strategy, with the National Rural Development Plan, as well as a priority of Romania's rural development strategy. The main scope was to identify the demographic characteristic of the rural areas over the last 3 decades and the territorial disparity that occur at the local administrative unit level. There are two main research directions. The first one, it was to establishing the main indicator to be analyzed and identifying the typology related to the demographic feature which shapes the demography of the rural areas in Romania. The world context, it's a population decline, but this was not a unique process in the demographic history. During the first half of the 20th century, subject as the decline in fertility and the quality of children were argued in many Western European country. The population now is characterized by an aging and unprecedented speed. This was the result of success women empowerment, improved education, a better child, maternal and reproductive health. The population age and over represent 12.3% of the world population, and by 2050, this number is expected to rise to 22%. In Europe, we have the greatest percentage of the elderly population, which is around 25%. As a consequence, the current ratio of working age population to all the dependent population of 4:1 will be replaced by a 2:1 ratio by 2050, according to Eurostat projection. Generally, aging is a result of development. People live longer because they have a better nutrition, better condition of sanitation, healthcare, and education. Regarding the European Union context, the demographic trends, it's a demographic decline, which it's across large parts of Eastern Europe. It's in Bulgaria, in Slovakia, in Croatia. Island of demographic growth were noticed around the capital and the metropolitan cities. Generally, population decline is more likely to occur in rural region, which have the lowest population shares. However, in the Central and Eastern European countries, population decline is most frequent in the intermediate regions. The coming demographic challenge of stagnant and aging population, along with the rising health and pension claims under the continuous decrease of prospective workers, it's already generating concern for today affluent Western economies. The Eastern and Central European countries are experiencing demographic decline. This it was combined with a very low birth rates, increasing of the mortality rates, migration. For example, in Romania, we have a lot of people which are living outside Romania. In Spain, for example, they are living around 1 million people. In Italy, maybe it's the same number, and this creates a lot of problem. Romania context. Romania before 1990, it was a very we have increase of the population because we were under the communist period and the abortion was forbidden. But after the revolution, which was in 1989, we came with a transition period that was a follow-up of the demographic trends from the past, but as well as the development of a specific demographic pattern, not only for Romania, but also for a group of countries which just go out from the communist bloc. For example, Czech Republic, Slovakia. Over the last decade, population in Romania faced significant changes. It was depopulation, aging. The birth rates started decreasing after 1990. And it was an increase in dynamics of external labor mobility. We have a difference of the demographic behavior between the rural and the urban. For example, in the rural area, the birth rates are decreasing. And it's increasing the share of the elder population. The Romanian rural environment is characterized by a strong social and economic heterogeneity between different parts of the country. The socio-economic decline has led to an increased depopulation of the village, also that led to the emergence of demographic imbalance in the age and gender structure. The study area, Romania is situated in the southeast of the Europe. We have the main capital city, Bucharest, and 41 counties. The rural area is 87.1% of the country total surface. Also, it's 48% of the dwellings and 47% of the residential area. We have 2,861 communes. This include almost 13,000 villages, and the average demographic size of a commune is about 3,300 inhabitants, and for a village it's about 715 inhabitants. But we have also some situation, maybe about 200 villages in Romania. They don't have any inhabitants, but they are still existing, like the administrative one. This situation was because after 1990, many of the German people which live in Romania, they go in Germany. In 2020, the rural population it was about 9.7 million inhabitants, which represent 43.6% of Romania's population, which is 1.1% lower than in 2002. We use data and methods like population and census, housing census in 1992, 2011, and another was TEMP Online, which covers the period between 1992 and 2020. We calculated the population dynamics, which represents the percentage of population growth over 1992-2020. Population structure by large groups, which is divided in three categories: young, adult, and elderly. Vitality index or Pearl index, which represent the correlation between the birth rate and mortality. Demographic dependency index, which is calculated like the ratio between the young and elderly and adult population. Labor renewal index, which is referring to the population age 15-29 and 30-44 years old. And the activity rate as the active population, which is population between 15 and 65 years old. This was related to the total population, expressing the potential of the labor force at the level of a regional or general economy. Resultant discussion about the rural population dynamics and ruralization level. The share of the rural population dropped starting with 1992, when it was 45.9% to 44.9% in 2002 and 43.6% in 2020. Here we have a table with the number of the rural local administrative units, the number of counties, and the list of the counties by number of rural local administrative units. We have the county Ilfov, which is surrounding Bucharest. This has the lowest number of rural local administrative units, and the most we have over 90. We have in 8 counties like Bihor, Mureș, The highest values are in Dâmbovița, Giurgiu, Teleorman. We also have a graphic with the evolution of total population, which is represented with blue, and the evolution of rural population, which is represented with red between 1992 and 2020. We can see the decrease of level of ruralization. The proportion of countryside people dropped from 10.6 million in 1992 to 9.7 million in 2020, and this drop was about 8.5%. We have negative natural increase because the mortality rate is higher than the natality rate, and we have especially of the migration to town of the younger and better skilled segment once the law which had prohibited definitive settlement in large towns was abolished. This law, it was until 1990, it was forbidden to establish in a big town. Regarding the demographic size, this is very large from few inhabitants. And here we have some example. For example, Gherghedal village, which is in Sibiu County, which has 14 inhabitants. Sau Mighindoala village, which also is in Sibiu County, which has 3 inhabitants. But we have also a village with which have a size which is very close to urban dimension. Example, it's village Florești, which is has almost 30,000 inhabitants, which is near Cluj-Napoca. Another one is Holboca, almost 15,000 inhabitants. This is near Iași. Or Chiajna, which is very near to the capital, Bucharest. We have a demographic decline in 78.8% of the villages. Here we have a map with the population dynamics between 1992 2020. With circle we have with blue we have decrease, which you can see it's dominant. With yellow circle we have stagnant, and with red we have increase. And with color we have a demographic size in 2020. The high decrease it was registered in 3.1% of the counties, and most of them are situated in the south of Romania, northeast of Romania. Moderate decrease we have in most of the rural network, almost 65%. These are spread relatively all over the country. Stagnant evolution we have in 3.9% of the rural network. This was registered in south and east of Romania. Moderate increase we have in 18% of the rural network. High increase in the 1.3%, and very high increase it's near metropolitan areas of Bucharest, Cluj-Napoca, Iași, Timișoara, Sibiu, Constanța. This it was because this towns offers works, so many people are establishing near these big cities. Changes in the demographic structure. Here we have a graphic with the age structure of the population. In 1992, 2002, the share of the young population fell from the 20.6% to 19.6%. In the same time, we have a decrease also of the group of the adult group, which fell from 64.7 to 62.7%. In 2020, the share of the rural population age 0-14 years it's dropped to 16.1%. In 2002, the share of the young age group it was varying very much from a minimum of 3.9% from the total population to a maximum of 43.9%. We have here the map with the young people in 2002, and we have the dynamics of the young population between 1992 2002, and with minus we have decreases, and you can see it's dominant all over the Romania. And with plus we have the decrease. The decrease they are especially near the towns. The lowest values are registered in the western part of Romania. This part of Romania it's known for a low level of birth rate. And the highest values are local administrative unit in which we have a share of the Roma population which is higher. This ethnic group it's also very known for being high level of birth rate. And the values over the rural average 36.9 of the rural network. And the young people registered the decrease in 81.7% of the total rural network. Regarding the elderly group, we have the highest share in the south of Romania. You can see with very brown color. But also we have in the western part of Romania, especially in the Apuseni mountain. In Apuseni mountain we have special cases because there we have many villages, they don't have any inhabitants, or maybe they have 1 or 2 inhabitants, but also the villages are at a large distance from each other, maybe 10 kilometers, 15 or more. The lowest share we have some rural local administrative units which are around the big cities, Iași, Cluj-Napoca, and Constanța. And the elderly group decreased in 76.3% of the total rural network. Most demographic, we have a demographic aging trend. This is particularly from the southern and eastern part of the country. Regarding vitality index or Pearl index, over 50% of the commune have a vitality index below unity. 47 communes, meaning 1.7% of all the communes in Romania, scoring 100. This means that the number of the live-born babies it's the same with the number of the dead people. We have the highest values in south of Romania, in north and northeast. In the average for this index in 1992 it was 86.2%, but in 2020 this index dropped to 75%. We have just 35 communes with values of 100. And the higher values of this index are in the southwest in Romania, also in the center of Romania, in Cluj County. Regarding demographic dependency index, economically speaking, theoretical expression of the pressure put by the upkept population on the potential active one, we have almost half of the rural local administrative unit which are below the average, and the highest score are registered in Dâmbovița County, in Nedoara. You can see on the map with very dark brown. You can see in the middle of Romania, in southeast, in western of Romania. In 2020, the demographic dependency index dropped to 50.8%, and 55 of the communes there were the rural average in Romania. And the lowest score we have in three communes, which are in Iași County, which is in the east of Romania. And the analyzed indicator values reveal the dense degradation of the population age structure as a consequence of village depopulation. Regarding labor renewal index, this was calculated by population between 15-29 years and 30-44 years. Through this indicator, we can see if the population will be replaced. Most of the current advanced economies of the Organization for Economic Cooperation and Development shrink range is their working age group. The 1992 census data, we can see the labor renewal potential in the countryside was positive 1. It was about 1.08%. And we have with a very dark blue color, it is east of Romania. We have Botoșani, Iași, Vaslui County. These counties are very well known for the high rate of the natality. The highest values, the Suceava, Botoșani, Vaslui. On the opposite side, we have 62 communes that were subunity, which were in the southwest of Romania. In 2020, the renewal resources diminished, and the most rural local administrative unit recorded a subunit ratio. And in 2020, high values we can see mainly the eastern, northeastern, and central and western county. But you can see the big differences between these two maps, 1992 and 2002. In 2002, only a few local administrative units have green color. Over 81% of the total local administrative in Romania, the potential for the labor without the ability to maintain their demographic productive vigor. And the causes are multiple, the most important being the migration of the young labor force, which prefer to go to the urban places or especially go outside the Romania border. And another cause is the decrease of the natural balance. Regarding the general activity rate, the Europe 2020 strategy for a smart, sustainable and inclusive growth emphasizes the need to promote active aging policy. In 1992, almost half of the rural administrative unit in Romania they have rates below the national average, which was 64.4%. This level of activity had major differentiation. The minimum value being in Timiș County, which is the west of Romania, and the maximum it's in Hunedoara County, which is in the center of Romania. In 2020, the situation was similar. 40% of the rural local administrative units, the values were under the national average. The highest values are not territory concerned. The overall picture of the general activity rate, the territorial distribution for 2020, it's associated with the areas registering a decrease of total population as an effect of the increase in mortality rate and decrease in birth rate, implying the reduction of the natural balance. As a rule, the rate of activity in the countryside is lower because of the marked aging. Conclusions, the Eastern County changed the main demographic feature, departing from the national mean. This county in the Eastern were known for the high levels of fertility, of natality, but in the last year, these counties, Iași, Vaslui, Botoșan, also registered the same direction of the rest of Romania, and the main indicators start to decrease, and we have the population. A similar situation, the central and western parts, effects of the metropolitan areas are more visible than in the eastern part. We have the general dynamic of the rural population. It's negative. We have a severe aging, and also we have a feminization of the population in rural area, because the women, the elderly women, especially 70 years old, are live longer than the men. We have a decreasing birth rates, and also we have the upsurge of external migration. The population aging is affecting both rural and urban area. We have the main issue, the population is aging. We have a series of economic and social difficulties, drop of the ratio between the active and inactive population. We have a lot of retired people that this put pressure on the active population. We have a problem with the health system, or also with the pension system. After decades of rural exodus, the urban-rural flow has been increasing in the past few years. Some of the rural settlements lying close to the large cities evolve into the residential areas, because the people which are living in these rural settlements during the day they go to the big city to work, and after that they coming back for staying. At another end of spectrum are the villages located at a great distance from the major cities. That means they are geographically isolated. The post-1990 demographic decline, we have the young force emigration abroad in search for a better job. We have a positive phenomenon for some segments of the active population, and the negative impact of the demographic and social economic life of the rural communities. We have a feminization and the aging of the workforce. Growth and aging of population, national and international migration, and state of the labor market concern and demand appropriated strategies and policy. Thank you for the attention.
Thank you, ma'am. It was a wonderful presentation. We got to know quite a lot about the dynamic change of Romanian population and the demographic change over a period of time. Now, again, coming back to the session, I would like to re-invite Dr. Saila Jamal, Associate Professor, Department of Geography, Aligarh Muslim University, to start presenting her presentation again. Ma'am, you're most welcome.
Yes, yes. Thank you, Priyanka. Again, sorry for the inconvenience because of due to some weather conditions. Because of rain, I lost my network, and now I have connected with the mobile data. I don't know how much it will work, but still trying. So coming to the presentation part, now the screen is visible. Anyone can
Yes,
show
yes,
the
ma'am.
screen? Yes.
Yes,
Okay, fine.
yes.
So my topic of today's talk is that is way forward to environmental research, the role of remote sensing and GIS. Is there,
Hello, ma'am, we lost you again. Shali, ma'am, we have lost you again.
It's raining very heavily at her place. That's why I think lot of problem of
sorry. Again, one more time, I'm going to try. Yes. Sorry. Again. Now, coming directly to my talk. Now, I think the screen is shared now. The way forward for the environmental research and role of remote sensing. Role of remote sensing and GIS. So already we know that the field expeditions are the best method for collecting data, but still with the advancement of these modern geospatial technologies, we cannot ignore the use and how much we can combine it with the field expedition for better investigation and for integrated approach, for better mapping, for better monitoring, and for better decision task making. We can say that there are any number of applications of these geospatial technologies in various fields like environmental mapping of natural resources, pollution mapping, natural disaster, mineral exploration, agriculture, forestry, and all. We can say so many applications are there. So we can say that there is a need of some sort of systematic study in order to understand the role of the applications so that we can efficiently utilize it for different applications. When we observe generally the relationship between some sort of, we can say, geological, geographical, biological, physical, and chemical data, we see that it provides a very unique combination, and we can translate the interpretation in more meaningful way, we can say. And we cannot ignore in few last decades, we can see with the availability of hyperspectral images, or we can say spectrometers, which has taken the study in a very new dimension. And one of the more advantage is that as opposed to the limited point measurement, we can say that remote sensing techniques and geospatial technologies aids in continuous monitoring and mapping, which is the foremost, we can say, the advantage. But what is the need? Why we say day by day there is so much increase in environmental research? Do we need to ponder in so much environmental research? Yes, because we can see the planet has already heated up. There has not been a cool month since 438 months. If we talk about the emissions like carbon dioxide, methane, nitrous oxide, with the data set, it says that it has reached the record since 2020. Nearly 2/5 of the population is living in the regions warming by more than 1.5 degrees centigrade. And since July, we can say we have saw the highest number of extreme events since 2011. So the time in which we are living, we are breathing so bad, we can say. There are various examples of declines in nature, like we can say ecosystem extent, we can say species extinction, we can say ecological communities. Here you can see the data of number of increase in the frequency of the events of the disasters. Even we can see the sea level rise. So the time in which we are living, the number of events of certain disasters have increased, whether we talk about floods, storms, droughts, or extreme events, we can say, or even we can say the peoples affected to such disasters and hazards, that also the number of has increased many. But a few applications, how we can contribute to reduce the extremities of such events. And what is our contribution to that? We can map the vulnerable zones, we can map the vulnerable population, we can map the areas that are susceptible to such types of events, and we can reduce the frequency of such events. So the applications of this geospatial technologies, actually it helps lot in these things, like in mapping, in monitoring, and better we can say decision making. So a few of the applications in very short here I would like to show here, just like the snow cover mapping and monitoring, like in Himalayas we can say by resource sat, the sensor whips we can see here, we can map the snow cover. Even we can have the glacier mapping and the lakes, lakes mapping. If we can map the forest fire also, this is the raw image. If the person is having knowledge about this, we cannot see any sort of fire in this entire band. But once it is viewed through the SWAR, we can here point out directly, and accordingly we can proceed for the management where the forest fire can be seen. So we can also map the areas which are most prone to the flood, where the areas which get inundated during the flood time, and accordingly we can plan so the people get less affected by these things. Now, before coming to my case study, I would like to say already we have two talk about the wetlands, and my talk is also concerned with that from the two of the eminent scholars. But the perspective are very different. Here, my approach and my perspective is also very different for what we previously heard from the two of the eminent scholars, and I hope it will add some of the knowledge with different perspective. Specifically, it is the we can say wetland ecosystem monitoring of Kashmir Valley, where we have taken the three wetlands, so Wular Lake, Hokersar, and Achar Lake, three wetlands for which, and here I would like to show how the geospatial technologies, particularly the remote sensing, the application of remote sensing and GIS, how it worked in the ecosystem monitoring. So let's start. This is the map you can see here, that land use land cover change map. So application, we can say the satellite data serves as the primary source of information for the land use land cover change detection of any geographical area through different period of time, we can say. For the analysis of this land use land cover change in we can say wetlands of ecosystem in Kashmir Valley, Landsat 5 thematic mapper of 1994, then Landsat 7 enhanced thematic mapper of 2002 and 2010, and Landsat 8 OLI has been acquired from the USGS. And for the removal of geographical incongruity, all the images of land 5, 7, and 8 were co-registered to subpixel accuracy in ADAS imaging. See the applications where we are using this data in ADAS imaging. And in the present study, the maximum likelihood classification algorithm was adopted using ADAS imaging. And a total of, you can see here, 7 classes were identified. I'm not going to take the name. You can already see it here. So the land use land categories of the study area, which generally includes the buffer of, we can say, 5 square kilometer in this wetland ecosystem of the Wular Lake, it reveals that it has gone a massive land use land cover change over the last decades. Just like it reveals that agriculture is the most dominant land use around Wular Lake, followed by horticulture and marsh. And on the other hand, we can say that the area under forest plantation, water body, marsh display a negative trend in the Wular environs. Similarly, this is the land use land cover change mapping of Hokersar and Achar Lake, and the same scenario can be seen that it exhibits a positive change with an increasing trend of forest plantation, horticulture, and built up areas we can see. So it can be said that the land cover changes mainly in the wetland environs of this area, that is Kashmir Valley, have been identified as one of the main driving force behind the degradation of wetland ecosystem. Because it is mainly, we all know that it is threatened by the anthropogenic activities, maybe urban development, agriculture, horticulture practices, or impacts of, we can say, even the insecticide and pesticide, fertilizers, climate change, and sometimes also due to the invasion of, we can say, the alien species. So in not only this is enough, another application can be seen that how much land is transformed to which category. We can also map out the transformation matrix of these three water bodies. So which reveals, you can see here, it reveals that the forest cover has been occupied by the plantation, marsh, agriculture, horticulture, built up category in the last 3 decades. And similarly, we are mainly concerned with the water body. So here the water body, if you see, mainly 1200 hectares of the area of the water body of the Buller Lake is generally found unchanged, but rest has been converted into the other categories. Similarly, same is the case with the Hokersar and Achar. The Hokersar and Achar, we find out that nearly 200 hectares of the water bodies have been converted into plantation, forest, agriculture, horticulture, and other, we can say, categories. So not only this application, but moving more forward to another application, we can say that during the last few years, the water bodies, generally the water body, because we are working on this water bodies of the Kashmir Valley. So what we found in the last few years, we have seen that the water bodies of Kashmir Valleys have faced a very widespread water quality deterioration due to the increasing, we can say, human-induced factors mainly as compared to the natural factors. And we all know that the Buller Lake, Hokersar Lake, which is one of the designated Ramsar site also, and Achar Lake, one of the urban wetland, are not exception if we talk about the deterioration in the quality of the water. So here for this, the monitoring of the water quality of these water bodies was performed in order to see the status distinctions of the similarities among the different sampling sites. What are the similarities and what are the distinctions among these different sampling sites, as well as to find out the factors, whether it is, we can say, natural or human-induced factor, which affects the physical chemical parameters of these water bodies. So in order to collect the water sample for the physicochemical analysis, the sampling approach was framed such that the factors, various factors, like we can say proximity to the settlements, the spread of open waters, aquatic vegetation, and even the inlet streams were taken into consideration, which in combination determine, so that all these factors were taken together, so we can determine the overall water quality of these water bodies. You can see here, I would like to acknowledge one of my scholar, one is Suhail Ahmed, who has just completed the research work, and part of his research work under my supervision, part of his research work I am presenting here. So you can see some of the field and laboratory insights of water sample collection analysis, that how the work is going on. So collected samples after the physicochemical and statistical analysis are presented as one of, we can say, mean values, and where all these values were analyzed under expressive analysis. In total, 22 parameters of water quality were monitored. You can say some of which, that is the depth of water, turbidity, calcium, hardness, magnesium, etc. These are the 22 parameters: alkalinity, free oxygen, atomic oxygen, transparency, total phosphorus. So total 22 parameters were assessed for water quality of these water bodies. And then we can say that nearest neighbor interpolation algorithm was used for the creation of these surface quality maps for each parameter in ArcGIS, meaning 10.5. And so after this, that nearest neighbor interpolation method, we have come to this type of maps. And then after this, the water quality index was also computed. And mainly, I have already said that our analysis is based on 7 selected sites, and the water quality of wetland of Kashmir valleys, particularly we can say the Buller Lake, Achar Lake, and Hokersar, as computed by the water quality index, is found substandard and distressing, both already the parameters we have seen, the nitrate and the nitrogen and the turbidity, especially these two parameters, have crossed the desirable limits as set by the BIS and WHO. So the present study suggests that the water quality of the wetlands of Kashmir Valley mainly we can say finds its place into three categories: poor, very poor, and unsuitable. We can say unsuitable. As a result of this water quality, we can say that the wetlands are in great danger and it requires prompt treatment in order to restore the vitality of the aquatic ecosystem. Also related to this, we had the morning talk, today's talk. Not only this, another applications of the geospatial technologies can be seen while having the trophic state assessment of these water bodies. Trophic state assessment, simply we can say that it is the presence of weight of biomass at specific time and location in a water body. So in that term, that also can be assessed. So the here we can say the several parameters like Seshi disk transparency, chlorophyll 8, total phosphorus, total nitrogen were taken with different methods like Seshi disk, acetone extraction method, ascorbic acid and Gildan method. And classification categories are oligotrophic, mesotrophic, eutrophic and hypertrophic on the basis of the amount of we can say the biomass at a specific time and location. So the analysis reveals that analysis reveals that the trophic status of the wetland ecosystem of Kashmir Valley is generally eutrophic by employing, here we have employing, sorry, I have not told here we have employed different indices like Carlson trophic state index method, and also we have applied the Burns trophic level index method and OECD. The difference is in the parameters. Here we can say that in Carlson's method, nitrogen is not included, but in Burns method, total nitrogen is also included. So this is we can say trophic state assessment of the all three water bodies. And finally, what the result we have got that is based on the variables like the phosphorus, Seshi disk transparency, chlorophyll A and total nitrogen. The concentration values of these parameters in respect to the Achar, what we see depict that the state of lake is hypertonic in nature. The general trend is eutrophic, but in case of Achar we can see here that is hypertrophic in nature. And through the findings we can say that Kashmir wetlands are highly enriched with the nutrients like phosphorus and nitrogens, and the concentration values of these parameters have found very above the prescribed limits of the eutrophic levels. So another application we can say the trophic state assessment. Not only this but one of the applications regarding this wetland, because we are talking about the monitoring of wetland ecosystem. So these are the aspects that can be included. So here also the mapping out the soil erosion or soil loss and soil yield aspect. So in order to predict the extent of soil loss in the watershed, several models I have already given by the various scholars, but we can say the validation of these models in relation to the loss of soil is one of the main problem because of lack of data. So here we have used the Russell model in combination with the remote sensing and GIS, which helped in the estimation of soil erosion and its spatial distribution, we can say in much better accuracies. Because once these models are used in combination with the remote sensing data and geospatial technologies, these existing models of soil erosion forms further, we can say, one of the essential asset if we use it in combination with the remote sensing and GIS framework. So GIS mainly here helps to identify the role of all the individual variables that is used in Russell model for finding out the potential soil erosion area. What we can see here, the output of the study is mainly based on the mainly five factors, that is the rainfall, erosivity, topographic, we can say topography, soil erodibility, cover and support practices. So the study already we have seen there is significant change of land use in land cover in previous slide, which has taken place in the catchments of the Kashmir Valley, which we can say which led to the intensification of the runoff and sediment yield as well as soil loss. And we can also say the anthropogenic stress is also one of the main factor behind the change of this land use, change classification, land changes in the land use, just like the deforestation, we can say, and unplanned urbanization. In the previous slide of land use land cover already we have seen. So these changes, we can say in long run, if we talk about, this results in increased soil loss activities in the wetland catchments, leading to the generation of soil yield, causing sedimentation, siltation of these water bodies, and due to which the water holding capacities of these water bodies reduces, and which affects in one or the other way. Here also barren land is also one of the main factor in terms of the soil erosion and sediment yield. We can see for the Buller Lake here, this map shows the highest erosion risk zones are identified on the eastern and northeastern sides. And if we see for the Achar watershed, the entire watershed we can see here, the entire watershed contributes to the process of soil loss with highest erosion risk zone of northeast and the southeastern parts. So this is the major. And if we talk about the Hokersar, we will see the Hokersar watershed indicates that the most of the affected part is mainly southwestern side. So this is a sediment yield map. We can point out all the areas which are mostly affected for all these three wetlands. So here is another, we can say, the application. So overall, after studying all these things, even we can also map out the ecological vulnerability of these wetlands, catchments of our study area. And mainly this ecological vulnerability maps, final map is produced by using 13 indicators, mainly here you can see, like biological richness, disturbance index, we can say, forest fragmentation, vegetation type, land use land cover, then NDVI, then SAVI, then we can say NDSI, modified normalized difference and normalized difference moisture index, slope, temperature, then rainfall. So after this, a fuzzy extent analysis method was adopted in order to weight the selected parameters for computing the ecological vulnerability maps. So here what we have found, the final result gave that nearly about 124 square kilometer of the area of the Buller catchment and 26 kilometer in the Achar catchment and 2.72 square kilometer in the Hokersar catchment was found under very high ecological vulnerability. So thus, in those areas where the soil is bare mostly and mostly exposed, like barren lands, these are the major affected areas. North and southwestern parts of the Buller catchment are worse affected, we can say. You can see here in the map are worse affected with respect to the ecological vulnerability. Similarly, in the Hokersar, we can say the high rate of ecological vulnerability is mainly prevalent on the highlands where the man-environment interaction is at larger in case. And in Achar catchment, some pockets in the higher reaches of the catchment are found to be high ecological vulnerability. Similarly, the eastern part of the catchment depicts a much portion of the area under very high ecological vulnerability. So finishing with this, some more application, I'm not going to discuss this in very detail. Some more applications we can see here in terms of the, we can also map out the built up areas, NDBI, NDWI, and even we can also evaluate the green spaces, we can say. We can also calculate the LST, the land surface temperature, through NDVI, FPC, and emissivity, and the final map of getting into land surface temperature. So these are the few of the applications for which I talked about here. But whatever we can say, the recent advances we can see by applying these applications on our research is mainly due to the availability of satellite images at affordable price, which was not previously, we can say we are not getting at affordable price, but where now we have very much, we can say, free sources where we can get this data, and even we can get the data at affordable price, which has initiated, we can say, a revolutionary phase of monitoring such earth resources using this satellite data. So the geospatial techniques comprising of, we can say, the remote sensing, GIS, and its allied technologies is one of the most proven cost-effective and precise technique in order if we compare it with the traditional approach. But if we use these tools in combination with the existing approach of field surveys, it will give best result and comprehensive result, and it will give a better we can have the better decision making process. So lastly, I can say here that remote sensing, or even we can say the process of environmental decision making, where the environmental changes and impacts are being monitored at regular basis, can be greatly enhanced using remote sensing data and its allied techniques. If the remote sensing data is combined with the information from the other sources, like with the ground observations, the environmental monitoring techniques may further be improved. So hope more advancements we will see in more future, and more of the researches related to will enhance our knowledge. So lastly, here again, I would love to acknowledge our research team and mostly the hard work of my research scholar, that is Vani Suhail Ahmed. Thank you all.
Thank you, ma'am. Thank you for the beautiful presentation and enlightening us with such detailed research that has been conducted in Kashmir Valley. Now, taking forward this event today, now we will start with our paper presentation session. Okay, so the first presenter of the session is Nicholas, Dr. Nicholas Koronjikis, and he will be presenting on the title using remote sensing in detection of illegal landfill case study of Croatia. So you're most welcome.
Hello. First of all, I would like to thank Dr. Sura and Dr. Shruti for inviting me to this beautiful conference. So far, it was really interesting. I have been following since the morning, since in Croatia is early in the morning, and I didn't join. I mean, I was listening, but I didn't follow the discussion. So now I would like to present in, 10 minutes as my time limitation. It was my student work. Just a second, so I need to present my screen. Okay, share. So, everybody sees? Okay. So, the title of my presentation is Use of Remote Sensing in Detection of Illegal Landfills, Case Study Croatia. My name is Nikola Krančić, and I'm assistant professor at Faculty of Geotechnical Engineering at University of Zagreb. And in the last 10 years, we are teaching the lectures on environmental engineering. And I'm responsible of courses on geodesy, remote sensing, and spatial databases. The content of my presentation should be brief introduction, waste and sustainable waste management in Croatia. We used several methods and different satellite images, present results, and finally conclusions. First, what are illegal landfills? Throughout Europe and in Croatia, it is current ecological and social problem. In the Republic of Croatia, we will see why later in presentation. Waste and sustainable waste management, as Croatia is part of European Union, we need to follow European Union directive from 2008 in order to provide sustainable waste management throughout the whole country. And waste is defined as any substance or object which the holder discards or intends or must discard. And waste management is basically the process of collection, transport, recovery, and disposal of waste, including the supervision of such operations and the subsequent maintenance of disposal sites, and includes actions taken by the trader. So basically, you have one location where all the waste from some area needs to be put and defined and manufactured. Uncontrolled waste disposal ultimately disrupts the landscape, polluting the environment, increasing pests, can result in fires, underwater damage, etc. We are all aware of that. And even controlled waste disposal can lead to some of these options. However, uncontrolled waste disposal is really dangerous to our nature. Identification is possible in person or via remote sensing. In person, if you have to cover a lot of area, there is a problem with large area and personnel who needs to see this area, while via remote sensing is quite fast and it could give good results, as you will see later in the presentation. In Croatia and in European Union, there are several types of waste, such as bio-waste, biodegradable municipal waste, construction waste, inert waste, municipal waste, large waste, mixed municipal waste, marine waste, problematic waste, and production waste. As it goes for municipal waste, bio-waste, and mixed municipal waste, we have several buckets in which we are filling and separating this waste as per each household. However, for construction waste, problematic and production waste, we have specialized landfills where you can pay in order to take care of your waste. And here we have a problem because there are yet people who are not paying and not putting the waste where it should be. Rather, they just drive it into forests or rivers, etc. Based on European directive, the most desirable option for sustainable waste management would be to prevent creation of waste. However, we are all aware that this is somewhat challenging in these times. So mostly we should focus on reuse, to prepare for reuse of the waste and to recycle that waste. Next, other use application is also better than waste disposal. Waste disposal is most complicated and it is challenging in these times. So basically, the best option is preventing waste creation. What we have used in my presentation, here we have a map of Croatia, and city of Varaždin is located in north part of Croatia, and we used area of eastern Croatia, area of city Osijek for detection of illegal landfills. We used 3 different satellite images, and we have proven that images from Sentinel, which is in the middle, and right image is Landsat 8 RGB satellite image. They have limitation in poor resolution. Therefore, we decided just to use Maxar, which is commercial satellite. However, based for educational purposes, they offer free of charge specific areas of interest. So on the left, it is half meter resolution of Maxar satellite image. Next, my student went on field, so we had he followed 3 different illegal landfills. So top left image is 1 illegal landfill, top right image is 2nd illegal landfill, and bottom left is also illegal landfill, and bottom right is 1 landfill which is controlled and which is desirable. So we use that as our training sample. As you can see on these illegal landfills, they are mostly construction waste and other dangerous waste which people are not disposing correctly. Left, we have set red, green, blue image of Osijek area and surrounding villages, and we used 2 different methods. One is maximum likelihood supervised classification, and other is unsupervised classification. And in our research, unsupervised classification didn't show good results, since the limitations are in not being able to control or put some training areas, which is basically the whole point of unsupervised classification. And the supervised classification part of result is shown on right part of the screen, which is kappa value 90%, which is ranked as very high classification accuracy. After we performed supervised classification, we have made training areas of controlled landfill, which is presented on left image, very large purple stains. And after classification, we had smaller parts of illegal landfills, which are shown and selected on figure on the right part of the screen. And if you can see on the left part of the image, there are several options, and my student went and checked these three, and it's basically one after another on the same road, and it is here. It is located in the western part of the training area, and he concluded that basically based on this controlled or supervised classification, we got practically 100% correct classification of illegal landfills. So based on that, it could be checked whole area of Republic of Croatia. Many limitations which were in this presentation or this work were processing powers of our personal computers, since basically all of you which are sitting here today with us on this conference are working with some part of remote sensing or GIS data, and are aware if you are using larger areas, then processing power and graphic power of your PC is really important, because larger areas took a larger RAM memory of PC, and then the whole analysis is really long. So we had a couple of days processing on our PCs, and after we saw that the results are good, then we could proceed. So main advantages of this technique is that easily is covered large area and with great accuracy. However, limitations for much larger areas would be processing powers of personal computers. So to conclude, using remote sensing for the purpose of detecting illegal landfills lies in waste disposal, which is, as I already mentioned, the last way of disposing in the order of priority. So we should avoid waste disposal. However, people tend to illegally dump waste, and these illegal dumps are not regulated by anyone, and they pose a huge threat to our environment, basically on drinking water and our soils. And when we detect them by remote sensing, it is easier for responsible personnel to act on it. Advantages and disadvantages I have mentioned before on the figures. So we have many free to download satellite mission imagery. However, there are still limitations in spectral and spatial resolution of some figures. However, we can also buy or ask for educational purposes different better resolutions satellite imagers, such as Maxar or other manufacturers, PlanetScope, etc., or Google Earth imagery. This method of supervised classification was proven to be really high accuracy. However, unsupervised didn't achieve such a good result, so we have discarded it from our research. Thank you for your attention, and if you have any questions, please feel free to ask.
Thank you, sir. It was a wonderful presentation. So we will move to our second presenter, Mr. Muhammad Faizan O. And his topic of presentation is spatiotemporal mapping of Kambaram Reserve of Tamil Nadu, India, using GIS and remote sensing techniques.
Yes, ma'am. I'll be presenting on behalf of my team, Mohammed Faizan and Khadija Sabrin.
Okay.
Yeah, it's a small request that please turn on your camera so that we can identify, and
Okay.
please share your presentation.
Okay.
Oh. Dr. Nicola, it's a request that post completion you can have a few questionnaire from the student if there is any query relating to her presentation.
Yes, I'm also available. I can write email if someone wants to ask me personal, no problem. I will be here till the end of this conference, so no problem.
Yeah, you may start your presentation.
Good evening, everyone. I am a BE Geoinformatics student from College of Engineering, Gindi, Anna University. Um, my name is Sabrin Sadak, and we are a team of three: Mohammed Faizan and Khadija Sabrin. So I'll be presenting on the topic spatial temporal mapping of the Chembrambakam Reservoir of Tamil Nadu using GIS and remote sensing. Yeah. So, as we all know, remote sensing means the gathering of information about the Earth from a distance. So here we can use this in various aspects, and a few aspects we'll be discussing here, and spatial and temporal mapping and surface dynamics of water bodies. So we dealing with water bodies here. So these two are the main aspects here, and spatial and temporal mapping of the Chandramakam Lake is our aim of the study, and modified normalized difference vegetation index is a spectral index which we used in this study, and we'll be discussing that further. We carried out this study for 3 decades from 1991 to 2020, and it is the mapping of the water spread area of the Chembrambakam Reservoir. Okay, so water being an essential component, and it's a vital part of our daily lives. These water bodies are being degraded, like due to various reasons, and uh, so we tend to exploit water, and the water is getting polluted uh, by various factors, and there's a risk of overuse of water, and it may be due to two primary reasons, which are rapid urbanization and the poor management of water resources. And in order to protect the water bodies and to provide water to the people, and we need to conserve water, and suitable steps should be undertaken. And one such step is that we need to assess what's happening to the natural resources, what's happening to the water body, and then we can carry out the further measures. And these measures, one such tool to assess and monitor the changes of water bodies is remote sensing and geographical information system. These two play a vital role in monitoring the Earth's surface, and it's been applied in various aspects of life. Okay. So uses of satellite imagery. So satellite imagery is very advantageous way now, and we can make use of the technology at its best. And since technology has given us the advantage of gathering information from a distance without an actual contact, it means a lot of ease to us and reduces a lot of physical work. And so we can map the natural resources, we can monitor the water bodies. We can monitor the changes happening to the water bodies, or what are the changes which can be seen in and around the water bodies. And this can also be used to assess the climate change and changes in the hydrological cycle, carbon cycle. Okay, and spatial and temporal variation, variation of a certain natural resources or certain land cover over time. All these can be assessed efficiently using language imagery. And spatial techniques, spectral techniques, indices. Spectral indices are used here to extract a particular information about the resource, maybe a water resource. And it has various it has numerous application. And here we will be seeing about the application pertaining to the water body and monitoring of water body. And the one advantage is of Landsat imagery. So Landsat imagery has the capability to provide us continuous time series data. That's why I was able to use the imageries from 1990 here. And it's also been made available free for us to use, and it's many researches are being carried out using Landsat imagery. And so the aim of the study is to map the decadal changes in Chandrabakam reservoir of Tamil Nadu. And we have divided this study into two parts, like pre-monsoon and post-monsoon. So images of pre-monsoon are taken separately, and then post-monsoon taken. And then we are applying NDWI index, normalized difference water index. This is to assess and monitor the water, to demarcate a water body. And as I told, I have used Landsat imagery. So Landsat 4, 5, 7, and 8 imageries have been used here. So the platform used for this is a QGIS Quantum GIS, and it's an open source software where we can make use of a lot of free plugins available, and it has been very good, and it's also yielded very good results. And time period is for 3 decades, from 1991 to 2020. Okay, the study area. The study area is situated in Chennai. Chennai is a city in Tamil Nadu. And the geographical coordinates of this lake is 13.01158 degree north latitude and 80.0603 east longitude. And the total area of this lake covers a 15 kilometer square. And the full tank capacity is 26.03 meters, and the total capacity is 108 million meter cube. And the level which is usually the tank is 23 meters. And so I'll show visual map of the place. So this is Tamil Nadu. Tamil Nadu is a state, a southern state, and in the southern state, the Chandrabakam is situated here in this place near Chennai, and this is the image of the Chandrabakam Lake. And Chandrabakam Lake is one of the vital source of metro water to the Chennai and its suburbs, and it has been the major source next to Kulal Lake. And so the data sets used here is the medium resolution satellite imagery, Landsat. So the selection was such that the cloud cover is up to 10% and not exceeding 10%, and minimal snow cover was used. And 14 Landsat images were used here, were 7 for the
Please
3 months.
summarize. Please summarize. Summarize.
Okay. So the 14 Landsat images were used here. So these Landsat images were taken from 1991 to 2020. For each year, one pre-monsoon season pre-monsoon season image and one post-monsoon season image was taken in such a way that we have taken 7 scenes from nine for from 1991 to 2000. So with the 5-year gap, so the data sets were 1991, 1995, 2000, 2005, 2010, 2015, and 2020. A total of 14 Landsat images were downloaded from the USGS website. Okay, and this is the data which we selected. So Landsat 4 and 5. So Landsat 4 and 5, the years were 1991, 1995, and 2010. So for pre-monsoon season, we have taken dates around May, before the commencement of the northeast monsoon. So after the commencement, after northeast monsoon, we have taken the post-monsoon images, which were around October to December. And then for Landsat 7, again images of May or in and around May were taken, and for post monsoon it's around October to December. And Landsat 8, Landsat 8 2015 and 2020. For these 2 years it was taken, and for May and June. And then for post monsoon season, it was taken on October and 2000 and July. Due to Niva cyclone, we were not able to get cloud-free images in 2020 in around October due to the Niva cyclone, which happened, which had its landfall between Chennai and Puducherry. We were not able to find cloud-free images, hence so we were forced to take July. And then, so methodology used for this study is, first is data collection. So data collection, data were downloaded from the USGS website, Landsat 4, 5, 7, and 8.
Please summarize. Please show your results. You show your results.
Yes, sir.
10 minutes of presentation is allowed. You have exceeded more than 20 minutes till now, and you have not yet shown your results. So
okay.
Focus on your results.
Okay, sir. Okay, sir. Okay, sir. Okay. Modified normalized difference water index is used here. So this water index diminishes built-up area and enhances water features. And the formula goes. So it makes use of green and shortwave IR bands. And then the formula is as follows. And then these are the results and discussion. So in 1991, we can see that the Chambramakkam Lake is relatively small in size, but in the post-monsoon season, the lake has a more water spread area, and a similar water spread area has been observed in the next year, not next year, for the next after 5 years, and then for post-monsoon it has diminished, and then for pre-monsoon it's pre-monsoon 2010. And for post-monsoon, it's nearly the same. And for 2015, it has increased a little bit. And 2015 post-monsoon, it's here. And I show you the calculated water spread area. So for pre-monsoon season, these were the values have been tabulated here. The water spread area of the reservoir. And this is the time series graph, and we can see the water spread area was maximum in both post monsoon and pre monsoon. The is peak in 1995. The blue line indicates the pre monsoon area, pre monsoon, and the post monsoon is indicated by the red line. So maximum of water spread has been observed in 1995, and minimum is observed minimum of post monsoon water spread in 2000, and in 2005 there's again a sharp increase. Okay, and the distribution of water throughout the study period for both the pre-monsoon and post-monsoon was maximum in 1995. So the area was 31.684 square kilometer, and for post-monsoon it was 22.99 square kilometers. Hence, NDWI norm modified NDWI index was effectively used to monitor and to map and to demarcate the water spread area of Chembalavakkam Reservoir effectively. Thank you.
Thank you. Thank you for presentation. So we will go forward for the third presentation.
Ask Dr. Nicola if he wants any question or if there is any query. If not, if he says okay, then proceed to next.
Okay. Dr. Nicola, sir, are there any questions to her?
No. I just have one remark, and Dr. Surya already said when you're time limited, please follow the timestamp of 10 minutes. Thank you.
Yes, sir. Yes. Thank you. I'll do it. I'll take this. Thank you, sir.
Okay. So we are moving forward with our third presenter, Mr. Rahul Sharma. His topic of presentation is municipal waste generation and environment degradation in India. Please stop sharing the screen so that Mr. Rahul can present his present paper. Yeah, Mr. Rahul.
Priyanka, check whether he has joined or not.
Yes, ma'am. I'll just check through them. No, ma'am, he's not there.
Better you take a attendance of all the presenters who are present. Thereafter, if somebody wants to present, his name is not listed, you include his name and then you proceed in a continuous manner.
Okay.
Otherwise, it will you have to wait for 10 minutes. There is no one. So better the names are with you. Ask
Yes,
their
sir.
name who are present, and then we'll start in sequence.
Okay.
If anybody is left, we'll add his or her name.
Okay. Name forward from Mr. Rahul. Next presenter will be Mr. Tapas Das. Is he there? Tapas Das. Mr. Mahavir Singh. Mr. Mahavir Singh. Dr. P. Sithavallai Valam.
Yes, I think he is present.
Dr. Venkata Kamal.
Yes, ma'am. I am present here.
Okay. Okay. Mr. Deepak Kumar Mandal.
Check, Priyanka. Check their names.
Yes.
Check their names.
Yes.
Excuse me, ma'am.
Yes.
Ma'am, a small correction. I'm Mr. Venkat Kamal Lal. Actually, it was there Dr. Venkat Kamal Lal.
Okay. Yeah. Corrected.
Thank you, ma'am.
Okay. Next is Mr. Gudiri Hitkam. Is he there? Deepak Kumar Mandal. Deepak Kumar Mandal. Okay. Yeah. All right. Miss Sonam Banerjee. Miss Sonam Banerjee. Mr. Deepak Kumar Mandal, Sonam Banerjee, Vishnu Kumar. Mr. Vishnu Kumar. Dr. Sandhya. So they are the names. Anyone else who wants to present whose names are not been called yet? Okay. Okay. Marked. So shall we start? I've marked all those who have raised their hands here in the comment section.
Okay, there is one Dr. P. Santhivalam.
Yes, his name there is.
Yeah. Start.
Marked.
Start.
Okay. So Mr. Tapas Das is not there. So we will start with Dr. P. Senthivalan.
Yes, sir. Please start your presentation. Unmute yourself, Dr. P. Senthivalam. Unmute yourself. Unmute. Yeah, Pranay,
You have
please
to
unmute him.
No, sir. This is from their side. They have to
Okay.
unmute themselves.
Okay.
Don't have that control to unmute anyone.
You have to unmute yourself, sir. Please select the appropriate option. So as
प्रणय स्क्रीनशॉट लेके उसमें फॉरवर्ड कर दो मैसेज में.
we cannot hear you. Please check your appropriate option so that we can hear you. Unmute yourself. There is an icon in front of you. Whether you have joined through a laptop, you have to just uncheck it and you can easily present. Who is this?
We can start with next presenter. He is next
If there
presenter.
is a problem, next presenter.
Okay.
Whose
Although,
presentation is shared?
sir, next presenter is Venkata Keel.
My presentation.
Yeah. Who is this?
Sir, this is
Hicham Gudari. Hicham Gudari.
Hicham Gudari. Sir, Gudari Hicham.
Yeah. Yeah. His name is listed.
Is listed, but sir,
Yes.
he's after Venkata Kamal Lal.
Koina. He has shared, so
Yes.
continue.
Okay.
Please do in
Can I
slide
present
share mode.
this
Slide
one?
share mode.
Yes.
Slide share mode. Select the option slide share mode. In downwards, there is an option. Yeah.
Can you see my presentation?
Yes.
Yeah. We can see. We can see. You start your presentation.
Hi, committee. I present myself. My name is my research is assessment physico-chemical of the gas aquifer on the eastern region of Morocco. Of Wetland in Morocco. In the first step, I will present introduction, general view, and after material and methods, after results and discussion. In the finish, I will finish with the conclusion. In the first step, I will introduce my work, the natural water in the world. Indeed, the potential of natural water resources is evaluated at 22 in cubic area, equivalent of 750 cubic commonly accepted as a critical. There should index the appearance of shortage in addition to this limitation of water resources. Is the degradation of water.
Sorry to interrupt, but your slide is not changing. Your slide is not changing. Slide is not changing. Your slide is not changing.
You cannot.
We are not able to see your slides changing. Means it's constant. It's stagnant.
No.
Yeah.
Now, okay. Now it's working.
Please select the current slides which you want to focus and concentrate on 10 minutes only. Don't start for 30 minutes presentation, as we have got good number of presenters who are available with us. Yeah.
There is the degradation of water quality in in order to identify the origin of the observed degradation of water resources, it's necessary to draw up an inventory of the source of water pollution on the entire surface of the Garrett aquifer. This inventory, based on update, field surveys, and water resources analysis, covered all the main sources of pollution: domestic, industrial, agriculture, mining, accidental pollution, landfills, and cemeteries. After we pass to the geology of the region, the prairies are large structural units characterized by lower relief located facial and mesorifacial zones. Its territory is merely represented by highly developed Marley series of same age with an olistotomic character. The study area covers an area of 650 kilometer and includes the Garib Buarg and Plain Buarg, are bordered by the Garib Kbdana ranges to the south and east of Sisota and Bnei Boyfror mountains to the west. Two plains of Garib Buarg are underlain by silt, limestone, alluvium, gravel, and marl. In the new to the west of the plain boundary is geological formation are underlain by the volcanic formation of Bnei Boyfror and Garib. This is the map of geology of Garib Buarg. After we pass to the climate in the Garib Buarg basin in summer with temperatures around 35 degrees. Winter temperatures are relatively mild during the day around 15 degrees. Annual temperature is about 18 degrees. The basin has a subtropical Mediterranean climate. In this diagram, we have pre-monsoon monsoon in we distinct two periods, summer periods and winter periods for in
Please summarize your presentation. Please summarize. You have exceeded your time. Please complete your results and conclusion. Conclude. What is your major outcome? You just focus on that because your voice is also not clear. So please conclude.
I can hear you.
Gudari, please conclude. Come to the results because your voice is also breaking and it is not clear. Please come to the results and conclude.
Okay, sir. Pass to the results. Chemical and bacteriological analysis in this diagram, as you see, variation of conductivity. Conductivity increase and decrease in the south of this basin because of salinity and phenomenon of Messinian crise. And in this you see the variation of pH in the south west, in the southwest and the northwest. You see that pH increase and decrease in the southeast. and in variation of nitrate, variation because of the use of fertilizers in these sprays, and the nitrate exceeds the standards. After we see you see the variation of sodium, and because of the humidity in these places. In the next view, you see the diagram of paper. We have two phases, chloride sulfatic and chloride sodic. Because of salinity, we conclude the degradation of the quality of water resources is one of the major problems of the water sector in the reef. Indeed, the cost of water quality degradation due to different sources of pollution was evaluated in 203 critical level district, and increased pollution problems are generated by the different sources of pollution and agriculture pollution. My work is finished. Thank you for all your attention.
Okay. Dr. Nicholas, any questions to him, or should we proceed with the next presenter?
We can proceed with next presenter, please.
Okay.
Please stop sharing your screen. Ask the earlier presenter to stop.
Yeah, Gudari, please stop sharing your screen. Mr. Gudari? Okay. Next presenter is Mr. Mahavir. Mr. Mahavir Singh? His topic of presentation is relevance of environment in present era.
सभी को नमस्कार। मैं महावीर सिंह और भूगोल विषय से शोधार्थी हूँ श्री कुशाल दास विश्वविद्यालय मानगढ़ से, और मेरा आज का टॉपिक है रिलेवेंस ऑफ एनवायरनमेंट ऑफ प्रेजेंट एरा, वर्तमान युग में।
क्षमा कीजिए आपको इंटरप्ट करने के लिए सर, प्लीज आप कैमरा ऑन कर लीजिए। प्लीज टर्न ऑन द कैमरा एंड प्रेजेंट योर पीपीटी।
महावीर सिंह, शोधार्थी भूगोल श्री कुशाल दास विश्वविद्यालय मानगढ़ से हूँ, और मेरा टॉपिक है पेपर प्रेजेंटेशन का वर्तमान युग में पर्यावरण की प्रासंगिकता। इसमें मैंने सबसे पहले प्रस्तावना को रखा है कि सभी प्रकार के जो प्राकृतिक तत्व हैं जो जीवन को संभव बनाते हैं वो पर्यावरण के अंतर्गत आते हैं, जैसे कि पानी है, हवा है, भूमि है, प्रकाश है, आग है, जंगल, जानवर इत्यादि। ऐसा माना जाता है कि पृथ्वी एक ऐसा ग्रह है जिस पर जीवन है, और जीवन के अस्तित्व को बनाए रखने के लिए पर्यावरण बहुत ही जरूरी है। उसके बाद में हमने दूसरा टॉपिक लिया था पर्यावरण प्रदूषण का हमारे जीवन पर क्या प्रभाव पड़ता है। पर्यावरण के अभाव में हमें जीवन की कल्पना नहीं कर सके, और हमें भविष्य में जीवन को बचाए रखने के लिए पर्यावरण की सुरक्षा को सुनिश्चित करना होगा। और पृथ्वी पर जो निवास करने वाले प्रत्येक व्यक्ति है उसकी जिम्मेदारी ये बनती है कि हर व्यक्ति सामने आए तथा पर्यावरण संरक्षण की मुहिम का हिस्सा बने। पृथ्वी विभिन्न चक्र हैं जो नियमित तौर पर पर्यावरण के जीवित चीजों के मध्य घटित होकर प्रकृति का संतुलन बनाए रखते हैं, और जब एक चक्र विक्षिप्त होता है, डिस्टर्ब होता है, तो पर्यावरण संतुलन भी उससे विक्षिप्त होता है, जो निश्चित रूप से मानव जीवन को प्रभावित करता है। वैसे ही जैसे मनुष्य को प्रकृति के द्वारा बनाया गया पृथ्वी का सबसे बुद्धिमान प्राणी माना जाता है, उनमें ब्रह्मांड के तत्व को जानने की बहुत उत्सुकता होती है, जो कि उन्हें तक उनकी की ओर अग्रसर करता है। उसके बाद में हमने अगला टॉपिक लिया था पर्यावरण का क्या महत्व होता है। हम सभी के जीवन में इस तरह की तकनीकें उत्पन्न हुई हैं जो दिन प्रतिदिन जीवन की संभावना को खतरे में डाल रही हैं तथा पर्यावरण को नष्ट कर रही हैं। जिस तरह से प्राकृतिक हवा है, पानी है, मिट्टी है, ये सब दूषित हो रहे हैं, और हमें ऐसा प्रतीत हो रहा है जैसा कि एक दिन हमें बहुत हानि पहुंचा सकते हैं, और यहाँ तक कि इसने अपना बुरा प्रभाव मनुष्य पर, जानवर, पेड़ पौधे, अन्य जीवित प्राणियों पर दिखाना भी शुरू कर दिया है। जो कृत्रिम रूप से जो तैयार खाद है और हानिकारक रसायनों का जो उपयोग है, उससे मिट्टी की उर्वरता शक्ति नष्ट होती है, तथा हम जो भी रोज खाना खाते हैं, जो हम रोज खाना खाते हैं, हेलो हेलो, आवाज नहीं आ रही सर।
हाँ जी,
हाँ, जो
यस यस, आप बोलिए।
तथा जो रोज खाना खाते हैं उसके माध्यम से भी हमारे शरीर में बहुत सारे कीटाणु विकसित हो जाते हैं, जो कि कंपनियों से जो निकलने वाला जो हानिकारक धुआं है वो भी हमारी प्राकृतिक हवा को दूषित करता है, जिससे हमारा स्वास्थ्य प्रभावित होता है, क्योंकि हमें हमेशा सांस के माध्यम से इसे हमें ग्रहण करते हैं। हेलो, आवाज नहीं आ रही सर। उसके बाद
हाँ जी, आप बोलते रहिए, आवाज आएगी नहीं, आप बोलते रहिए।
ठीक, ओके सर। आगे हमारा टॉपिक रहेगा पर्यावरण के प्रति हमारी क्या जिम्मेदारियां बनती हैं। प्रदूषण में वृद्धि और प्राकृतिक स्रोत में तेजी से कमी का मुख्य कारण यही है। इससे न केवल वन्य जीवन और पेड़ों को नुकसान होता है, बल्कि उनके द्वारा इकोसिस्टम भी बाधित होता है, प्रभावित होता है। आधुनिक जीवन की इस व्यस्तता में हम कुछ बुरी आदतों को बदलना होगा, और इसके लिए हमें आवश्यक है कि हमें दैनिक जीवन में कुछ करना पड़ेगा। और ये सत्य भी है कि नष्ट होते पर्यावरण के लिए हमारे द्वारा किया गया छोटा सा भी प्रयास बड़ा सकारात्मक बदलाव कर सकता है। हम अपने स्वार्थ की पूर्ति तथा विनाश कामनाओं के लिए प्राकृतिक संसाधनों का उपयोग है वो गलत उपयोग नहीं करना चाहिए। उसके बाद में हमारा लास्ट टॉपिक है निष्कर्ष। इसे हमें क्या निष्कर्ष निकलता है? हमें इस बात का ख्याल रखना चाहिए कि आधुनिक तकनीक पारिस्थितिक संतुलन को भविष्य में कभी विक्षिप्त नहीं कर सकते। समय आ चुका है कि हम प्राकृतिक संसाधनों का जो अपव्यय है उसको बंद करें और उनका विवेकपूर्ण तरीके से उपयोग करें, और हमें हमारे जीवन को बेहतर बनाने के लिए विज्ञान तथा तकनीक को विकसित करना चाहिए। और समय पर इस बात का ध्यान भी रखना चाहिए कि ये वैज्ञानिक विकास भविष्य में पर्यावरण को किसी भी प्रकार के नुकसान से न पहुंचाएं, इसके हमें प्रयास करना चाहिए। नमस्कार।
Thank you. Priyanka, next.
Yes, thank you. Next presenter is Mr. Venkata Kamal Lal Mingua.
Yes, ma'am, I'm here.
Okay. Turn on your camera and please present your presentation. And try to conclude within 10 minutes.
Sure, ma'am. Yeah. Good evening to everyone. I'm Mr. Venkat Kamal Lal. I'm an assistant professor in Anurag University, Hyderabad. My topic is simulation of urban flood management by using stormwater management model. First, we'll see what are the major causes of these urban floods. Of course, there will be numerous causes of these urban floods, but in this study, I have concentrated only on the infiltration, which has a major impact in it. First, let us understand what is meant by infiltration. The major misconception happening is the difference between infiltration and percolation. Infiltration is the process by which water on the ground surface enters the soil. That means soon after any kind of precipitation happens anywhere, the initial intake, the top layer of the soil will absorb some water. That one we are naming as infiltration, whereas percolation, after a certain amount of time, the water which had already got infiltrated into the top layer of the soil will eventually go and join with groundwater table. This is the process through which groundwater also will get recharged in number of ways. But when coming to the urbanization, problem happening is the top layer or the soil surface is completely covered by impervious layers. Here we will see natural ground cover and 20% of impervious surface and 35 to 50% of impervious surface and 75 to 100%. Whereas in case of natural ground cover, 25% shallow infiltration happens and 25% deep infiltration happens and 40% evapotranspiration happens. When rain occurs, if some amount of water will get infiltrated into the soil and some amount of water will get evaporated. So it's a natural process where we can experience more rainfall and also the groundwater recharge at the same time. But due to the urbanization, 75% to 100% of the area has been covered with impervious layer where there is no chance of water getting infiltrated or percolated into the soil. Hence, evapotranspiration rate also very less because of the rooftops. Now, what I have done is I have simulated an area with stormwater management model. What is the stormwater management model? It is a tool, it's a software, it is an open source software. The main purpose of the stormwater management model is simulate hydrology, hydraulics, and water quality in urban areas. So it was developed by US Environmental Protection Agency, and there are also related softwares, XPSSWMM, PCSSWMM, MyCarbon. Comparatively, all other alternate softwares which were available for simulating hydrology, hydraulics, and water quality in urban areas, SWMM, Stormwater Management Model, has shown proficiency result and which is very easy to use. So what is SWMM? SWMM is a rainfall runoff simulation model used for simulation of runoff quantity and quality from urban areas. It is not only about simulation only rainfall and runoff, the water quality and also can be simulated, and the water can be transferred by using junctions, conduits, and with the help of storage tanks. If we were capable of transferring water, then what would be the result? These and all simulations and modelings can be done by SWMM. So the major modeling capabilities of SWMM were time varying rainfall, evaporation of standing surface water, snow accumulation and melting, rainfall interception from depression storage, etc. But the major concern of this particular study has been taken for the modeling of this particular thing, where infiltration has to be increased. For that, what are the possible techniques we can use after infiltration has been increased? So what is the amount of rainfall which is getting percolated and infiltrated into the soil, so that how much flood we are able to eradicate? Applications of SWMM. See, it will design and sizing of the drainage systems, components of floods. In this present study, I have taken few storage units and I have kept some conduits, junctions over there, so that the water which is resulting into the flood can be taken away by using of junctions and conduits in that particular area, and eventually I can store the water. So this SWMM software interface will be looking like this. So it's much similar to a StatPro software. Here we can import our study area, then after importing we can create so many junctions, and first of all we can divide entire area into subcatchments for just our comfort purpose. After dividing into subcatchments, we can input how many conduits, junctions we need. After that we can start simulation. So here my abstract of the study is, if we can increase the rate of the infiltration gradually, there will be reduction in the drainage problems and increase in the groundwater table recharge. So only one thing, increase in infiltration rate will create groundwater table recharge, and also it will reduce the all drainage issues, flooding issues which we were facing in urban areas. So what is my major objectives of the study is managing the floods in urban area in economical way by placing minimum number of conduits and junctions by using SWMM software. Yes, apart from this, I am using some LID, low impact development techniques, to increase the rate of the infiltration. Eventually, I can able to minimize the surface runoff and eradicate the urban floods which we were facing these days. So for that, I have collected any area. Study area is Chennai T Nagar. So why I have selected only Chennai T Nagar? It is the most affected area when even a minimum flood occurs in that area. What would be the reason behind it is the soil particles which were present in that area have been compacted. So many years have been compacted, hence it is not allowing infiltration. And there are two types of soils in this particular study area. One is black cotton soil and one is red soil. So what is my methodology is, by using SWMM software, I have planned to store the runoff water in overhead tanks through collecting through conduits and junctions. So to increase, apart from that, the area where soil is getting exposed to the atmosphere, I need to improve infiltration rate in that area. For that, I have followed two LID techniques. First one is mixing the boulders with soil. The second one is replacing the base soil sub-base of the layer. So I have done some experimental study regarding this. These are my experimental model. So first one, clayey soil mixed with boulders. So here clayey soil is available in Chennai T Nagar area. I have taken the soil samples from there, and also red soil is available. From that, as it is being highly compacted, what I have done, following the LID techniques, first one I have mixed with boulders, second one I have mixed with the sand layer. In the same way, compacted soil, red soil also there, so that I have experimented among all the 4 soils. From the experiments, I found that results, these are the experimental results which I found. In fact, here, clayey soil replaced with sand layer. So first LID technique is that clayey soil I have replaced with sand layer. Infiltration rate, first 15 liters. I have decided to pour 45 liters among my experimental pit over there, completely based on the literature. I have taken such calculations. So when I have done the experiments, I have replaced with sand layer. I found infiltration rate has been increased. Starting infiltration is bit low, lateral gradually it is being increased. Likewise, I have done infiltration capacity for clayey soil replaced with sand layer. It also has shown result proficiently, and also this is for mixed with boulders. I have just removed some soil from that particular place, and I have mixed the soil particles with boulders. So it was also shown the proficient results. So from the study, these are my specific graphs which came from the experimental results. So finally, by using stormwater management model, after using these LID techniques for infiltration increasement, so what I have achieved finally is totally precipitation occurred. The rainfall data I have collected from IMD department. So total precipitation, high precipitation is 608.428 acre feet. So evaporation loss I have considered as 0. Why? Because for the complete, obviously evaporation will be there, but I have designed if evaporation loss is 0. So I need to treat complete water. So I need to store the water, so that I need to eradicate this urban floods. So infiltration loss, it has been resulted into 456.321 acre feet and surface runoff 150.236. So this is the result which I got. From that, what can I conclude is, based on the simulation carried out in stormwater management model, the infiltration loss has been increased and runoff loss is less than the infiltration rate. The main aim of the study is to increase the infiltration rate. After that, modeling, doing simulation by using SWMM. So increase the infiltration rate, low impact development methods were used. So they are soil mixed with boulders and soil mixed with replaced sand layer. When we have compared from both the models, so we found that soil replaced with sand shown the higher infiltration rate with respect to the soil mixed with boulders. So soil replaced with the sand layer is the best method to practice infiltration rate. And also by using SWMM, I have modeled from the simulation, I have achieved almost 86% of increase in the infiltration rate. Thank you.
Thank you. Dr. Nicholas, sir, any questions? Sir?
Yes, hello. So I was wondering, in which ratio did you mix clay with your other soils? You didn't.
It's completely based on the literature which we have studied, sir. Actually, based on the sample which we have collected from that place, we have added boulders. So probably 30% of sand layer has been used, and boulders, 40% of boulders which were used. It is why? Because the complete soil has been compacted over there from many years, so it is easily getting affected. Even with a small amount of precipitation has been occurring over there.
Okay, thank you. And second question. Okay, you did experiment here in your laboratory and in your software, yes, and you provided infiltration loss. It is considerable based on your results. However, how do you plan it to achieve it on field, where you have large areas of clay? How would you mix it?
Yeah, field
what are the
cost
cost to benefit ratio, please, sir?
Yes, a study is completely on urban floods only. So in urban areas, we can see very less amount of soil is getting exposed to the atmosphere. That is the reason here low impact development techniques have been implemented, without which in a remote area where complete soil is getting exposed to the atmosphere, practicing these kind of low impact development techniques is highly impossible and not economical too. That's the reason here urban flood management, there will be very less amount of soil will be getting exposed to the atmosphere.
Thank you very much.
Thank you, sir.
Okay, thank you, sir. Sir, the next presenter is Dr. Sandhya. So, Dr. Sandhya?
Yes.
Yes.
Can I share my presentation?
Yes, please do.
Is it visible?
Has not come yet.
Sorry, is it visible?
No, not yet.
Is it visible now? Is it visible now?
No.
I have to share the entire screen, right? Or a window?
Yes. Only then it will come. You have to share the entire screen.
But the share option, that is not active. Only the cancel option is active.
You have to select the share entire window. You have to select it, and then you will get an option. The share option will get blue. It will turn blue, and then you can select it.
It is not turning blue. Actually, it is grayish. Only the cancel option is blue.
Rejoin again.
Okay.
Join again. Okay.
Yes.
Log out and rejoin again.
Meanwhile, we'll take another presenter, sir.
Yeah.
Okay.
Hello.
Yes, sir.
Hello, ma'am. I am Deepak Kumar Mandal.
Deepak, I'll call your name. The next presenter is Senthivalam, P. Senthivalam. He had already tried previously and he requested right now, so I'll call his name again.
Okay, madam. Thank you.
Yeah.
Madam,
is it visible?
Yes.
Sorry, that is my previous attempt. I says problem with my laptop. So, thank you for the opportunity to the SGVU, and I have this establishment and nutrient management practices and rice cropping system productivity through it may be a different topic from your observation technology, because even though technology is there, just we have to have something in the land. Then only we can just have it. So how we are sequestering the changing in the climate, this other technology. So we have an introduction. This is a little introduction. That is why carbon addition or carbon sequestration is important. So because there are two core considerations in that. So reduce greenhouse gases that is emission in the atmosphere, and restoring and improving soil by sequestering carbon will help in the soil health and productivity. These are a core consideration, will help in the food security and just also the playing in atmospheric changes or climate change. So how much carbon content? So I have gone through the statistic of 2021. The soil containing around 700 to 3,000 gigatons. That is, it is more than 3 times of our carbon stored in the atmosphere. So that much carbon is have in the natural ecosystem. That is in soil. So what happened? This in the soil carbon, just it is the imbalance in that. You see that 50 to 70% of the organic soil carbon pool present in the natural system is lost due to clearing and cultivation. So that is the loss. So that's why we have more carbon. But less carbon enters in the soil. That is clearance above known biomass. stubble burning, whatever the agriculture practice we are doing. So the agriculture is just like grazing and harvesting and telling everything is reduced soil carbon, but we have to increase the input of soil to reduce the atmospheric temperatures, global temperature. So another we have some management practice we have to maintain the soil carbon and also the global the atmospheric. That is the tillage practices, manure and compost application, conversion of the monoculture system to diversity culture system, and other activities that helps to increase the soil organic carbon, and also carbon holding capacity. That is sequestering carbon, increasing in microbial load and activities that helps in the lot of way, and increase the soil liable carbon also. That is very important. Soil liable carbon is very important because the soil liable carbon pool is playing an important role that provides carbon to the plants, and just through the photosynthetic activity, the plant increase the atmospheric carbon. So next slide, we have some simple diagrammatic presentation. What happened in the soil management? That is, we have also play in soil structure that play in the gas transport capacity, water holding capacity, and just fermentation resistance. So whatever the we just try to input in the soil, that the physical condition of the root growth, and we have the microbial biomass and activity, and just the organic carbon input that becomes soil organic carbon. Just so the release of organic carbon and the accumulation of organic carbon have decide the soil organic the soil carbon sequestration potential by the microbial temperature. Then see the microbial activity. So what happened is microbial activity that in soil and just organic matter with the plants, and direct mechanism of microbial biomass, that is soil and different cultivation. And the benefits of soil carbon sequestration, we have the improved soil structure, better water use and storage, less erosion, improved soil fertility, improved biodiversity, healthier ecology, improved agriculture performance, everything. Then the next slide, just we are going to see that what happened with the rice pulse problem. Just we have given a slide that it may be just mobile, just I cannot explain this that much. You can see that. So what happened here? The soil organic carbon accumulation, just some methane emission in the flooded rice system, and also the follow crops like wheat, rice, wheat, pulse, or just rice pulse. Different systems have different capacity of accumulating soil carbon, and also the soil carbon, the organic carbon in the plant itself. So there is a cycle reducing the cycle, just circulating the organic carbon in the throughout the that is in the inside the soil and also outside soil. There is atmospheric carbon. So change in the balance of this organic carbon, carbon content in the atmosphere and the soil will just play in the productivity and also the global climate change. So we have taken the objectives of the hypothesis. The crop establishment and nutrient management practices in rice pulse cropping system can contribute to increase soil organic matter and helps in the maintaining soil biological process, which in turn increase the carbon holding capacity, water holding capacity, microbial load, and just microbial activity. And this objective I have taken only one, that is assessing impact of crop establishment on INM practices in rice pulse cropping system, productivity, soil health, and improving soil carbon sequestration. So we have used that different set of treatments that we have taken a design of split design and a field experiment. It conducted for 3 years from 2012 to 2015, and have two main plot as SRI system of method of cultivation and this conventional system of cultivation, and have 7 INM treatments. So like our 100% recommended dose of fertilizer and this other organic, inorganic split up, just we are combined to apply, and just we have get the yield, biomass yield. See that the grain yield and straw yield of rice crop, just pool of 3 years, mean up to 3 years, and also the residual crop of black gram, just we have pool of 3 years. So see that the SRI method of cultivation just increase the yield, the above ground biomass compared to conventional technology, and also see the treatment just applied in the SCCR bed IPNS integrated plant nutrient supply system. It increases more biomass compared to the other treatment, INM treatment applied, and also the compared to conventional system, SRS system have more growth of biomass yield. So also see the difference. We have a lot of difference in the cultivation methods of increasing biomass, and also the residual crops. See that black gram also have difference in the residual system SRI plots and also CSC plots. And also we have a lot of difference in the biomass yield in the both in rice and residual black gram yield. And see the graph I have shown that the grain and straw yield of the biomass yield is rice and black gram. The percentage was just related to grain yield and straw yield. See the treatment, the SCCR IPS in the second treatment, SCCR IPS just given more grain yield and straw yield. So increasing biomass, also the accumulating carbon as a source of carbon sink just reduces the atmospheric carbon, and also see that second thing, the residual crop having that the seedil and the biomass carbon, the soil organic carbon just accumulated by the rice and rice fallow black ram. See, compared to rice crop, the product system, even though this anaerobic system or the aerobic system, the residual rice fallow black ram is increasing more soil carbon compared to the rice system because of the flooding system of irrigation. So the rice pulse cropping system able to sequester more carbon compared to the other system in the our covered delta X1 because of these. Most of the crop is here grown in rice fallow pulse. Like your North India, we have the rice wheat or just wheat cultivation. Like we have rice pulse person. So on the observation point, we have the what happened to the biological properties, the soil, bacteria, fungi, and just actinoviruses are improved, and just there is no nematode found in, and just pH is altered, easy is static, and also we have other biological parameters and soil organic carbon improved. So based on that, we have some strategy. SCCR based IPNS improve the soil organic pool enriched, and biomass yield of rice pulse is improved, and cropping system productivity also enhanced. So and just actually in the present study, we have the SRI combined with the SCCR based IPNS. So there is increased biomass yield in rice fallow pulse cropping system. So there is the 15 to 20% of soil organic carbon increase compared to the initial analysis the past 3 years. It's 2012 initial and just 2015 initial, we get 15 to 20% soil organic carbon content increase, and yield also increased 40 to 60% compared to the initial yield. And then soil health, we have the 30 to 45% just improved in the soil health, just helps in the soil carbon sequestration. And also there is a findings of this the field experiment taken. Application of soil test crop response based integrated plant nutrient supply system proved to be a promising technology, and SRI system of rice integration to enrich the soil carbon sequestration in soil, that is especially our soil, wet soil, which in turn enhances the soil health and rice black ram cropping system productivity according to Tamil Nadu. And the residual effect of applied INM materials have more residual effect on legumes, which improve more soil organic carbon compared to rice. So the cropping system helps in the reducing the atmospheric carbon and just improving the soil carbon. So even though just we are clearing more amount of above ground biomass. So thank you. Just I'm waiting for suggestions.
Okay, thank you. Dr. Nicholas, sir, any questions to him?
Not right now, thank you.
Okay, so we will proceed with the next presenter. Again, I'll call Dr. Sandhya to start presenting.
Thank you, ma'am. Thank you, ma'am.
Yeah. Dr. Sandhya, ma'am. Please unmute yourself. You are muted.
Please stop sharing your screen.
Yeah, please stop sharing.
Actually,
Sentivillain, yeah, please stop sharing Sentivillain. Okay.
Sorry, ma'am.
Yes, Dr. Sandhya, you can present now, ma'am.
It's again the same problem. That share that is not active. Can I share a window?
Yeah, try to do that. Share a window.
Am I able to share it?
Yes, yes.
It's visible. Your presentation is visible now.
It's visible?
Just start.
Okay.
Yes,
Okay, I will start. My topic is demarcation of waterlogged areas by remote sensing. It is a case study in Indira Gandhi Canal project stage 1 command area. Actually, as you all know that Indira Gandhi Canal project, it is an irrigation project which has been introduced in the western part of the Rajasthan, which is a desert. And this irrigation project has not only extended the irrigation facility there, but it has also increased the agriculture production, and it has also provided the drought proofing, and it has increased the human settlement by increasing the irrigation and agriculture facility as well as the drinking water facility which has been created. This has also created the employment opportunities there, and other economic activities has also developed due to that. But This increased agriculture, all this development has no doubt that that is very good, and it has also increased the groundwater level due to the excessive seepage of groundwater through the canals as well as the water which has been used for the irrigation. But this has also raised to a problem there in the lower lying areas, the areas which are having some hard layer below that, that is the problem of waterlogging. So in order to identify that, I have chosen an area that is in the Shri Ganganagar district that comprises of 3 tehsils of Shri Ganganagar district, that is the Anupgarh, Vijayanagar and Suratgarh. This area is drained by 3 major canals of IGCP, that is the main canal, and 2 branches, 2 very big branches of the main canal, that is the Suratgarh branch and the Anupgarh branch canal. And if we see the SRTM, the elevation model of the study area, we find that this southeastern part of the study area has sand dunes, and it is high up to 232 kilometers, whereas the area which is having a border with the Pakistan, that is a low-lying area, and it's having a height of 127 meters. Now we will have a look towards a study area. That if we see the geomorphological setting of this area, it has 4 type of geomorphological features. One is the old aggravated alluvial plain, which extends in the northern part of this area, which is drained by a seasonal river, Gaggar. And this river ends, it has an inland drainage, it ends in the sand dunes only. It doesn't get into any ocean. Then the second is the sandy, undulated, older aggregated alluvial plain regions. These are the older aggregated alluvial plain regions which are considered to be the part of the Saraswati River, which is being covered under this thick sand. And the third is the sand dunes, which are found on the western part of the Anupgarh Tehsil and in the southeastern part of the Suratgarh Tehsil, which are locally called here as an Ucha Tibbas. Then the fourth region is sandy, undulating interdunal plains and the flat interdunal plains. These are the flat interdunal plains within these sand dunes, and which has resulted mainly due to the agriculture which is being practiced here. And if you see the topography, it's a plain having a thick layer of sand which is spread over the alluvial plain. And these sand dunes are on the western border. We have found that they are up to 4 to 5 meter high, and they are transverse dune types. And towards the southeastern part of the Suratgarh Tehsil, also sand dunes are common. And if we see the general slope of this region, that is northwesterly, and the elevation is 127 meter close to the India-Pakistan border, and 232 meter towards the eastern extent of this area, and the average slope is 1.5 meter per kilometer. And the soils of this region, it has 2 types of soil. One is the floodplain soils, which are found mainly in the Gaggar plain, that Gaggar riverbed region, where its thickness is about 10 to 45 centimeter deep. That is mainly below, that is the windblown sand here. Then the Aeolian sand, that is of 2 types, that the sand desert plain soils and the sand dunes. And if you see the hydrology of this region, the geological formation are of Quaternary period, and they include the unconsolidated and the semi-consolidated sediments, which is comprising sand, silt, clay, and the kankar. And the local aquifer is here locally called as a reli. And the thickness of the alluvium here, which is found in this, its geological formation is higher towards the northwestern direction, whereas it reduces towards the south and the southeastern direction. And if you see the climate, as per the Köppen's classification, the region has a hot desert type climate, and the maximum minimum temperature ranges are 1.4 degrees Celsius to 46.4 degrees Celsius. And this is the mean annual temperature here, 23 degrees centigrade, and the annual rainfall at the Anupgarh station is 188 millimeter with the 10 rainy days annually, and at the Vijayanagar station it is 114 millimeter with 8 rainy days annually. And one feature is very common here in the climate, that is the dust storms, and they have very high speed up to 60 to 80 kilometer per hour during the summer season. The materials which I have used is Landsat 8 satellite imageries. I have used satellite imageries for 3 periods, that is 92, 2010, and 2016. For 92, I have got only imagery for the post-monsoon period. The post-monsoon period includes the month of October and November, and the pre-monsoon includes generally the month of May. It has been mapped using the ADAS and the ArcMap softwares. I have used two formulas here. One is the normalized differential water index, NDWI, which is proposed by McPheets. This formula is used to demarcate the surface waterlogged regions, because NDWI, it maximizes the reflection properties of the water. So the typical reflectance of water features using the green wavelength, and by lowering the reflectance of near infrared, it can be enhanced. So only the water which is there on the surface, that we can get information about that through the NDWI. But the NDWI doesn't takes into account the actual definition of waterlogged areas, because the definition of waterlogged area, which is defined by the Ministry of Water Resources 1991, suggests that the groundwater level up to 2 meters below ground level is considered to be waterlogged area. So the area somewhere where water is not logged above, but the soil is wet, if that would also be considered as the waterlogged regions. So for that, different indexes used, that is the soil wetness index. It is determined by the Tessel cap transformation, which is proposed by the Hung. And here he has used different bands, and and these bands has been converted by giving some weighted sums has been given to them, and those bands which are not of use or which reduces the information of wetness, they has been reduced, they have been subtracted, and the negative weightage has been given to them, and the other bands has been given the positive weightage. So this is the wetness index, and using the NDWI and the soil wetness index, this is the flow chart of the methodology which has been used. The layers has been stacked, areas has been subset, then the NDWI, and here the Tessel cap transformation for wetness has been used. And for the NDWI, here the threshold which I have shown here, that is the 0 I have taken into account. Then the waterlogged areas has been mapped for the pre-monsoon and post-monsoon, then both the seasons has been combined. Then the permanent surface waterlogged areas has been identified through that. And here the soil wetness map has been produced for all the seasons, and accordingly, as per the information of this area, and I also know about this area as I have surveyed also through that area. So where the soil wetness could not be, even in some areas, is not actually waterlogged area, that has been removed, and the other part has been included, and the waterlogged areas has been mapped through digitization. So what my analysis shows here, this is for the pre-monsoon season for 2000 and 2016. Here, these are the brown color is showing the man-made water storages. Actually, on the canals somewhere, the water storage are there in all the villages generally for the storage of the water. So that can be easily be identified as they are either in the rectangular shape, or proper circle is their shape, or they are in the square shape. So they has been removed. So it has been found during 2000, the area which was waterlogged was 18.66 square kilometer of the area, whereas in 2016 only 0.40. As you can see, this is which season? It's a pre-monsoon season, or it means it's a month of May. So during the month of the May, as it is the temperatures are very high in this region, so this happens that this water, which is actually waterlogged, but it gets evaporated. Though it's get evaporated, then also that land cannot be used, because the salt level increases in the soil, and that soil is saline, and as well as water is not available during summer season. So even that cannot be used for the agriculture purpose. Then these two are combined, and the final pre-monsoon map has been generated for the waterlogged areas. Then this is the surface water regions during the post-monsoon season. For the post-monsoon, I have got satellite imageries for 92 as well. So that also I have included. So this is for 1992 and this is for 2000 map and this is for 2016, and it shows in 2016 considerably high waterlogged area we can see. In 1992 it was 9.24 square kilometer area, whereas during 2000 it was 26.06 square kilometer area, and 2016 it increased to 31.53 square kilometer of area, and this is the combined map of all these 3 years. Then the soil wetness that the Tessel cap formula I showed you, according to that, the soil wetness of the region has been identified, and these are the soil wetness maps. Here this blue color is showing the highly moist soil, whereas the darkest, this brown shadow shade of the brown color is showing the dry soil. So we can see here these this map somewhat coincides with the elevation map, and this is the lower, actually this region is the lower lying area, which is the flow of Gaggar plain flow region. So that's why this region is having the higher wetness even during the pre-monsoon season we can see. And one more reason why these regions are coming highly moist is because agriculturally they are very advanced. So because agriculture is done here, so that's why due to the irrigation which is being provided to the agriculture fields, that has also increased the soil moisture level, and it is showing highly moist. Whereas this southwestern area, this part if we see, we have even seen in the elevation map that it is mainly the sand dunes. So the sand dune areas, there is no agriculture, or even though agriculture is there, that is only during the monsoon season. That is mainly the bajra crop that is being cultivated, and that is rain fed mainly, not the irrigated one. So here we find that this area is having the dry soil region. So, and during the post monsoon season, if you see during the post monsoon, see the difference between the pre monsoon and the post monsoon. Whereas during the post monsoon, the wet highly wet soils are less. Here what is beneficial for us is this region, because this region we have seen in the pre-monsoon or in the normalized differential water index that this is the waterlogged area. So here the regions nearby which is showing this blue color is also the waterlogged area, which was not coming in the NDWI. That map was not showing it, but it is actually the waterlogged areas. So these here by marking this soil moisture of the soil, we were able to demarcate the soil moisture and the waterlogged areas in the study area. So the results in the conclusion is mainly this is the overall map which has been prepared using the data of 2010, 2016. Then we have demarcated the waterlogged areas, and we have found it is mainly in the lower lying plain of the northeast Suratgarh Tehsil. As we have seen the canal map, from here the main canal is passing and then it enters in the study area. So the water is mainly draining from the main canal area in this region, and this region is also having in the underlying it as the hard pan of the Kankar, which is stopping the seepage of the canal water as well as the excessive irrigation water which is applied to the agriculture. So that's why that has raised to the problem of waterlogging in this region. So which can be analyzed using normalized differential water index as well as the soil wetness index, that is the Tessel cap index. Thank you very much.
Thank you. Thank you for the presentation. Now I would like to call upon the next presenter, Mr. Deepak Kumar Mandal. Mr. Deepak Kumar Mandal, you there? Yes, Dr. Nicholas, sir.
Thank you. I had just one quick question for the latest presenter, if she's still here.
Yes, she's here.
I'm here.
Okay, can you repeat which satellite data were you using for your study? You mentioned it.
I have used Lancet 8 data.
Okay, and which data did you use for your study area in 2000? Or year 2000?
I have for 2010, sorry, for 2000 and 2016, and also I've got for 1992 for the post-monsoon season. But for the pre-monsoon, the imagery was not there for 1992. Actually, this is an extended work to, I have also studied the groundwater level for this region and the fluctuation levels, and that I have analyzed for the 50 years. And that I have also combined it with the rainfall pattern, that is the daily rainfall I have seen. It is it's in my extension work, this demarcation of waterlogged areas. So that's why even I have taken this 1992 satellite image.
Okay, thank you. But maybe you should have mentioned it in presentation, because some of the satellites were not launched until 2013, like Lancet 8. So it's a bit confusing, but thank you. Now you have cleared it.
Okay.
So shall we move to the next presenter?
Good evening to all. I am doing paper presentation without turning on the camera because of network rule.
Okay, please turn on your presentation.
My paper title is Impact of Climate Change in Mangrove Ecology. There is growing scientific unequanimity that environmental change is having huge ecological impact on the natural ecology of the Sundarbans. In the coming decades,
Mr. Mandal, sorry to interrupt you. We are not able to see your presentation.
Hello.
Yes, we are not able to see your presentation, Mr. Mandal.
Okay, thank you.
Your presentation is not there.
Okay, thank you so much.
Okay, we'll move on to the next presenter, Miss Sonam Banerjee.
Good evening, all.
Yeah.
Ma'am, am I
Yes.
audible?
Yes. Please turn on your camera, start presenting, and try to capitulate it within 10 minutes.
Okay, ma'am. But I, 1 minute, ma'am.
Priyanka, how many presentations left?
Ma'am, Vishnu Kumar, Saurabh Singh, and Dr. Sarika Shukla.
All are present?
Ma'am, Mr. Saurabh Singh and Dr. Sarika Shukla, I think she is present there. I'm not sure about Mr. Vishnu Kumar.
Ma'am?
Yes, Sonam.
Ma'am, visible, ma'am?
Yeah. Start your presentation.
Good evening, all. Today, I present my topic. My topic name is a review on environment and climate change. Nowadays, environmental issues are increasing at an alarming rate. We have reviewed many research papers on climate change and environmental issues. In the review paper, an overview of many researches by many researchers on environment and climate change. This paper reports a comprehensive literature review for 1991 to 2019, the years in which this topic appeared in scientific journals. Our review paper includes all ecological factors, critical thinking on environment, space climate, global environment change, and many more. Environmental pollution represents an obstacle to the economical explorations of coal deposits. In industrialized countries, the rules for protection of the environment are stricter than in developing countries. Thus, to get license to obtain mines involves lengthy procedures, which in turn cause delay. Indian authorities have also started to put stringent conditions in place regarding environmental pollutions Consequently, ecological problems can be totally prevented, but such measures are costly. So we decided to work and read the research paper of extraordinary persons. So we give our views and spread awareness to as many people as possible towards the environment. In our review paper, we include many circular things on awareness of environmental problems like many hazards, industries emitting out many toxic gases which have a major part to pollute our environment. In this review paper, we will discuss about health factors by this changing climate and also give a small explanation of CTTEE, which means the critical thinking test in environmental education. The variation in normal weather pattern save unfavorable effects on the physical and biological entities of the environment. Change in space weather at Earth orbit by SSN. Timeline of 1700 to 2018. The atmosphere is a blend of nitrogen, oxygen, and many different gases that are essential for our Earth atmosphere. The increase in air pollution level, contamination of water, waste collected in seas, ponds, rivers affected the natural wildlife of both terrestrial and aquatic living beings. Many surveys have been conducting all over the world for our ecological balance of life in our precious environment. The key to realize the whole of air pollution and short-lived climate pollutants related to growing global warming effect in the establishment of further change. Uh, these uh, mm, these sensors, however, gently depend on judgment about the future adaptation and mitigation policies to be established and applied, including the technological, economical, and industrial requirements of various alternative mitigations pathway and feedback from these policies. Our nature takes several years to get blended with all these resources. As we own resources are limited and we are over exploiting them. So many scientists were researching for an alternative means to meet our daily increasing needs. So some take some of the research papers and review them on to acquire knowledge and help to update them accordingly. Conclusion है, we deal with most environmental problems and their effects. We are spreading awareness worldwide regarding this topic. Natural weather changes procedures a big effect on the environment as we are living on Earth. This is our duty to take care of our Mother Earth and live with harmony. Sometimes small change leads to big change in life. Human activities create an imbalance in the ecosystems and food chain of the environment. We should live with the integrity within the ecosystems of the earth. Thank you.
Thank you, Sonamanaji. Dr. Nicholas, any question to her?
No, right now. Thank you for the nice presentation and thank you for keeping it in time.
Okay, we will move to next presenter, Mr. Vishnu Kumar Meghawal. Mr. Vishnu Kumar Meghawal, are you there? Okay. The next presenter is Mr. Saurabh Singh.
Yes, ma'am.
Yes. Please present and try to keep it in 10 minutes.
Okay, ma'am.
Okay.
Ma'am, are you able to see my PPT?
Yes. Presentation mode. Turn it on.
Okay, ma'am. Hello everyone, my name is Saurabh Singh and today I am going to give the paper presentation on stone dust as a alternative of natural sand for the development of a sustainable concrete. As we all know, nowadays we are facing a lot of problem due to the illegal mining of the natural sand. It is also affecting on our ecological system. So now this is the very serious problem for the construction industry to find an ecological alternative of a natural sand. Here is my table content, introduction, aim, objective, alternatives of natural sand, result output of alternative material, and conclusion. So come on the introduction. Sand, as we all know, sand is a very important engineering material for the construction work. Without the sand, we cannot prepare the concrete and we cannot do the construction activities. That's why sand is a very important material for the construction industries. As you can see here, nowadays a large amount of natural sand are used for the construction purpose, and these are mined from the river. And this is estimated that between 32 to 50 billion ton of sand are extracted globally each year. It is the quantity of this extraction is a very high, and it can be disbalance the ecosystem of our river bodies. Natural sand deposits are being used up, causing serious threats to our environment as well as our society. Rapid extraction of sand from the riverbed causing so many problems like losing water retaining soil strata, deepening of the river beds and causing bank slides, loss of vegetations on the banks of river, disturb the aquatic life as well, disturb the agricultural due to the lowering of the water table in the well. So as you can see here, now what we need to do, we need to find some alternative of the natural sand. That material we can use on the place of the natural sand. If you will see the Rajasthan, there are many districts which they are very rich from the gypsum, they are very rich from the limestone. So these material can be alternative of the natural sand. As you can see, this map is showing the gypsum. If you will see Bikaner, Ganganagar and Hanumangarh, these are the very there are gypsum in very high quantity, and if we will use the dust of the gypsum in the concrete, it can be used as a alternative of the natural sand. Limestone, as we all know, Jodhpur, Jaisalmer, they are very rich by the limestones, and we can use the dust of the limestone as the natural sand. So it can be an alternative of a natural sand. What is the aim and objective? To find the alternative of natural sand for the construction industry. And second one is also very important objective of my research, to perform the site suitability analysis for the alternative material by which the natural sand is replaced. As we all know, on everywhere gypsum is not available, on everywhere lime is not available, but we can identify the place like in Nagaur. If you will see in the Nagaur, there is lime is available. If you will see the Jaisalmer, there is a gypsum is available. So we can find the site suitability for the alternative of the natural sand. Like in Nagaur, we can use the byproduct of the gypsum. In the Jaisalmer, we can use the byproduct of the limestone on the place of natural sand. So now you can see the shortage of the natural sand. If you will see this map, you will see what is the demand and what is the supply. And even nowadays, a lot of companies and a lot of construction industries are using the natural sand. Even they are facing the shortage of the natural sand, as you can see here. And this shortage of the sand can be fulfilled by the finding an alternative material of the natural sand. So here is the some alternatives. Basically, I am doing work on the stone dust and a copper slag and washed bottom S. And there is also one more quarry dust. These can be also alternative of the natural sand, foundry sand. As we all know, foundry sand can be easily available on everywhere. So it can be also used in the concrete on the place of the natural sand. So it can be also a very economical and very eco-friendly alternative of the natural sand. Now we will see the copper slag. Approx 33 million tons of copper slag is generating annually worldwide. Among that, India is contributing 6 to 6.5 million tons. So if we will use this copper slag in the concrete, it will also reduce the it will also decrease our waste, and it will be also helpful for the maintaining the shortage of the natural sand. Come on the stone dust, about the 20 to 25% of the total production in the each crusher units is left out as the waste material of the quarry dust. So you can see here, uh, uh, quarry dust is, or stone dust is generally a byproduct of a limestones or rocks. So if you will see, it is like a waste. If we can use this waste as a material which can replace the natural sand, it will be very helpful for the our will very helpful for the our environment. In ideal percentage, the replacement of the sand with the quarry dust is 55% to 75% case of the compressive strength. And if we combine with the fly ash, another industrial waste, which is another industrial waste, 100% replacement of sand can be achieved. Now I am planning to do, like I'm going to do some research on it. Like we can combine two material which can replace the natural sand. Like we can combine stone dust and marble slurry together in the concrete, and it can minimize the demand of natural sand. Come on the washed bottom ash. Currently, India is producing in over 100 million tons of the coal ash, from which total ash produced in any thermal power plant is approx 15 to 20% of bottom ash, and the rest is the fly ash. Fly ash has found many users, but bottom ash still continues to pollute the environment with the unsafe disposal mechanism in the India. So we can also take washed bottom ash as the alternative of the natural sand. Now these are the some results which we got by the using of copper slag on the place of natural sand, as you can see here. And these are the some various concrete mix details which is prepared by the using of copper slag. Now this is the average compressive strength of the specimen which we got by the using of copper slag on the different quantity, as you can see this table. This is the ultrasonic pulse velocity test which we perform for the strength of a concrete, which we perform by the 7 days and 28 days on different replacement. Now come on the result. In the first series, we have already done this. We got a very good result on the replacement of 20%, 25% on by 30% by the replacement of quarry dust in 3 days, 7 days, 28 days, and 68 days. In second series, M25 grade of concrete with the 20, 25, and 30% replacement of quarry dust tested for 3 days, 7 days, 28 days, and studied. We also got very good result by the using of quarry dust. In third series, M20, M25, and 30 grade of concrete with 20 days, 25% percentage, and 30% replacement of quarry dust by the varying of water cement ratio 0.45 to 0.50 are studied, and we also got very good result by these quarry dust. Now we are now I'm doing the work to find 100% replacement, find the alternative of natural sand, 100% replacement by the using of different combined material. As you can see, these are the graphs which is representing the compressive strength of concrete, which is of M20 grade of concrete. Now this is the graph. This graph is showing the percentage of replacement of quarry dust, and it is relation between the percentage of replacement of quarry dust and compressive strength. And these are the results. As you can see, we got the very good crushing strength, which is 19.30 kilonewton. So these are the results. Now come on the conclusion. For the result, the replacement of fine aggregate using copper slag in concrete increase the density of concrete, thereby increase the self-weight of the concrete. The workability of concrete increased with the increase in the copper slag content of fine aggregate replacement at the same cement water ratio. From the result of compressive strength, split tensile strength and flexural strength, the concrete shown higher value at 40% replacement of fine aggregate using copper slag. So it is recommended that 40% of fine aggregate can be replaced by the copper slag. If you will talk about the strength of the concrete is mainly depend on the bonding of the fine aggregate, which is fill the void between the coarse aggregate. It is found the strength of concrete is more for WC ratio of 0.45 when compared with the WC ratio of 0.5. As the quantity of water increase, the compressive strength decrease when the replacement with the quarry dust. So if these things happen in the adding of quarry dust, this is due to the water absorption property of the quarry dust. It is found that 40% replacement of sand by the quarry dust gives the maximum result in the strength compared to the normal concrete, and then decrease from the 50%. Now this is the problem which we need to solve, because till the 40% replacement we are getting very good result, but after 40%, when we are increasing the percentage of replacement more than 40%, then strength is decreasing. This problem we need to fix, and I'm working on it to replace the natural sand till the 100%. Thank you. Thank you, sir.
Thank you, Saurabh. Thank you for the presentation. Dr. Nicholas, sir, any questions to him?
No, thank you.
Okay. Then moving forward to the next presenter, Dr. Sarika Shukla. Dr. Sarika Shukla, are you there?
Good evening. Yes, ma'am. I'm there.
Yes. Hi.
May I share my screen, please?
Yes, please share the screen and turn on the camera so that we can also see it.
Okay. Good evening, everyone. Deepti Dwivedi and myself, we are presenting a presentation on temporal assessment of salt affected area through geospatial technology in Dalmau block, Raebareli district, Uttar Pradesh, India. So in the present scenario, one of the most devastating environmental hazards for an agrarian economy is the salinization of agricultural land. In India, about 6.73 million hectares of land is under salt-affected soils, and Uttar Pradesh state has 1.37 million hectares of productive land which is salt-affected. A major concern in the state is the declining productivity of food grains, especially of rice and wheat. Uttar Pradesh is a part of India's breadbasket, and like other districts of Uttar Pradesh, Raebareli district also contributes in this basket, so it becomes vital to discuss the growing environmental hazard and its mitigation process in the study area so that mitigation plans can be adopted in other areas facing similar environmental crises. The objective of the study is to monitor temporal assessment of the real-time changes in the saline pockets in the study area through geospatial technology. The study area lies between 26 degree to 26 degree 14 minutes north latitude and 80 degree 57 minutes east to 81 degree 12 minutes east longitude as shown in the figure 1, and this lies 115 meters above mean sea level. According to the census, this spatial extent covers Dalmau development block boundary located in Dalmau Tehsil of Raebareli district in the state of Uttar Pradesh. This is a secondary study. The legacy data of Raebareli district boundary and Dalmau Tehsil boundary was traced on Survey of India topographical maps, scale 1:50,000. The area of salt affected land in Dalmau block was verified by field visit and field survey. The census 2011 report, the water quality report, the soil survey reports, the soil maps, agriculture contingency plans were collected from the related government departments and utilized for the interpretation and fieldwork. The remote sensing data was acquired from IRS P6 Resource Stat 2 List 3 multispectral orthorectified images for February 2013 and February 2018 in the months of Rabi season. List 3 satellite data of the Almog block was collected from National Remote Sensing Center website Bhuvan, Indian Geo platform of ISRO. The software ArcGIS 10.1 was used for georeferencing, delineation, image classification, area statistic, and map composition. The flow diagram presents the methodology adopted to conduct the present study. The data from different composite bands were integrated to prepare a digital mosaic of the study area. The standard FCC was developed using different band combination for visual analysis of salt degraded soils. FCC was visually interpreted for areas of salt affected soil based on different indicators of soil salinity like tone, texture, shape, size, patterns, and association, etc. To get a classified image of the study area, unsupervised classification was applied to composite image. The salt affected areas were delineated in GIS environment. According to the World Bank, Uttar Pradesh produces nearly 20% of the India's food grain on about 17 million hectares cultivable land, which is declining. And this is mainly due to the water-induced land degradation, salinization, solidification, groundwater depletion, and loss of soil fertility, with the sustained removal of nutrients associated with more intensive cropping and the inappropriate use of heavily subsidized nitrogenous fertilizers. The average annual rate of growth of crop yield has declined. According to Singh, According to Singh, various factors which govern development of soil affected areas include climate, topography, geology, soil minerals, weathering, drainage, hydrology, irrigation sources, and groundwater depth and quality, and management practices. All these factors, as mentioned by Singh, have interplayed in the development of certification in the study area. And precise mapping and classification of these soils are necessary to identify the nature, extent, and spatial distribution of these soils. A final map representing visual features of soil affected soils were prepared for both the years February 2013 and February 2018, collecting visual interpretation and ground truth information and integrating visual interpretation keys and geocoded image was prepared. The use of digital pre-processing with visual post-processing greatly reduced analysis time. In ArcGIS environment, geometry of each feature showing patches of salt-affected soil was calculated, and statistic data of total area of salt affected area in the Almo block was estimated. For images, for image analysis and visual interpretation, List 3 satellite data is used in the present study. From this data, salt affected soil area was identified using FCC and brightness index. Total area of Dalmo block in the Raebareli district is covered in two tiles of List 3 satellite images, namely tile G44G04 and tile G44116. In order to observe and analyze the temporal difference of salt affected area, the above two tile satellite data they were both downloaded for February 2013 and 18, and the satellite image downloaded was having four bands Therefore, a composite band image was derived by integrating all four bands in ArcGIS environment. In this study, band combination B321 and B432 were used, and a standard FCC was prepared. In the near infrared band and in the visible band, soil affected soils have a high reflectance. This standard FCC was then used for analysis of soil affected area in the study area. So, depending upon the preliminary identification of map of soil affected land, with tentative legends were prepared, and during observation of study area of satellite image, FCC was region of mixed stones were also observed. So, these are the this is the, you can say, distribution of salt affected soils in the Almo block, and based on list 3 February 2013 satellite data, total salt affected land area was found, you can say, and this is the 2018, and you can see the difference. And this is the list 3 satellite data. Total salt affected land area was found 2344 hectares, which is 9.2% of the total geographical area of the Almar block. The total salt affected land was also analyzed from list 3 satellite data to get change detection and impact of soil reclamation measures. And based on February 2018 satellite data, total salt affected land area was reduced to 758 hectares, which is 2.97 percentage of total geographical area of the study area. And the spatial distribution of salt affected soils in the study area is shown in the slide I've shown you earlier, this and this. And thus, from the year 2013 to the year 2018, that is the span of 5 years, total salt affected land area has been reduced from 9.2 of the total geographical area to 2.97 percentage of the total geographical area. And this reduction in sodic soil area has been observed mostly in the central region of the Almo block. And in both the years, the satellite data, the salinity problem is much higher in the northern part of the study area. And the beneficiaries are the residents of the village, owner of the sodic soil, women, landless laborers, and village artisans. Basically, approx 85% of beneficiaries are small and marginal farmers, and 65% people living below the poverty line. And UP Sodic Land Reclamation Project was successful in reclaiming the about, you can say, 67.56% of the total sodic land area through gypsum-based alkali land reclamation technology. And this has enhanced approximately 16 to 17 million tons of paddy and wheat has been added annually to the national food basket. And to conclude, the integrated analysis of such database in GIS environment is important for decision making and planning of soil reclamation measures for salt affected areas in the different districts of UP state or even the country, and help in the food, livelihood, and the environmental security of the nation. Thank you.
Thank you, ma'am. It was a good presentation. Dr. Nicholas, sir, any questions?
No, thank you. Thank you for a nice presentation.
Thank you, sir.
So, ma'am, we are on the end of the presentation. This was the last presenter. So, as we have come to the last leg of our conference, I wish a very good evening to our guest, Honorable President Ma'am Dr. Ritu Galotra, Professor M.K. Banerjee, Chair Professor of Suresh Kanvihar University, Dr. Shruti Kanga, Coordinator of Center for Climate Change and Water Research, Dr. Suraj Kumar Singh, Coordinator of Center for Sustainable Development, faculty members, and to all who have joined us for this validatory ceremony of one-day virtual international conference on Earth observation technology for environmental management. Now, with this thought, I would like to invite Dr. Professor M.K. Banerjee, Chair Professor of Suresh Kanvihar University, for valedictory remark on today's conference. Sir, you are most welcome, sir.
Honorable Pro-President, ma'am, Dr. Shruti, Dr. Suraj, and my dear fellow colleagues. At the outset, I will record my sincere gratitude to Professor Shruti and Professor Suraj Singh for enabling me to be present all along. And then I had the privilege of listening to some very important papers, so which were quite, I will say that your informative. So therefore, taking that kind of context, I mean, I would say that your appreciation is befitting to our organizing team, because within such a stringent situation, there has been such kind of assemblage of people, highly educated, highly experienced people. I mean, I don't want to belittle by crediting them, because I mean they have gone far beyond what one can expect. So therefore, and not only that, the presentations were very good. Even the young guys who were presenting in the form of contributive papers, I really appreciate them. The first important point which strikes me to share with you is that everyone knows that the last century was branded as a century of economy, and because of the economic activities, the unproliferated use of the natural sources have been there, and it was the human intellectual dogma which has always tempered the nature's wisdom, and that is for why the realization came into being at the end of the last century. And then there was many such conventions, Rio Convention, all those things were there. So ultimately, there was a general consensus of keeping down the pollution level, keeping down the greenhouse effect, all those things. But new benchmark was set up and everything was there. But the most important point which I would like to bring to your observation is that this century was branded as a century of environment right at the end of the last century. So naturally, we have already crossed to fifth of that century of environment. And under such circumstances, what are the changes? The basic fundamental changes are that all these things, that the predictive capacity of human being has enhanced like anything. Why? Because of the major issue that while the ecological balance is at threat, that means the existence of Homo sapiens on Earth is at threat. So under such a situation, what would be our best doings? First of all, we have to map the things, and then that is why the pertinence of this particular conference is so important, that we know very well that with the advent of newer and newer technologies, the Earth observation technologies have improved quite a lot. So I remember that the resolution has been, for the imageries, the resolution has been enormously increased. But as back as 2000 or something like that, the initiation was there for the various states to go for the zoning atlas, where environmental the impact of the industries on the environment, taking those things in consideration with the demographic profile of a particular region, the zoning was tried to be contemplated where exactly the industrial activities will be safe. Now, two contradictory things are happening all the time. So these are the things which have been adequately addressed in this conference. One is that because of the increase in population, So naturally, the habitation issues are becoming more and more critical. So once that habitation issues are becoming more and more critical, by default, we have to consume more and more natural resources. So once we do consume the natural resources, the question is that what is its impact on the ecology and the environment. So therefore, the mapping of that particular thing, which is the contemplation of this conference, herein lies the pertinence of this conference, and that is for why every our organizing team must have to be congratulated, because the thematic selection is so pertinent right at this particular moment of time that it doesn't, it beggars description. So therefore, I really thank Professor Shruti ma'am, Professor Suraj sir, and other your team members who have taken all the pain to do this kind of thing. Now, what is benefit for me to understand? So what did I gain out of this your conference? That the invited speakers, like the first speaker, Professor Garg, who talked about this wetland resource management, wetland restoration, as well as its management. Now, wetland resources have been identified as a very, very important component to keep the ecological balance. Now, the point is that there has been, because of that, again, that habitation and more population and the unjudicious use of this kind of wetland, there has been erosion of wetland. Now, at the same time, the consciousness of ours have also tried to create some kind of new wetland systems. Now, which one is lagging? That is much more important. Which one is lagging and which is the factor? Now, climate change, we are able to monitor the climate change on date, and there has been both this particular presenter as well as another speaker. They basically took all the huge data. So that's very interesting that they have taken the data from quite a back and then till now, and then they have tried to monitor what kind of changes are there. Now, my question, which question, that question I'm throwing to you, the researchers, that we as a layman will always think like that okay, from 2000, if I map the entire change up to 2021, then I get what is the today's scenario. But is it any predictive? Is the change predictive, or the change is not predictive? If the change is not predictive, then what kind of modeling we have to go for in order to predict the future? So it is the predictive analytics which is very, very important. That appears to me, because most likely it should be having some correspondence with the energy consumption of the global energy consumption. So that is a man-made kind of thing which ultimately affects the climate. But what is that component which otherwise is also taking place? Just like a natural mutation, there should be a natural change in climatic. So naturally, what is that component which has to be subtracted, and the rest part you can only address. Now, the rest part addressal is very, very intelligent game which the people are doing. I can also learn the way Professor Tripathi addressed. Now, he simply took the entire stock of this climate change and as well as the crop pattern, and then ultimate finding was that he could not conclude, because this is another very important contradiction he has raised. It's not important what he has said, but it's important that what contradiction he has raised. He simply said that the pattern is not there because of the fact that the technological advancement is also there in cropping. In agricultural technology is improving. So naturally, on one side, our ecological degradation is there. At the same time, the technological improvement is there. But whenever the technological improvement is there, more advanced technology means that more energy consumption, and more energy consumption means that more environmental degradation. So what is that race? That dynamism of the entire thing has to be understood. So this is, I personally feel that monitoring the past, because those data are nowadays very easily available, the people have understood the importance of the data repository, and the data analytics technology is also there. But my point is that there has to be some kind of statistical modeling, some kind of new generation algorithm has to be created, because most probably you will see that if the pattern is not, that is whatever changes had been there from last year to this year and what change will be from next year, there is no such kind of predictive, no pattern. Is it pattern? My fundamental question is the change in climatic pattern? If it is not pattern, why not? That means, can I really take out the natural component and then find what is the man-made component? Man-made component has to have some kind of correlation with the energy consumption. Now, energy consumption, you cannot, by default, energy consumption, you cannot give a check to, but you can introduce different kind of technology wherever you are using for feeding the entire human being, for giving them the comfort. The technological configurations are also changing. People are thinking of the zero emission technology. So the zero emission technology, that means there is a concept like techno ecosystem. So the techno ecosystem has to be done. Now, whenever you have got the imageries, you have got the land use planning, you have got several layers, you can introduce that thing you have been doing. So, and because of that high resolution within 11 meter or so you can very easily give us all kind of information that look, you guys are doing such and such things. So that is why. So the planners are being helped by you the scientists, like anything. Now the point is that the scientists have to say right at this moment that what kind of planning has to be ahead. I mean, the long-term planning has to be there, because if this is the century of environment, right, it has to be proven. At the end of this century, okay, we have done something. So this is my point is that this is the contradiction which ultimately is raised by the speakers in here. So that's precisely what was very much pleasing to me, that they have raised the questions. And then these questions, normally a valediction is essentially an initiation or an introduction. Valediction always marks the initiation or introduction. So naturally, we should take this valediction as the introduction and initiation of new generation research, and then these are all transdisciplinary activities, and more importantly, that the group-based research, that the huge interaction is nowadays required. So I find that the people from foreign countries, they are very eagerly interacting with us. So naturally, from SGVU, we have a very strong team. I am quite proud that I am with an organization where such a very strong, knowledgeable team is there in this particular very burning area. So I had the privilege of addressing these things as back as 2000 for a particular state. So naturally, I know what is the importance. And then the way you have organized this thing and the way you have raised the questions for the sustenance of human being, that the forest, the degradation of forest, then the degradation of wildlife. Now, wildlife is degrading, and people are saying that restoration policy they are trying to do. But that's not the solution. The solution is that you have to causative factors once identified, you have to give addressal to that. So these causative factors you are giving. So I will say that now is a time where huge data are there, and capability of Earth observation technology has been enormous, and then the technology is increasing and the ecological degradation is taking place quite fast. Now that competition, that race, is there. So in that particular race to make the technology supersede the degradation factor is the intelligence of human being. So that intelligent activity will definitely require the input from the geological and geographical sciences. So all this data collection, data generation, that we are quite competent because of the advanced technology as is being invoked. So therefore, for the people who have assembled here, my personal submission is that probably this is the time that we can expect from them to that kind of modeling where some kind of predictive analytics will be there, that with unpatterned changes in climate, if it is not, I don't know, but nobody has anyone really went through this kind of thing. Has anyone linked it with the human activity? So simply by saying that this is degrading and then we should take this kind of measure, this is one part, but that is a temporary solution. The permanent solution will come from the scientists, and then that's why I am very, very happy that the coining of this particular conference, that shows the skill of our organizer, that the Earth observation technology vis-a-vis environmental management. So this is the point of issue. This is the major point. So the actual point you have attacked. So that's why I congratulate you. I express my pride that I am being able to be associated with you in some form or other. By saying this, I wish all the researchers in here to be quite active and be interactive. And that is the purpose of this thing. Once again, I repeat that valediction is a mark of initiation and introduction. So let us initiate the collaborative research. Let us initiate the sharing of ideas, a vibrant community. From here, you let us create, and that vibrant community may give some kind of disruptive research. So that is by saying all these things, and by thanking all the participants, specifically those who presented their papers, and the people who are present right till now, whole day. So I must congratulate them. I must thank them. By saying this, I finish my deliberation. Thank you all.
Thank you, sir. Thank you for giving such beautiful words regarding our conferences. Now, taking forward today's event, I would take this opportunity to invite our Honorable President, Ma'am, Dr. Ritu Galotra, Ma'am, to take the address of the event.
Very good
evening,
evening,
ma'am.
everyone. So, like this one-day virtual international conference on Earth observation technologies for environmental management, which is held today, as the aim of the conference was to bring together the leading academicians, scientists, industrial experts, researchers, students from India and around the world to exchange and share their experiences, research findings of all aspects of climate change, sustainable development, natural resource management, green, smart cities, disaster risk management, reduction, and many more topics to meet at one place. I think that the aim has been quite well justified, and I congratulate the team C3W on this, particularly Dr. Shruti, Dr. Suraj Singh, all the other members of the team. They have really put up a very wonderful show. It has been very meticulously planned. I have been seeing the kind of these speakers who have spoken till the morning, the kind of the papers that have been presented, and also the kind of the audience that has been connecting to the event from throughout the world, and also the important kind of the deliberation that has taken up. I believe the recommendations of this event will be really technically very useful to the future policy making. And I once again congratulate the whole team. I thanks Dr. Malay Banerjee for sparing his precious time. He has been all the way together with the team and has been listening to the speakers and been very very meticulously. He has concluded all the things together. Also, I would look forward for the report of the event whenever possible by the organizers to put together. And I would surely love to see more such events and such kind of conferences in the future. And once again, I thank all the participants, all the senior speakers who have come over at this platform with Suresh Kumar University to benefit our research scholars and students. All the people who have presented papers, I congratulate them for their research, and thank you so much. And I sincerely once again extend my appreciation to the wonderful teamwork that has been put together. Thank you so much. Best of luck.
Thank you, ma'am. And now, as we have come to the end of today's event, I would like to invite Dr. Suraj Kumar Singh, Coordinator of Center for Sustainable Development, for the vote of thanks.
Very thanks to Honorable President Ma'am, Dr. Ritu Ma'am, and my regards to Dr. Professor Malay Kumar Banerjee sir, that from their busy schedules they have come and they have seen our sessions. So I'll be briefing a brief summary of the report that we have done today. So today we conducted a one-day international work conference on Earth observation technologies for environmental management, where Ms. Priyanka Roy, Assistant Professor C3WR, served as an anchor for this event. The introductory speech was delivered by Dr. Shruti Kanga, Coordinate C3WR, where she briefly defined about the university along with the academic and research activities of C3WR. A brief information about the number of participants, number of research abstract, number of participating university institute across the globe, and other technical details were delivered by myself. I am the coordinator, Center for Sustainable Development. Thereafter, the inaugural speech was done by Honorable Chief Mentor Dr. Sudhanshu SGVU, where he talked about the advancement of remote sensing technique that is critically used for various kinds of scientific and social studies related to climate change, sustainable development, and we have to start various initiating leading to sustainable livelihood. Thereafter, we were very fortunate that our Honorable Chairman, Sir Shri Sunil Sharma, Sir, provided a address where he focused on disseminating and promoting the advanced knowledge by providing institutional research and extension facilities to provide academic and industrial pool for the necessary atmosphere, facilities, infrastructure to overcome the problem of sustainable issues in current scenario. We were very fortunate for his continuous blessings throughout our academic life in Center for Climate Change and Center for Sustainable Development, Grand Vihar University. After the inaugural function, the technical sessions were started. The first talk was delivered by Professor J.K. Gaur, who is the governing body member, Wetland International South Asia, New India. He discussed the use of geospatial technology in conservation and management of wetlands. He describes the values of wetlands and ecosystem. The major threats faced by wetland ecosystem, including urbanization, conversion of agricultural land, global climate change, have been covered in his talking. Thereafter, the second talk was delivered by Professor Nitin Kumar Tripathi, School of Engineering and Technology, Asian Institute of Technology, Thailand. His talk was focused on the impacts of climate anomalies on crop yield modeling. He described the role of NDVI, Normalized Different Vegetation Index, that we know, then LAI, Leaf Area Index, and its relationship with the temperature. The climatic anomalies are having a major impact on various kinds of crop production. Thereafter, the third talk was delivered by Dr. Lakshmikant Sharma, who is Associate Professor, Department of Environmental Science, Central University, Rajasthan, India. His talk was focused on the role of Earth observation technologies for the management of environment. It discussed in detail about the fundamentals of space imaging methods for various applications in the field of Earth resource management. Thereafter, the fourth talk was delivered by Dr. Kirti Abhishek, who is also an associate professor in Department of Civil and Environmental Engineering, Birla Institute of Technology, Meshra, Ranchi, Jharkhand, where he discussed the use of geospatial technology in monitoring of wetland ecosystem. He analyzed the vegetation data for calculating density, frequency, and abundance in wetland monitoring. The fifth speaker was Dr. Praveen Kumar Rai, who is also an associate professor in Department of Geography, KMC, Language University, Lucknow, India. His talk was mainly focused on the role of geospatial technology in climate change and environmental monitoring. He also discussed various environmental satellites in solving the environmental challenges for sustainable management. The sixth talk was delivered by Dr. Professor Sleha Jamal, Associate Professor, Department of Geography, Aligarh Muslim University, New Delhi, India. The main focus of her talk was on the role of remote sensing and GIS in environmental research. She discussed the utilization of various Earth observation data sets for analyzing lakes in Kashmir Valley. That was very interesting. And the seventh talk was delivered by Ms. Maila Parasu, Scientific Research Officer from Department of Institute of Geography, Romanian Academy, Romania. Her talk was about the changes in the dynamics and demographic structures of Romanian rural space. She discussed various parameters such as labor renewal index, general activity rate for analyzing the geographic demographic changes over the period of 1992 to 2020. After that, there was a technical section where total 15 papers were presented online on various topics of forestry, urbanization, civil engineering, environmental engineering. We had a gathering of more than 400 participants from various institutions of India and across the world. There was a great enthusiasm shown by the participant. The topic discussed in this virtual conference is of great interest to the researcher, academicians, urban planners, environmentalists, policymakers, scientists, ecologists working in the field of environmental management and monitoring. Last but not the least, I would like to thank my faculty members, starting from Dr. Shruti Kanga, Dr. Varun Narayan Mishra, Dr. Pranay, who were continuously handling the online portal, how to share it, guiding the audience, guiding the participation. Mr. Rishabh, who was continuously into the creation of certification, designing creation of abstract volume. So, and finally, Miss Priyanka, who leaded from the front for introduction of various speakers and presenters. So it was all cumulative, all teamwork that led to a huge success of this international conference. And with this, I seek the permission from Malay Kumar Banerjee sir and President ma'am to close this international conference. And at last but not the least, I thank all the participants, all the presenters, all the speakers who gave their precious time and precious knowledge to our students, and finally our students were benefited from your esteemed knowledge. With this, I'll end my talk and vote of thanks. Thank you for listening.
Thank you all. Very good.
Thank you.
Yes. Dr. Nicola. I missed the name. Dr. Nicola is a good friend of mine, so I missed his name. But a special thanks to Nicola for chairing the entire session of the valuable inputs that the students and the participants were felicitated. Thanks, Dr. Nicola. He's from Croatia.
Thank you.
Thank you.
Thank you, Dr. Surai and Dr. Shruti. It was wonderful conference, and the rest of you in organizational board. It was I really enjoyed this morning. Best regards, and hopefully in the future we will collaborate more.
Yeah, thank you, sir. It's our privilege. Priyanka, please seek the permission from sir, and we can close the session for today.
Photo?
Sir.
Yeah, we can have a group photo.
Yeah, I would request all of you to turn on the camera before I turn the request for the session off.
Please turn on your camera so that we can have a group photograph. All the participants, please turn on your cameras so that we can capture the movements together. Mr. Rishabh, please take the photographs.
Done, sir.
Done. Okay, clear.
Sir, I seek the permission to close this session officially.
Yeah.
So I call the session officially closed.
Okay. Have a great day.
Have a good day.
Thank you, Shruti.
Thank you, sir. Thank you all of you for coming.
Thank you, Pranay.
Thank you very much.
Thank you. Yeah. Hello. Bye.